The Vim User Manual by Bram Moolenaar. About the manuals. This chapter introduces the manuals available with Vim. Read this to know the conditions under which the commands are explained. Chapter 1, Part 1. The Vim documentation consists of two parts. 1. The User Manual, task-oriented explanations from simple to complex, reads from start to end like a book. 2. The Reference Manual, precise description of how everything in Vim works. The notation used in these manuals is explained here. Notation. Jumping around. The text contains hyperlinks between the two parts, allowing you to quickly jump between the description of an editing task and a precise explanation of the commands and options used for it. Use these two commands. Press Ctrl close right bracket to jump to a subject under the cursor, or press Ctrl O to jump back. Repeat to go further back. Many links are in vertical bars, like this, bars. The bars themselves may be hidden or invisible, see below. An option name like number, a command in double quotes like :right, and any other word can also be used as a link. Try it out. Move the cursor to Ctrl close right bracket and press Ctrl right bracket on it. Other subjects can be found with the :help command, see help.txt. The bars and stars are usually hidden with the conceal feature. They also use HL-ignore, using the same color for the text as the background. You can make them visible with :set conceal level equals 0, :high link help bar normal, or :high link help star normal. Chapter 1, Part 2. Vim installed. To create an empty Vim RC, do :call make_dir open parentheses standard path open parentheses single quotation config single quote close parentheses comma single quote p single quote close parentheses. Then do :exe single quote edit single quote standard path open parentheses single quote config single quote close parentheses period single quote /init.vim single quote, and then do :write. For more info, see Vim RC. Chapter 1, Part 3. Using the Vim tutor. Instead of reading the text, boring, you can use :tutor to learn your first Vim commands. This is a 30-minute tutorial that teaches the most basic Vim functionality hands-on. To start the tutorial, execute :tutor from within Neovim. The tutorial will lead you from that point. Have fun. Chapter 1, Part 4. Copyright. The Vim User Manual and Reference Manual are copyright 1988 by Bram Moolenaar. This material may be distributed only subject to the terms and conditions set forth in the Open Publication License, version 1.0 or later. The latest version is presently available at opencontent.org/openpub. People who contribute to the manuals must agree with the above copyright notice. Parts of the user manual come from the book Vi Improved-Vim by Steve Uerlein, published by New Riders Publishing, ISBN 073-571-0015. The open publication license applies to this book. Only selected parts are included, and these have been modified. Example, by removing the pictures, updating the text from Vim 6.0 and later, fixing mistakes. The omission of the From Book tag does not mean that the text does not come from the book. Many thanks to Steve Uerlein and New Riders for creating this book and publishing it under the OPL. It has been a great help while writing the user manual, not only by providing literal text, but also by setting the tone and style. If you make money through selling the manuals, you are strongly encouraged to donate part of the profit to help AIDS victims in Uganda. See ICCF. The first steps in Vim. This chapter provides just enough information to edit a file with Vim. Not well or fast, but you can edit. Take some time to practice with these commands. They form the base for what follows. Chapter 2, Part 1. Running Vim for the first time. To start Neovim, enter this command, neovim file.txt. On Unix, you can type this at any command prompt. If you are running Microsoft Windows, open a command prompt and enter the command. In either case, Vim starts editing a file called file.txt. Because this is a new file, you get a blank window. This is what your screen will look like. The tilde lines indicate lines not in the file. In other words, when Vim runs out of file to display, it displays tilde lines. At the bottom of the screen, a message line indicates the file is named file.txt and shows that you are creating a new file. The message information is temporary and other information overrides it. Chapter 2, Part 2, Inserting Text. The Vim editor is a modal editor. That means that the editor behaves differently depending on which mode you are in. The two basic modes are called normal mode and insert mode. In normal mode, the characters you type are commands. In insert mode, the characters are inserted as text. Since you have just started Vim, it will be in normal mode. To start insert mode, you type the I command, I for insert. Then you can enter the text. It will be inserted into the file. Do not worry if you make mistakes. You can correct them later. To enter the following programmer's limerick, this is what you type. I, a very intelligent turtle, found programming Unix a hurdle. After typing turtle, you press the enter key to start a new line. Finally, you press the escape key to stop insert mode and go back to normal mode. You now have two lines of text in your Vim window. A very intelligent turtle found programming Unix a hurdle. What is the mode? To be able to see what mode you are in, type this command, :set show mode. You will notice that when typing the colon, Vim moves the cursor to the last line of the window. That's where you type colon commands, commands that start with a colon. Finish this command by pressing the enter key. All commands that start with a colon are finished this way. Now, if you type the I command, Vim will display insert at the bottom of the window. This indicates you are in insert mode. If you press escape to go back to normal mode, the last line will be made blank. Getting out of trouble. One of the problems for Vim novices is mode confusion, which is caused by forgetting which mode you are in or by accidentally typing a command that switches modes. To get back to normal mode, no matter what mode you are in, press the escape key. Sometimes you have to press it twice. If Vim beeps back at you, you already are in normal mode. Chapter 2, Part 3, Moving Around. After you return to normal mode, you can move around by using these keys: H for left, J for down, K for up, and L for right. At first, it may appear that these commands were chosen at random. After all, who ever heard of using L for right? But actually, there is a very good reason for these choices. Moving the cursor is the most common thing you do in an editor, and these keys are on the home row of your right hand. In other words, these commands are placed where you can type them the fastest, especially when you type with 10 fingers. Note: you can also move the cursor by using the arrow keys. If you do, however, you greatly slow down your editing because to press the arrow keys, you must move your hand from the text keys to the arrow keys. Considering that you might be doing it hundreds of times an hour, this can take a significant amount of time. Also, there are keyboards which do not have arrow keys or which locate them in unusual places. Therefore, knowing the use of the H, J, K, L keys helps in those situations. One way to remember these commands is that H is on the left, L is on the right, and J points down. In the picture, you have K at the top, L on the right, J at the bottom, and H on the left. The best way to learn these commands is by using them. Use the I command to insert some more lines of text. Then use the H, J, K, L keys to move around and insert a word somewhere. Don't forget to press escape to go back to normal mode. :tutor is also a nice way to learn by doing. For Japanese users, Hiroshi Iwatani suggests using this. For K, think of Komsomolsk. For right or L, think Los Angeles. For down or J, think Java, the island, not the programming language. And for left or H, think Huanho, the Yellow River. Chapter 2, Part 4, Deleting Characters. To delete a character, move the cursor over it and type X. This is a throwback to the old days of the typewriter, when you deleted things by typing XXXX over them. Move the cursor to the beginning of the first line, for example, and type XXXXXXX, 7 X's, to delete a very space. The result should look like this. Intelligent Turtle found programming Unix a hurdle. Now you can insert new text, for example by typing I, a young, escape. This begins an insert, the I, inserts the words a young, and exits insert mode, the final escape. The result, a young intelligent turtle found programming Unix a hurdle. Deleting a line. To delete a whole line, use the dd command. The following line will then move up to fill the gap. Found programming Unix a hurdle. Deleting a line break. In Vim you can join two lines together, which means that the line break between them is deleted. The J command does this. Take these two lines, a young intelligent turtle. Move the cursor to the first line and press J, and you get a young intelligent turtle. Chapter 2 Part 5. Undo and redo. Suppose you delete too much. Well, you can type it in again, but an easier way exists. The lowercase u command undoes the last edit. Take a look at this in action. After using dd to delete the first line, lowercase u brings it back. Another one. Move the cursor to the capital A in the first line. A young intelligent turtle. Now type XXXXXXX to delete a young. The result is as follows. Intelligent turtle. The U to undo the last delete. That delete removed the G, so the undo restores the character. G intelligent turtle. The next lowercase u command restores the next to last character deleted. NG intelligent turtle. The next lowercase u command gives you the uppercase U, and so on. Redo. If you undo too many times, you can press Ctrl R for redo to reverse the preceding command. In other words, it undoes the undo. To see this in action, press Ctrl R twice. The character A and the space after it disappear, and you get young intelligent turtle. There is a special version of the undo command, the U undo line command. The undo line command undoes all the changes made on the last line that was edited. Typing this command twice cancelled the preceding U. So if you have a very intelligent turtle, and you delete very, and then you delete turtle, you are left with a intelligent. You can then restore the line with U, and you get a very intelligent turtle. And then you can undo the U with lowercase u to get back to a intelligent. The U command is a change by itself, which the lowercase u command undoes, and Ctrl R redos. This might be a bit confusing. Don't worry. With lowercase u and Ctrl R, you can go to any of the situations you had. More about that in section 32.2. Chapter 2 Part 6. Other editing commands. Vim has a large number of commands to change the text. See Q_in and below. Here are a few often used ones. Appending. The I command inserts a character before the character under the cursor. That works fine, but what happens if you want to add stuff to the end of the line? For that, you need to insert text after the cursor. This is done with the A or append command. For example, to change the line, and that's not saying much for the turtle, to, and that's not saying much for the turtle, 3 exclamation marks. Move the cursor over to the dot at the end of the line. Then type X to delete the period. The cursor is now positioned at the end of the line on the E in turtle. Now type A 3 exclamation marks and then hit escape to append 3 exclamation points after the E in turtle. And you get, and that's not saying much for the turtle, 3 exclamation marks. Opening up a new line. The lowercase o command creates a new empty line below the cursor and puts Vim in insert mode. Then you can type the text for the new line. Suppose the cursor is somewhere in the first of these two lines. A very intelligent turtle found programming Unix a hurdle. If you now use the lowercase o command and type new text, "Oh, that liked using Vim escape," the result is a very intelligent turtle that liked using Vim found programming Unix a hurdle. The capital O command, uppercase, opens a line above the cursor. Using a count. Suppose you want to move up 9 lines. You can type K multiple times, or you can enter the command 9K. In fact, you can precede many commands with a number. Earlier in this chapter, for instance, you added 3 exclamation points at the end of a line by typing A, 3 exclamation marks, and then escape. Another way to do this is to use the command 3A exclamation mark escape. The count of 3 tells the command that follows to triple its effect. Similarly, to delete 3 characters, use the command 3x. The count always comes before the command it applies to. Chapter 2, Part 7, Getting Out. To exit, use the capital ZZ command. This command writes the file and exits. Unlike many other editors, Vim does not automatically make a backup file. If you type ZZ, your changes are committed and there is no turning back. You can configure the Vim editor to produce backup files. See Chapter 7, Part 4. Discarding changes. Sometimes you will make a sequence of changes and suddenly realize you were better off before you started. Not to worry, Vim has a quit and throw things away command. It is :q bang. Don't forget to press enter to finish the command. For those of you interested in the details, the 3 parts of this command are the colon, which enters command line mode, the q command, which tells the editor to quit, and the override command modifier, bang. The override command modifier is needed because Vim is reluctant to throw away changes. If you were to just type :q, Vim will display an error message and refuse to exit. E37, no write since last change. Use bang to override. By specifying the override, you are in effect telling Vim, I know that what I'm doing looks stupid, but I really want to do this. If you want to continue editing with Vim, the :e bang command reloads the original version of the file. Chapter 2, Part 8, Finding Help. Everything you always wanted to know can be found in the Vim help files. Don't be afraid to ask. If you know what you are looking for, it is usually easier to search for it using the help system instead of using Google, because the subjects follow a certain style guide. Also, the help has the advantage of belonging to your particular Vim version. You won't see help for commands added later. These would not work for you. To get generic help, use this command, :help. You could also use the first function key, F1. If your keyboard has a help key, it might work as well. If you don't supply a subject, :help displays the general help window. The creators of Vim did something very clever or very lazy with the help system. They made the help window a normal editing window. You can use all the normal Vim commands to move through the help information. Therefore, H, J, K, and L move left, down, up, and right. To get out of the help window, use the same command you used to get out of the editor, ZZ. This will only close the help window, not exit Vim. As you read the help text, you will notice some text enclosed in vertical bars, for example, help. This indicates a hyperlink. If you position the cursor anywhere between the bars and press Ctrl close right bracket, jump to tag, the help system takes you to the indicated subject. For reasons not discussed here, the Vim terminology for a hyperlink is tag. So Ctrl right bracket jumps to the location of the tag given by the word under the cursor. After a few jumps, you might want to go back. Ctrl T, pop tag, takes you back to the preceding position. Ctrl O, jump to older position, also works nicely here. At the top of the help screen, there is the notation help.txt. This name between asterisk characters is used by the help system to define a tag or hyperlink destination. See Chapter 29 Part 1 for details about using tags. To get help on a given subject, use the following command: :help subject. To get help on the X command, for example, use the following: :help X. To find out how to delete text, use this command: :help deleting. To get a complete index of all Vim commands, use the following command: :help index. When you need to get help for a control character command, for example Control A, you need to spell it with the prefix Control dash. So you would do :help Control -A or CTRL-A. The Vim editor has many different modes. By default, the help system displays the normal mode commands. For example, the following command displays help for the normal mode Control-H command: :help Control-H. To identify other modes, use a mode prefix. If you want the help for the insert mode version of a command, use I_. For Control-H, this gives you the following command: :help I_Control-H. When you start the Vim editor, you can use several command line arguments. These all begin with a dash. To find what the -t argument does, for example, use the command :help -t. The Vim editor has a number of options that enable you to configure and customize the editor. If you want help for an option, you need to enclose it in single quotation marks. To find out what the number option does, for example, use the following command: :help number. The table with all mode prefixes can be found below: help-summary. Special keys are enclosed in angle brackets. To find help on the up arrow key in insert mode, for instance, use this command: :help I_less_up>. If you see an error message that you don't understand, for example E37, no write since last change, use bang to override. You can use the error ID at the start to find help about it: :help E37. Summary. 1. Use Ctrl-D after typing a topic, and let Vim show all available topics, or press Tab to complete: :help sum tab. More information on how to use the help, do :help help help. 2. Follow the links in bars to related help. You can go from the detailed help to the user documentation, which describes certain commands more from a user perspective and less detailed. Example after: :help pattern.txt. You can see the user guide topics chapter 3 part 9 and user27.txt in the introduction. 3. Options are enclosed in single apostrophes. To go to the help topic for the list option, do :help single quote list single quote. If you only know you are looking for a certain option, you can also do :help options.txt. To open the help page, which describes all option handling, and then search using regular expressions, example text width. Certain options have their own namespace. Example: :help CPO -less than letter greater than. For the corresponding flag of the CP option settings, substitute letter by a specific flag. Example: :help CPO -, and for the GUI options flags, do :help go -less than letter greater than. 4. Normal mode commands do not have a prefix. To go to the help page for the GT command, do :help GT. 5. Insert mode commands start with I_. Help for deleting a word: :help I_Control-W. 6. Visual mode commands start with V_. Help for jumping to the other side of the visual area, do :help V_O. 7. Command line editing and arguments start with C_. Help for using the command argument %, :help C_%. 8. X commands always start with colon, so to go to the :S command, help, do :help :S. 9. Commands specifically for debugging start with greater than. To go to the help for the cont debug command, do :help greater than cont. 10. Key combinations. They usually start with a single letter, indicating the mode for which they can be used. Example: :help I_Control-X takes you to the family of Control-X commands for insert mode, which can be used to auto-complete different things. Note that certain keys will always be written the same. Example: Control will always be CTRL. For normal mode commands, there is no prefix and the topic is available at :h control dash less than letter greater than. Example, :help control dash W. In contrast, :help C underscore control dash R will describe what the control R does when entering commands in the command line, and :help V underscore control dash A talks about incrementing numbers in visual mode, and :help G underscore control dash A talks about the G less than C dash A greater than command. Example, you have to press G, then control A. Here the G stands for the normal command G, which always expects a second key before doing something similar to the commands starting with Z. 11. regexp items always start with /. So to get help for the \plus quantifier in Vim regexes, do :help /+. If you need to know everything about regular expressions, start reading at :help pattern.txt. 12. Registers always start with quote. To find out about the special : register, do :help quote:. 13. Vim script is available at :help vimeval.txt. Certain aspects of the language are available at :h expr-x, where x is a single letter. Example, :help expr-bang will take you to the topic describing the bang or not operator for Vim script. Also important is :help function-list to find a short description of all functions available. Help topics for Vim script functions always include the open-close parentheses. So :help append open parentheses close parentheses talks about the append Vim script function rather than how to append text in the current buffer. 14. Mappings are talked about in the help page :help map.txt. Use :help map mode-i to find out about the :imap command. Also use :map-topic to find out about certain subtopics particular for mappings. Example, :help map-local for buffer local mappings, or :help map-bar for how the pipe is handled in mappings. 15. Command definitions are talked about in :help command topic, so use :help command-bar to find out about the bang argument for custom commands. 16. Window management commands always start with Control-W, so you find the corresponding help at :h Control-W underscore letter. Example, :help Control-W underscore P for moving the previous accessed window. You can also access :help windows.txt and read your way through it if you are looking for window handling commands. 17. Use :help grep to search in all help pages, and also of any installed plugins. See :help grep for how to use it. To search for a topic, do :help grep topic. This takes you to the first match. To go to the next one, do :c next, as in the letter C and then next in one word. All matches are available in the quick fix window, which can be opened with :c open, as in the letter C and then open in one word. Move around to the match you like and press enter to jump to that help. 18. The user manual. This describes help topics for beginners in a rather friendly way. Start at usr_toc.txt to find the table of contents, as you might have guessed. :help usc_toc.txt. Skim over the contents to find interesting topics. The digraphs and entering special characters items are in chapter 24, so to go to that particular help page, do :help usr_24.txt. Also, if you want to access a certain chapter in help, the chapter number can be accessed directly like this, :help 10.1, which goes to chapter 10 part 1 in usr_10.txt and talks about recording macros. 19. Highlighting groups. Always start with HL-group name. Example, :help HL-warning MSG talks about the warning MSG highlighting group. 20. Syntax highlighting is namespaced to :syn-topic. Example, :help syn syn-conceal talks about the conceal argument for the :syn command. 21. Quick fix commands usually start with :C, while location list commands usually start with :L. 22. Auto command events can be found by their name: :help buff win leave. To see all possible events, do :help events. 23. Command line switches also start with dash. So for the help of the -f command switch of Vim use, do :help -f. 24. Lua language and Neovim's Lua standard library are available at :help lua.txt. Guide to using Lua and Neovim is available at :help lua-guide.txt. Lua 5.1 reference manual is available at :help lua-ref.txt. 25. Documentation for included file type specific functionality is usually available in the form ft-less-than file type greater than -less-than functionality greater than. So :help ft-c-syntax talks about the C syntax file and the option it provides. Sometimes additional sections for omni completion, :help ft-php-omni, or file type plugins, :help ft-tex-plugin are available. 26. Error and warning codes can be looked up directly in the help. So :help E297 takes you exactly to the description of the swap error message, and :help W10 talks about the warning changing a read-only file. Sometimes, however, those error codes are not described, but rather are listed at the vim command that usually causes this. So :help E128 takes you to the :function command. 27. Documentation for packages distributed with Vim have the form package-less-than name greater than. So :help package-term debug will bring you to the help section for the included term debug plugin and how to enable it. Moving around. Before you can insert or delete text, the cursor has to be moved to the right place. Vim has a large number of commands to position the cursor. This chapter shows you how to use the most important ones. You can find a list of these commands below, q_lr. Chapter 3, Part 1, Word Movement. To move the cursor forward one word, use the W command. Like most Vim commands, you can use a numeric prefix to move past multiple words. For example, FreeW moves 3 words. This figure shows how it works, starting at the position marked with X. This is a line with sample text. So if we start on this and we do W, it will jump to is, and then to A, and then to line, and then if we do like a multiplier then W, it will jump that many words. Notice the W moves to the start of the next word if it already is at the start of a word. The B command moves backward to the start of the previous word. So if we are on the word example, we can do B or even 2B to jump back. There is also the E command that moves to the next end of a word, and GE, which moves to the previous end of a word. So if we were on line, we could do GE, and that would take us to the end of the previous word, or we can do E to go to the end of the next word, and we can even do 2E to jump 2 words. If you are at the last word of a line, the W command will take you to the first word in the next line. Thus you can use this to move through a paragraph, much faster than using L. B does the same in the other direction. A word ends at a non-word character, such as a period, dash, or close parentheses. To change what Vim considers to be a word, see the is keyword option. If you try this out in the help directory, is keyword needs to be reset for the examples to work. Set is keyword ampersand. It is also possible to move by whitespace separated words. This is not a word in the normal sense, that's why the uppercase is used. The commands for moving by uppercase words are also uppercase, as this figure shows. With this mix of lowercase and uppercase commands, you can quickly move forward and backward through a paragraph. Chapter 3, Part 2, Moving to the start or end of a line. The $sign command moves the cursor to the end of a line. If your keyboard has an end key, it will do the same thing. The caret command moves the first non-blank character of the line. the 0 command moves to the very first character of a line, and the home key does the same thing. In a picture, a period indicates a space. The periods indicate blanks here, or blank space. The $sign command takes a count, like most movement commands, but moving to the end of the line several times doesn't make sense. Therefore, it causes the editor to move to the end of another line. For example, $sign moves you to the end of the first line, the one you're on, $2 at the end of the next line, and so on. The 0 command doesn't take a count argument because the 0 would be part of the count. Unexpectedly, using a count with caret doesn't have any effect. Chapter 3, Part 3, Moving to a Character. One of the most useful movement commands is the single character search command. The command fx searches forward in the line for the single character x. Hint, F stands for find. For example, you are at the beginning of the following line. Suppose you want to go to the H for human. Just execute the command fh and the cursor will be positioned over the H. So just like that. You can do fy to jump there. So to err as human, to really foul up, you need the computer. This also shows that the command fy moves to the end of the word really. You can specify a count, therefore you can go to the L of foul with freefl. So if you were here and you did freefl, you would go to the end of foul. The capital F command searches to the left. So if you were here and you did capital F and then H, you would jump to the start of human into err as human. The tx command works like the fx command, except it stops one character before the searched character. Hint, T stands for 2. The backward version of this command is capital TX. So if we were on the word really and we did capital TH, we would jump to U, which is after H. And then if we went back here and we did TN, we would jump before the N. And because the first one it was backwards, it jumped, the cursor ended or stopped after what we were hunting for. These 4 commands can be repeated with semicolon. Period repeats in the other direction. The cursor is never moved to another line, not even when the sentence continues. Sometimes you will start a search only to realize that you have typed the wrong command. You type F to search backward, for example, only to realize that you really meant capital F. To abort a search, press escape. So F escape is an aborted forward search and doesn't do anything. Note, escape cancels most operations, not just searches. Chapter 3, Part 4. Matching up parentheses. When writing a program, you often end up with nested parentheses constructs. Then the % command is very handy. It moves to the matching paren. If the cursor is on a open parentheses, it will move to the matching close parentheses. If it's on a close parentheses, it will move to the matching open parentheses. So for example here, if we do %, it will jump between these, and here it will jump between these. This also works for square brackets and curly bracket pairs. This can be defined with the match pairs option. When the cursor is not on a useful character, % will search forward to find one. Thus, if the cursor is at the start of the line of the previous example, % will search forward and find the first open parentheses. Then it moves to its match. So if we were here, we could just do this. And it just found, right, so we were here. There we go. Other ways to move around code can be found in usr_29.txt. Chapter 3, Part 5. If you are a C or C++ programmer, you are familiar with error messages such as the following: prog-c:33:j, undeclared first use in this function. This tells you that you might want to fix something on line 33. So how do you find line 33? One way is to do 9999k to go to the top of the file and 32j to go down 32 lines. It is not a good way, but it works. A much better way of doing things is to use the capital G command. With a count, this command positions you at the given line number. For example, 33 capital G puts you on line 33. For a better way of going through a compiler's error list, see user_30.txt for information on the :make command. With no argument, capital G positions you at the end of the file. A quick way to go to the start of a file, use lowercase gg. One capital G will do the same, but it is a tiny bit more typing. So if we were here and we did 7G in a normal file, it would take us here. If we then did capital G, it will take us all the way to the end. And if we did lowercase gg, it will take us to the start. Another way to move to a line is using the percentage command with a count. For example, 50% moves you halfway through the file, and 90% goes to near the end. The previous assumes that you want to move to a line in the file, no matter if it's currently visible or not. What if you want to move to one of the lines you can see? This figure shows the 3 commands you can use. That's capital H, capital M, and capital L. Hints: capital H stands for home, capital M stands for middle, and capital L for last. Alternatively, capital H for high, capital M for middle, and capital L for low. Chapter 3, Part 6. Telling where you are. To see where you are in a file, there are 3 ways. 1. Use the Ctrl-G command. You get a message like this, assuming the ruler option is off. Double quote usr_03.txt, double quote, line 233 of 650 --35% col 45-52. This shows the name of the file you are editing, the line number where the cursor is, the total number of lines, the percentage of the way through the file, and the column of the cursor. Sometimes you will see a split column number. For example, column 2-9. This indicates that the cursor is positioned on the second character, but because character 1 is a tab, occupying 8 spaces worth of columns, the screen column is 9. 2. Set the number option. This will display a line number in front of every line. Set number. To switch this off again, set no number. Since number is a Boolean option, prepending no to its name has the effect of switching it off. A Boolean option has only these 2 values. It is either on or off. Vim has many options. Besides the Boolean ones, there are options with a numerical value and string options. You will see examples of this where they are used. 3. Set the ruler option. This will display the cursor position in the lower right corner of the Vim window. Set ruler. Using the ruler option has the advantage that it doesn't take much room, thus there is more space for your text. Chapter 3, Part 7. Scrolling around. The Ctrl-U command scrolls down half a screen of text. Think of looking through a viewing window at the text and moving this window up by half the height of the window. Thus the window moves up over the text, which is backward in the file. Don't worry if you have a little trouble remembering which end is up. Most users have the same problem. The Ctrl-D command moves the viewing window down half a screen in the file, thus scrolls the text up half a screen. To scroll one line at a time, use Ctrl-E to scroll up, and Ctrl-Y to scroll down. Think of Ctrl-E to give you one line extra. If you use Microsoft Windows compatible key mappings, Ctrl-Y will redo a change instead of scroll. To scroll forward by a whole screen, except for 2 lines, use Ctrl-F. To scroll backwards, use Ctrl-B. These should be easy to remember, F for forwards and B for backwards. A common issue is that after moving down many lines with J, your cursor is at the bottom of the screen. You would like to see the context of the line with the cursor. That's done with the lowercase zz command. So if you were here and you did ZZ, it will take you to the middle line, like that. The lowercase zt command puts the cursor line at the top, lowercase zb at the bottom. There are a few more scrolling commands. See capital Q underscore lowercase sc. To always keep a few lines of context around the cursor, use the scroll off option. Chapter 3, Part 8. Simple searches. To search for a string, use the /string command. To find the word include, for example, use the command /include. So like this. You will notice that when you type the /, the cursor jumps to the last line of the Vim window, like with colon commands. That is where you type the word. You can press the backspace key, back arrow or BS, to make corrections. use the left and right cursor keys when necessary. Pressing Enter executes the command. Editor's note. So what it means is that if you're searching for something here, so for example if you search for executes, you can't use J and K because that would mess up the search. You'd have to use the arrows and backspace in order to modify that. Note: the characters period, asterisk, square brackets, caret, percentage, // backslash, question mark, tilde, $sign have special meanings. If you want to use them in a search, you must put a backslash in front of them. See below. To find the next occurrence of the same string, use the lowercase n command. Use this to find the first #include after the cursor. /# include. And then type lowercase n several times. There you go. You will move to each #include in the text. You can also use a count if you know which match you want. Thus, free lowercase n finds the third match. You can also use a count with /. For /the goes to the fourth match of the. The question mark command works like / but searches backwards. So question mark word will find this. The uppercase N command repeats the last search the opposite direction. Thus using uppercase N after a / command searches backwards, using capital case N after question mark searches forwards. Ignoring case. Normally you have to type exactly what you want to find. If you don't care about upper or lower case in a word, set the ignore case option. Set ignore case. If you now search for word, it will also match word with an uppercase W and fully uppercase word. To match case again, do set no ignore case. History. Suppose you do 3 searches. /1, /2, /3. Now let's start searching by typing a simple / without pressing enter. If you press up the cursor key, Vim puts 3 on the command line. Let me show you. So if we do 1, 2, 3. So if we do this and then that, pressing enter at this point searches for 3. If you do not press enter but press up instead, Vim changes the prompt to 2. Another press in the up moves you to 1. You can also use the down cursor key to move through the history of search commands in the other direction. If you know what a previously used pattern starts with, and you want to use it again, type that character before pressing up. With the previous example, if you type O and then up, then Vim will put the /1 on the command line. The commands starting with : also have a history that allows you to recall a previous command and execute it again. These two histories are separate. Searching for a word in the text. Suppose you see the word the long function name in the text and you want to find the next occurrence of it. You could type / the long function name, but that's a lot of typing. And when you make a mistake, Vim won't find it. There is an easier way. Position the cursor on the word and use the asterisk command. Vim will grab the word under the cursor and use it as the search string. The # or hashtag command does the same in the other direction. You can prepend a count, free asterisks, searches for the third occurrence of the word under the cursor. Searching for whole words. If you type /the, it will also match there. To only find words that end in the, use /the backslash and then greater than. The \greater than item has a special marker that only matches at the end of a word. Similarly, \less than only matches at the beginning of a word. Thus, to search for the word the only, do // less than the greater than. This does not match there or soothe. Notice that the asterisks in # commands use the start of word and end of word markers to only find whole words. You can use G* and G# to match partial words. Highlighting matches. While editing a program, you see a variable called nr. You want to check where it's used. You could move the cursor to nr and use # command, and press lowercase n to go along all the matches. Vim will highlight all matches. That is a very good way to see where the variable is used without the need to type commands. To switch this off, do :set no HL search. Then you need to switch it on again if you want to use it for the next search command, :set HL search. If you only want to remove the highlighting, use this command, :no HL search. This doesn't reset the option, instead it disables the highlighting. As soon as you execute a search command, the highlighting will be used again, also for the lowercase n and uppercase n commands. Tuning searches. There are a few options that change how searching works. These are the essential ones, :set no wrap scan. This stops the search at the end of the file, or when you are searching backwards, it stops the search at the start of the file. The wrap scan option is on by default, thus searching wraps around the end of the file, :set no inc search. This disables the display of the matches while you are still typing your search. Intermezzo. If you like one of the options mentioned before and set it each time you use Vim, you can put the command in your Vim startup file. Edit the file, for example, with :edit.config/nvim/init.vim. Then add a line with the command to set the option just like you typed it in Vim. Example, go :set HL search escape. Capital G moves to the end of the file, lowercase o starts a new line where you type the :set command. You end insert mode with escape, then write and close the file with capital ZZ. If you now start Vim again, the HL search option will already be set. Chapter 3, Part 9. Simple Search Patterns. The Vim editor uses regular expressions to specify what to search for. Regular expressions are an extremely powerful and compact way to specify a search pattern. Unfortunately, this power comes at a price, because regular expressions are a bit tricky to specify. In this section, we mention only a few essential ones. More about search patterns and commands can be found in Chapter 27, usr_27.txt. You can find the full explanation here. Pattern. Beginning and end of a line. The caret character matches the beginning of a line. On an English US keyboard, you find it above the 6. The pattern include matches the word include anywhere on the line, but the pattern caret include matches the word include only if it is at the beginning of a line. The $sign character matches the end of a line. Therefore, was $sign matches the word was only if it is at the end of a line. Let's mark the places where /the matches in this example line with X's. The solder holding one of the chips melted and the. So it would match the first the second the between of and chips, and the last the. Using /the $sign, we find this match, where it only matches the last the. And with /caret the, it only matches the first the in the sentence. You can try searching with /caret the $sign. It will only match a single line consisting entirely of the. White space does matter here. Thus, if a line contains a space after the word, like the space, the pattern will not match. Matching any single character. The dot character matches any existing character. For example, the pattern c.m matches a string whose first character is a c, whose second character is anything, and whose third character is m. So for example, in the sentence, we use a computer that became the coming winter, it will match the com in computer, it will match the com in computer, the cam in became, and of course the third option in the second to last word. Editor's note, that's a very bizarre choice of words. Matching special characters. If you really want to match a dot, you must avoid its special meaning by putting a backslash before it. If you search for ter period, you will find these matches. In the sentence, we use a computer that became the coming winter, you would match ter space at the end of computer and ter period at the end of winter. Searching for ter backslash period only finds a second match. Editor's note. The reason why it finds the second match is because by doing the backslash before the period, we escape it. And therefore, instead of searching for TER followed by any one character, by escaping the period, we're saying, hey, I want you to specifically look for a period. In which case the word winter period matches, whereas computer space does not. Chapter 3, Part 10, Using Marks. When you make a jump to a position with the capital G command, Vim remembers the position from before this jump. This position is called a mark. To go back where you came from, use this command, backtick backtick. This is a backtick or open single quote character. If you use the same command a second time, you will jump back again. That's because the backtick command is a jump itself, and the position from before this jump is remembered. Generally, every time you do a command that can move the cursor further than within the same line, this is called a jump. This includes the search commands / and lowercase n. It doesn't matter how far away the match is, but not the character searches with fx and tx or the word movements w and e. Also, j and k are not considered to be a jump even when you use a count to make them move the cursor quite a long way away. The backtick command jumps back and forth between 2 points. The Ctrl-O command jumps to older positions, hint O for older. Ctrl-I then jumps back to newer positions, hint, for many common keyboard layouts, I is just next to O. Consider this sequence of commands: 33 capital G, then / the with a capital T, and then Ctrl-O. You first jump to line 33, then search for a line that starts with the, then with Ctrl-O you jump back to line 33. Another Ctrl-O takes you back to where you started. If you now use Ctrl-I, you jump to line 33 again. Enter the match for the with another Ctrl-I. Note, Ctrl-I is the same as tab. The :jumps command gives you a list of positions you jumped to. The entry which you use last is marked with a greater than. Named marks. Vim enables you to place your own marks in the text. The command "ma" marks the place under the cursor as mark A. You can place 26 marks, A through Z, in your text. You can't use them, it's just the position that Vim remembers. To go to a mark, use the command mark, where mark is the mark letter. Thus, to move to a mark, you do backtick A. The command :mark or apostrophe mark moves you to the beginning of the line containing the mark. This differs from backtick mark command, which also moves you to the marked column. The marks can be very useful when working on two related parts in a file. Suppose you have some text near the start of the file you need to look at, while working on some text near the end of the file. Move to the text at the start and place the S start mark there, lowercase m, lowercase s. Then move to the text you want to work on and put the E for end mark there, lowercase m, lowercase e. Now you can move around, and when you want to look at the start of the file, you can use this to jump there, (S). Then you can use () to jump back to where you were, or (E) to jump to the text you were working on at the end. There is nothing special about using S for start and E for end. They are just easy to remember. You can use this command to get a list of marks, marks. You will notice a few special marks. These include the cursor position before doing a jump, the cursor position when last editing the file, open square bracket, start of the last change, close square bracket, end of the last change. Making small changes. This chapter shows you several ways of making corrections and moving text around. It teaches you the 3 basic ways to change text: operator motion, visual mode, and text objects. Chapter 4, Part 1, Operators and Motions. In Chapter 2 you learned the X command to delete a single character, and using a count, 4x deletes 4 characters. The DW command deletes a word. You may recognize the W command as the move word command. In fact, the D command may be followed by any motion command, and it deletes from the current location to the place where the cursor winds up. The for-w command, for example, moves the cursor over 4 words. The d4w command deletes 4 words. So if we have the sentence "to err is human, to really foul up you need a computer," if we started on "to really foul up" and we did d4w, we would remove "to really foul up" and we would be left with "to err is human, period, you need a computer, period." Vim only deletes up to the position where the motion takes the cursor. That's because Vim knows that you probably don't want to delete the first character of a word. If you want to use the E command to move to the end of the word, Vim guesses that you do want to include that last character. So if we start on space "you need a computer" and we do D2E, we will be left with "to err is human, period, a computer, period." Whether the character under the cursor is included depends on the command you use to move to that character. The reference manual calls this exclusive when the character isn't included and inclusive when it is. The $sign command moves to the end of a line. The $sign command deletes from the cursor to the end of the line. This is an inclusive motion, thus the last character of the line is included in the delete operation. So if we start on period, a computer, period, and we do $sign, we will simply be left with "to err is human," and that's it. There is a pattern here, operator motion. You first type an operator command. For example, D is the delete operator. Then you type a motion command like for L or W. This way you can operate on any text you can move over. Chapter 4, Part 2, Changing Text. Another operator is C for change. It acts just like the D operator, except it leaves you in insert mode. For example, CW changes a word, or more specifically, it deletes a word and then puts you in insert mode. So if we start on and we do C2WBE and escape, we remove is and then space, and we insert BE. So we're left with "to be human." This C2WBE escape contains these bits. C is the change operator. 2W moves 2 words, they are deleted and insert mode started. BE, we insert this text, and then escape to go back to normal mode. You will have noticed something strange. The space before human isn't deleted. There is a saying that for every problem there is an answer that is simple, clear, and wrong. That is the case with the example used here for the CW command. The C operator works just like the D operator with the exception CW. It actually works like CE, change to end of word. Thus the space after the word isn't included. This is an exception that dates back to the old VI. Since many people are used to it now, the inconsistency has remained in Vim. More changes. Like DD deletes a whole line, CC changes a whole line. It keeps the existing indent though, which is the leading white space. Just like D$ deletes until the end of the line, C$ changes until the end of the line. It's like doing D$ to delete the text and then A to start insert mode and append new text. Shortcuts. Some operator motion commands are used so often that they have been given a single letter command. Lowercase x stands for DL, delete character under the cursor. Capital X stands for DH, delete character left of the cursor. Capital D stands for D$, delete to end of the line. Capital C stands for C$, change to end of the line. Lowercase s stands for CL, change one character. Capital S stands for CC, or change a whole line. Where to put the count? The commands freedw and dfreew delete 3 words. If you want to get really picky about things, the first command, freedw, deletes 1 word 3 times. The command dfreew deletes 3 words once. This is a difference without a distinction. You can actually put in 2 counts, however. For example, freed2w deletes 2 words repeated 3 times for a total of 6 words. Replacing with 1 character. The lowercase r command is not an operator. It waits for you to type a character and will replace the character under the cursor with it. You could do the same with CL or with the lowercase s command, but with lowercase r you don't have to press escape to go back out of insert mode. So if we did lowercase r and uppercase T here, we would change lowercase t to an uppercase T. If we did lowercase r, lowercase t here, we'd replace the r with a T. And if we did lowercase r, lowercase w here, we would replace the word grong with a wrong. So we would get there is something wrong here. Using a count with lowercase r causes that many characters to be replaced with the same character. Example, if we were on wrong and we did 5rx, that would replace the word wrong with x's, 5 of them specifically. To replace a character with a line break, use lowercase r enter. This deletes one character and inserts a line break. Using a count here only applies to the number of characters deleted. 4r enter would replace 4 characters with one line break. Chapter 4, Part 3, Repeating a Change. Editor's note. I'm just having a bit of hell milk. I mean, I don't know about you, but hell is the only place that I want to get my milk from. Chapter 4, Part 3, Repeating a Change. The period command is one of the simplest yet powerful commands in Vim. It repeats the last change. For instance, suppose you are editing a HTML file and want to delete all the b tags. You position the cursor on the first less than and delete the less than b greater than with the command df greater than. You then go to the less of the next / b greater than and delete it using the period command. The period command executes the last change command, in this case df greater than. To delete another tag, position the cursor on the less than and use the period command. So in this case, if we start here, f would find the first instance of less than, df would delete to the greater than, then the next f less than would find this, and then we would just repeat, which would just delete until here. And then we go here, and again we will delete until here. The period command works for all changes you make except for lowercase u or undo, Ctrl R redo, and commands that start with a colon. Another example. You want to change the word 4 to 5. It appears several times in your text. You can do this quickly with this sequence of commands. /4 enter, find the first string 4. CW5 escape, change the word to 5. N, find the next 4. Period, repeat the change to 5. N, find the next 4. Period, repeat the change, etc. Chapter 4, Part 4, Visual Mode. To delete simple items, the operator motion changes work quite well, but often it's not so easy to decide which command will move over the text you want to change. Then you can use Visual Mode. You start Visual Mode by pressing V. You move the cursor over the text you want to work on. While you do this, the text is highlighted. Finally, type the operator command. For example, to delete from the middle of a word to the middle of another, so let's say you started in the middle of examination, we would do VE, LLLL, and then if we did D, that would delete the highlighted bit, and we would be left with this is an example of visual mode. When doing this, you don't really have to count how many times you have to press L to end up in the right position. You can immediately see what text will be deleted when you press D. If at any time you decide you don't want to do anything with the highlighted text, just press Escape and visual mode will stop without doing anything. Selecting lines. If you want to work on whole lines, use capital V to start visual mode. You will see right away that the whole line is highlighted, without moving around. When you move left or right, nothing changes. When you jump up or down, the selection is extended whole lines at a time. For example, select 3 lines with capital VJJ. So there you go. This is how it works. Selecting blocks. If you want to work on a rectangular block of characters, use Ctrl V to start visual mode. This is very useful when working on tables. To delete the middle Q2 column, move the cursor to the Q of Q2. Press Ctrl V to start blockwise visual mode. Now move the cursor 3 lines down with 3J and to the next word with W. You can see the first characters of the last column is included. To exclude it, use H. Now press D and the middle column is gone. Go into the other side. If you have selected some text in visual mode and discover that you need to change the other end of the selection, use the lowercase o command, hint, O for other end. The cursor will go to the other end and you can move the cursor to change where the selection starts. Pressing O again brings you back to the other end. When using blockwise selection, you have 4 corners. Lowercase o only takes you to one of the other corners diagonally. Use uppercase O to move to the other corner in the same line. Note that lowercase o and uppercase O in visual mode work very differently from normal mode, where they open a new line below or above the cursor. Chapter 4, Part 5, Moving Text. When you delete something with D, X, or another command, the text is saved. You can paste it back by using the lowercase p command. The Vim name for this is put. Editor's note. Even though put is the official name, most people will refer to it as paste. But just bear in mind that technically the name is put. Take a look at how this works. First, you will delete an entire line by putting the cursor on the line you want to delete and typing DD. Now you move the cursor to where you want to put the line and use the P for put command. The line is inserted on the line below the cursor. Because you deleted an entire line, the P command placed the text line below the cursor. If you delete part of a line, a word for instance, the P command puts it just after the cursor. So if we have the sentence, some more boring try text to out commands. If we do DW on try, that would remove the word try, and we would be left with some more boring text to out commands. And so if we do WEL and then we paste here, we would paste the word try that we deleted earlier right there, and so we would have some more boring text to try out commands. More on putting. The capital P command puts text like lowercase p, but before the cursor. When you deleted a whole line with DD, capital P will put it back above the cursor. When you deleted a word with DW, capital P will put it back just before the cursor. You can repeat putting as many times as you like. The same text will be used. You can use a count with lowercase p and uppercase p. The text will be repeated as many times as specified with the count, thus DD and then 3p puts 3 copies of the same deleted line. Swapping 2 characters. Frequently when you are typing, your fingers get ahead of your brain, or the other way around. The result is a typo such as TEH for the. Vim makes it easy to correct such problems. Just put the cursor on the E of TEH and execute the command XP. This works as follows. X deletes the character E and places it in a register. P puts the text after the cursor, which is after the H. So if we were here and we did an X, here, we'd be left with TH, and then if we did a P here, we'd end with D. Editor's note. This example isn't great. Most people would not edit this way, especially not advanced users. For pretty much any word that you want to modify, you would want to do CIW, and that would change inside word. So if you had TEH, if you just did CIW, that would delete the word, put you in insert mode, and then you would just type in the. And that would be much easier for most people. The manual will cover this later, but I just wanted to let you know that that's the case. Chapter 4, Part 6, Copying Text. To copy text from one place to another, you could delete it, use U to undo the deletion, and then P to put it somewhere else. There is an easier way, yanking. The Y operator copies text into a register, then a P command can be used to put it. Yanking is just a Vim name for copying. The C letter was already used for the change operator, and Y was still available. Calling this operator yank made it easier to remember to use the Y key. Since Y is an operator, you can use YW to yank a word, A count is possible as usual. To yank two words, use Y2W. Notice that YW includes the white space after a word. If you don't want this, use YE. The YY command yanks a whole line, just like DD deletes a whole line. Capital Y was originally equivalent to yank the entire line, as opposed to capital D, which is delete to end of the line. Capital Y has thus been remapped to mean yank to end of the line, to make it consistent with the behavior of capital D. Mappings will be covered in later chapters. Chapter 4 Part 7, using the clipboard. If you are using the GUI version of Vim, gvim, you can find the copy item in the edit menu. First select some text with visual mode, then use the edit copy menu item. The selected text is now copied to the clipboard. You can paste the text in other programs, in Vim itself too. If you have copied text in the clipboard in another application, you can paste it in Vim with the edit paste menu item. This works in normal mode and insert mode. In visual mode, the selected text is replaced with the pasted text. The cut menu item deletes the text before it's put on the clipboard. The copy, cut, and paste items are also available in the pop-up menu, only when there is a pop-up menu, of course. If your Vim has a toolbar, you can also find these items there. If you are not using the GUI, or if you don't like using a menu, you have to use another way. You use the normal Y, yank, and P, put commands, but prepend asterisk, double quote star before it. To copy a line to the clipboard, you do double quote asterisk YY. To put the text from the clipboard back into the text, you do double quote asterisk P. This only works on versions of Vim that include clipboard support. More about the clipboard can be found in section 9.3 and here, clipboard. Chapter 4 Part 8, Text Objects. If the cursor is in the middle of a word and you want to delete that word, you need to move it back to its start before you can do the W. There is a simpler way to do this, DAW. This is some example text, and if you do DAW on example, you are left with this is some text. The D of the AW is the delete operator. AW is a text object. Hint, AW stands for a word. Thus DAW is delete a word. To be precise, the white space after the word is also deleted, or the white space before the word if at the end of the line. Editor's note. Typically when you watch online tutorials, you will notice that people refer to the A as around, so most people would say delete around word or change around word, instead of delete a word. Using text objects is the third way to make changes in Vim. We already had operator motion in visual mode, now we add operator text object. It is very similar to operator motion, but instead of operating on the text between the cursor position, before and after a movement command, the text object is used as a whole. It doesn't matter where in the object the cursor was. To change a whole sentence, use CIS. Take this text. Hello there, this is an example, just some text. Move to the start of the second line on is un. Now use CIS. You would be left with hello there, just some text. The cursor is in between the blanks in the first line. Now you type the new sentence, another line. So you'd be left with hello there, another line, just some text. This is because if you are here and you do change IS, that's change inside sentence. So you're removing this is an example, even though the this is on the previous line. It doesn't matter because it's part of the sentence. So what you'd be left with is the cursor would essentially be here because of that. CIS consists of the C, change operator, and the is text object. This stands for in a sentence. There is also the AS, a sentence object. The difference is that AS includes the white space after the sentence, and IS doesn't. If you would delete a sentence, you want to delete the white space at the same time, thus use the AS. If you want to type new text, the white space can remain, thus you use CIS. You can also use text objects in visual mode. It will include the text object in the visual selection. Visual mode continues, thus you can do this several times. For example, start visual mode with lowercase v and select a sentence with AS. Now, you can repeat AS to include more sentences. Finally, you use an operator to do something with the selected sentences. You can find a list of text objects here. Text-objects. Chapter 4, Part 9. Replace mode. The R command causes Vim to enter replace mode. In this mode, each character you type replaces the one under the cursor. This continues until you type escape. In this example, you start replace mode on the first T of text. So you would do R interesting period escape, and you would be left with this is interesting. You may have noticed that this command replaced 5 characters in the line with 12 others. The R command automatically extends the line if it runs out of characters to replace. It will not continue on the next line. You can switch between insert mode and replace mode with the insert key. When you use BS for backspace to make a correction, you will notice that the old text is put back. Thus it works like an undo command for the previously typed character. Chapter 4, Part 10. Conclusion. The operators, movement commands, and text objects give you the possibility to make lots of combinations. Now that you know how they work, you can use N operators with M movement commands to make N times M commands. You can find a list of operators here. Operator. For example, there are many other ways to delete pieces of text. Here are a few common ones. Lowercase x, delete character under the cursor, short for DL. Uppercase X, delete character before the cursor, short for DH. Capital D, delete from cursor to end of line, short for $. DW, delete from cursor to the next start of word. DB, delete from cursor to previous start of word. DIW, delete word under the cursor, excluding whitespace. DAW, delete word under the cursor, including whitespace. G, delete until the end of the file. DGG, delete until the start of the file. If you use C instead of D, they become change commands, and with Y, you yank the text, and so forth. There are a few common commands to make changes that didn't fit somewhere else. Tilde, change case of the character under the cursor, and move the cursor to the next character. This is not an operator unless tilde OP is set, thus you can't use it with a motion command. It does work in visual mode where it changes case for all the selected text. I, start insert mode after moving the cursor to the first non-blank in the line. A, start insert mode after moving the cursor to the end of the line. Set your settings. Vim can be tuned to work like you want it to. This chapter shows you how to make Vim start with options set to different values. Add plugins to extend Vim's capabilities, or define your own macros. Chapter 5, Part 1, the vimrc file. You probably got tired of typing commands that you use very often. To start Vim with all your favorite option settings and mappings, you write them in what is called the init.vim file. Vim executes the commands in this file when it starts up. If you already have a init.vim file, example, when your sysadmin has one set up for you, you can edit it this way, :edit, all caps myvimrc. If you don't have a vimrc file yet, see init.vim to find out where you can create a vimrc file. This file is always used and is recommended. On Unix and macOS, in .config/nvim/init.vim, on Windows in appdata/local/nvim/init.vim. The vimrc file can contain all the commands that you type after a colon. The simplest ones are for setting options. For example, if you want Vim to always start with the ignore case option on, add this line to your vimrc file. Set ignore case. For this new line to take effect, you need to exit Vim and start it again. Later you will learn how to do this without exiting Vim. This chapter only explains the most basic items, For more information on how to write a Vim script file, go to usr_41.txt. Chapter 5 Part 2 Example vimrc Contents. In the first chapter was explained how to create a vimrc file. You do :exe single quote edit single quote standard path open parentheses single quote config single quote close parentheses period single quote /init.vim single quote. In this section we will explain the various commands that can be specified in this file. This will give you hints about how to set up your own preferences. Not everything will be explained though. Use the :help command to find out more. Set backup. This tells Vim to keep a backup copy of a file when overwriting it. The backup file will have the same name as the original file with tilde added. See Chapter 7 Part 4. Set history equals 50. Keep 50 commands and 50 search patterns in the history. Use another number if you want to remember fewer or more lines. Map capital Q, lowercase g, lowercase q. This defines a key mapping. More about this in the next section. This defines the capital Q command to do formatting with the GQ operator. Otherwise, the capital Q command repeats the last recorded register. v_no_remap _g y::exe double quote grep /_ period escape open parentheses at double quote period single quote // single quote close parentheses period double quote **c**h double quote less than cr greater than. This mapping yanks the visually selected text and searches for it in C files. This is a complicated mapping. You can see that mappings can be used to do quite complicated things. Still, it is just a sequence of commands that are executed like you typed them. Editor's note. If you're wondering, the CR at the end, it just means carriage return or enter. File type plugin indent on. This switches on 3 very clever mechanisms. 1. File type detection. Whenever you start editing a file, Vim will try to figure out what kind of file this is. When you edit main.c, Vim will see the .c extension and recognize this as a C file type. When you edit a file that starts with double quote #bang /bin /sh, Vim will recognize it as a sh file type. The file type detection is used for syntax highlighting and the other 2 items below. See file types. 2. Using file type plugin files. Many different file types are edited with different options. For example, when you edit a C file, it's very useful to set the C indent option to automatically indent the lines. These commonly useful option settings are included with Vim in file type plugins. You can also add your own, see write-filetype-plugin. 3. Using indent files. When editing programs, the indent of a file can often be computed automatically. Vim comes with these indent rules for a number of file types. See :filetype-indent-on and indent_expr. Another auto command. This time it is used after reading any file. The complicated stuff after it checks if the single quote double quote mark is defined, and jumps to it if so. It doesn't do that for a commit or rebase message, which are likely a different one than last time, and when using xxd1 to filter and edit binary files, which transforms input files back and forth, causing them to have dual nature, so to speak. See also using -xxd. The \/ at the start of a file is used to continue the command from the previous line. That avoids a line getting very long. See line-continuation. This only works in a Vim script file, not when typing commands at the command line. Command diff orig vert new pipe set bt equal no file pipe r++ edit pound pipe 0d underscore pipe diff this / pipe wincmd p pipe diff this. This adds the :diff orig command. Use this in a modified buffer to see the differences with the file it was loaded from. See diff and :diff orig. Set no lang remap. Prevent that the lang map option applies to characters that result from a mapping. If set default, this may break plugins, but it's backward compatible. See Lang Remap. Chapter 5 Part 3 Simple Mappings. A mapping enables you to bind a set of Vim commands to a single key. Suppose, for example, that you need to surround certain words with curly braces. In other words, you need to change a word such as amount into curly brace amount curly brace. With the :map command, you can tell Vim that the F5 key does this job. The command is as follows: :map less than F5 greater than I open curly brace less than escape greater than EA close curly brace less than escape greater than. Note, when entering this command you must enter less than F5 greater than by typing 4 characters. Similarly, less than escape or ESC greater than is not entered by pressing the escape key but by typing 5 characters. Watch out for this difference when reading the manual. Let's break this down. Less than F5 greater than. The F5 function key. This is the trigger key that causes the command to be executed as the key is pressed. I open curly brace less than ESC greater than. Insert the open curly brace character. The escape key ends insert mode. E. Move to the end of the word. A close curly brace less than ESC greater than. Append the close curly brace to the end, and then go into normal mode. After you execute the :map command, all you have to do to put curly braces around a word is to put the cursor on the first character and press F5. In this example, the trigger is a single key. It can be any string, but when you use an existing Vim command, the command will no longer be available. You better avoid that. One key that can be used with mappings is the \. Since you probably want to define more than one mapping, add another character. You could map \p to add parentheses around the word, and \c to add curly braces. For example, :map \p I open parentheses less than escape greater than EA close parentheses less than escape greater than. Then :map \c I open curly brace less than escape greater than EA close curly brace less than escape greater than. You need to type the \ and the p quickly after another so that Vim knows they belong together. The :map command with no arguments lists your current mappings, at least the ones for normal mode. More about mappings in section 40.1. Chapter 5 Part 4 Adding a package. You may use :pack_add to enable packages on demand. This is useful for plugins you want to enable only sometimes. To enable example_package, use the following command: pack_add example_package. That's all. Now you can find help about this plugin. :help example_package. This works because when :pack_add loaded the plugin, it also added the package directory in runtime path, so that the help file can be found. A package is a set of files that you can add to Vim. There are 2 kinds of packages: optional and automatically loaded on startup. You can find packages on the internet in various places. It usually comes as an archive or as a repository. For an archive, you can follow these steps. 1. Create the package directory. Make the -p .local/share/nvim/site/pack/fancy. Fancy can be any name of your liking. Use one that describes the package. 2. Unpack the archive in that directory. This assumes the top directory in the archive is start. cd ~.local/shared/nvim/site/pack/fancy. Then unzip /tmp/fancy.zip. If the archive layout is different, make sure that you end up with a path like this: ~.local/share/nvim/site/pack/fancy/start/fancy text/plugin/fancy.vim. Here, fancy text is the name of the package. It can be anything else. Adding NoHL search package. Load the plugin with this command: pack_add NoHL search. Automatically execute :noHL search after update time or getting into insert mode. Thus, assuming default update time, HL search would be suspended/turned off after 4 seconds of idle time. To disable the effect of the plugin after it has been loaded, do au bang no hl search. More information about packages can be found here. Packages. Chapter 5, Part 5. Adding a plugin. Vim's functionality can be extended by adding plugins. A plugin is nothing more than a Vim script file that is loaded automatically when Vim starts. You can add a plugin very easily by dropping it in your plugin directory. There are two types of plugins: global plugin, used for all kinds of files, and file type plugin, only used for a specific type of file. The global plugin will be discussed first, then the file type ones. Add-file type-plugin. Global plugins. When you start Vim, it will automatically load a number of global plugins. You don't have to do anything for this. They add functionality that most people will want to use, but which was implemented as a Vim script instead of being compiled into Vim. You can find them listed in the help index standard-plugin-list. Also see load-plugins. You can add a global plugin to add functionality that will always be present when you use Vim. There are only two steps for adding a global plugin. 1. Get a copy of the plugin. 2. Drop it in the right directory. Getting a global plugin. Where can you find plugins? Some are always loaded. You can see them in the directory $vim runtime/plugin. Some come with Vim. You can find them in the directory $vim runtime/macros and its subdirectories and under $vim/vim files/pack/dist/opt. You can download them from the net. There is a large collection on vim.org. They are sometimes posted on a Vim mail list, and you could write one yourself. See write-plugin. Using a global plugin. First, read the text in the plugin itself to check for any special conditions. Then copy the file to your plugin directory. On Unix, there would be ~.local/share/nvim/site/plugin. Example for Unix, assuming you didn't have a plugin directory yet, you can do make-dir-p ~.local/share/nvim/site/plugin and then cp/temp/yourplugin.vim to ~.local/share/nvim/site/plugin. That's all. Now you can use the commands defined in this plugin. Instead of putting plugins directly into the plugin/directory, you may better organize them by putting them into subdirectories under plugin/. As an example, consider using ~.local/share/nvim/site/plugin/perl/**vim for all your Perl plugins. File type plugins. The Vim distribution comes with a set of plugins for different file types that you can start using with this command: :file type plugin on. That's all. See vimrc-file type. If you are missing a plugin for a file type you are using, or you found a better one, you can add it. There are two steps for adding a file type plugin. 1. Get a copy of the plugin. 2. Drop it in the right directory. Getting a file type plugin. You can find them in the same places as the global plugins. Watch out if the type of file is mentioned, then you know if the plugin is a global or a file type one. The scripts in $vim runtime/macros are global ones. The file type plugins are in $vim runtime/ft plugin. Using a file type plugin. You can add a file type plugin by dropping it in the right directory. The name of this directory is in the same directory mentioned above for global plugins, but the last part is ft plugin. Suppose you have found a plugin for the stuff file type and you are on Unix. Then you can move this file to the ft plugin directory. So you do make-dir-p ~.local/share/nvim/site/ft plugin. You would then do mv the file to ~.local/share/nvim/site/ft plugin/stuff.vim. If that file already exists, you already have a plugin for stuff. You might want to check if the existing plugin doesn't conflict with the one you are adding. If it's okay, you can give the new one another name. So you would do mv the file to ~.local/share/nvim/site/ft plugin/stuff_2.vim. The underscore is used to separate the name of the file type from the rest, which can be anything. If you use otherstuff.vim, it wouldn't work. It would be loaded for the otherstuff file type. The generic names for the file type plugins are filetype.vim, filetype_name.vim, and filetype/name.vim. Here name can be any name that you prefer. Examples for the stuff file type on Unix: ft_plugin/stuff.vim, stuff_def.vim, stuff/header.vim. The file type part is the name of the file type the plugin is to be used for. Only files of this file type will use the settings from the plugin. The name part of the plugin file doesn't matter. You can use it to have several plugins for the same file type. Note that it must end in .vim or .lua. Further reading. File type-plugins. Documentation for the file type plugins and information about how to avoid that mappings cause problems. Load-plugins. When the global plugins are loaded during startup. ft-plugin-overrule. Overruling the settings from a global plugin. Write-plugin. How to write a plugin script. Plugin-details. For more information about using plugins or when your plugin doesn't work. New-file type. How to detect a new file type. Chapter 5 Part 6. Adding a help file. If you are lucky, the plugin you installed also comes with a help file. We will explain how to install the help file so that you can easily find help for your new plugin. Let us suppose a plugin, my-plugin, which comes with a help file in a non-standard place. It usually resides in a subfolder called doc. First, create a doc directory in one of the directories in runtime path. So you would do :bang make dir -b /local/share/nvim/site/doc. Now copy the help file to the doc directory. :bang cp my-plugin /my-plugin-doc.txt to ~.local/share/nvim/site/doc. Here comes the trick, which allows you to jump to the subjects in the new help file. Generate the local tags file with the :help tags command. :help tags ~.local/share/nvim/site/doc. You can see an entry for the local help file when you do. :help local-additions. The title lines from the local help files are automatically added to this section. There you can see which local help files have been added and jump to them through the tag. For writing a local help file, see write-local-help. Chapter 5 Part 7. The option window. If you are looking for an option that does what you want, you can search in the help files here, options. Another way is by using this command, :options. This opens a new window with a list of options with a one-line explanation. The options are grouped by subject. Move the cursor to a subject and press enter to jump there. Press enter again to jump back or use Ctrl-O. You can change the value of an option. For example, move to the displaying text subject. Then move the cursor down to this line. Set wrap, no wrap. When you hit enter, the line will change to set wrap, wrap. The option has now been switched off. Just above this line is a short description of the wrap option. Move the cursor one line up to place it in this line. Now hit enter and you jump to the full help on the wrap option. For options that take a number or string argument, you can edit the value, then press enter to apply the new value. For example, move the cursor a few lines up to this line. Set SO equals 0. Position the cursor on the 0 with $. Change it into a 5 with R5. Then press enter to apply the new value. When you now move the cursor around, you will notice that the text starts scrolling before you reach the border. This is what the scroll off option does. It specifies an offset from the window border where scrolling starts. Chapter 5 Part 8. Often used options. There are an awful lot of options. Most of them you will hardly ever use. Some of the more useful ones will be mentioned here. Don't forget you can find more help on those options with the :help command, with single quotes before and after the option name. For example, :help, single quote, wrap, single quote. In case you have messed up an option value, you can set it back to the default by putting an ampersand after the option name. Example, :set is keyword ampersand. Not wrapping lines. Vim normally wraps long lines so that you can see all of the text. Sometimes it's better to let the text continue right of the window. Then you need to scroll the text left-right to see all of a long line. Switch wrapping off with this command: :set no wrap. Vim will automatically scroll the text when you move to text that is not displayed. To see a context of 10 characters, do this: :set side scroll equals 10. This doesn't change the text in the file, only the way it is displayed. Wrapping movement commands. Most commands for moving around will stop moving at the start and end of a line. You can change that with the which wrap option. This sets it to the default value: :set which wrap equals b:(s). This allows the backspace key, when used in the first position of a line, to move the cursor to the end of the previous line, and the space key moves from the end of a line to the start of the next one. To allow the cursor keys left and right to also wrap, use this command: :set which wrap equals b:(s), less than, greater than. This is still only for normal mode. To let left and right do this in insert mode as well, do :set which wrap equals b:(s), less than, greater than, left bracket, right bracket. There are a few other flags that can be added. See which wrap. Viewing tabs. When there are tabs in a file, you cannot see where they are. To make them visible, do :set list. Now every tab is displayed as capital I. And a $sign is displayed at the end of each line, so that you can spot trailing spaces that would otherwise go unnoticed. A disadvantage is that this looks ugly when there are many tabs in a file. If you have a color terminal or are using the GUI, Vim can show the spaces and tabs as highlighted characters. Use the list chars option. :set list chars equals tab, greater than, dash, comma, trail, dash. Now every tab will be displayed as greater than, dash, 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 with more or less dashes, and trailing white spaces is dash. Looks a lot better, doesn't it? Keywords. The is keyword option specifies which characters can appear in a word. :set is keyword equals @ 48-57, _ 192-255. The @ stands for all alphabetic letters. 48 to 57 stands for ASCII characters 48 to 57, which are the numbers 0 to 9. 192 to 255 are the printable Latin characters. Sometimes you will want to include a dash in keywords, so that commands like W consider uppercase to be one word. You can do it like this: :set is keyword plus equals dash, :set is keyword equals @ 48-57, _ 192-255, dash. If you look at the new value, you will see that Vim has added a comma for you. To remove a character, use dash equals. For example, to remove the underscore, do :set is keyword dash equals underscore. Then :set is keyword equals @ 48-57, 192-255, dash. This time a comma is automatically deleted. Room for messages. When Vim starts, there is one line at the bottom that is used for messages. When a message is long, it is either truncated, thus you can only see part of it, or the text scrolls and you have to press enter to continue. You can set the CMD height option to the number of lines used for messages. Example, :set CMD height equals 3. This does mean there is less room to edit text, thus it's a compromise. Using syntax highlighting. Black and white text is boring. With colors, your file comes to life. This not only looks nice, it also speeds up your work. Change the colors used for the different sorts of text. Print your text with the colors you see on the screen. Chapter 6, Part 1. Switching it on. Syntax highlighting is enabled by default. Neovim will automatically detect the type of file and load the right syntax highlighting. Chapter 6, Part 2. Know or run colors. There can be a number of reasons why you don't see colors. Your terminal does not support colors. Vim will use bold, italic, and underlined text, but this doesn't look very nice. You probably will want to try to get a terminal with colors. Alternatively, your terminal does support colors, but Vim doesn't know this. Make sure your $term setting is correct. For example, when using an xterm that supports colors, do set env term xterm -color, or depending on your shell, do term all caps equals xterm -color semicolon export term. The terminal name must match the terminal you are using. Maybe the file type is not recognized. Vim doesn't know all file types, and sometimes it's near to impossible to tell what language a file uses. Try this command, :set file type. If the result is file type equals, then the problem is indeed that Vim doesn't know what type of file this is. You can set the type manually with :set file type equal Fortran. To see which types are available, look in the directory $vim runtime /syntax. For the GUI, you can use the syntax menu. Setting the file type can also be done with a mode line, so that the file will be highlighted each time you edit it. For example, this line can be used in a make file. Put it near the start or end of the file. #vim syntax equals make. You might know how to detect the file type yourself. Often the file name extension after the dot can be used. See new-file type for how to tell Vim to detect that file type. Maybe there is no highlighting for your file type. You could try using a similar file type by manually setting it as mentioned above. If that isn't good enough, you can write your own syntax file. See my syntax file. Or the colors could be wrong. The colored text is very hard to read. Vim guesses the background color that you are using. If it is black or another dark color, it will use light colors for text. If it is white or another light color, it will use dark colors for text. If Vim guessed wrong, the text will be hard to read. To solve this, set the background option. For a dark background, do :set background equals dark. And for a light background, do :set background equal light. Make sure you put this before the syntax enable command, otherwise the colors will already have been set. You could do syntax reset after setting background to make Vim set the default colors again. Finally, the colors are wrong when scrolling bottom to top. Vim doesn't read the whole file to parse the text. It starts parsing wherever you are viewing the file. That saves a lot of time, but sometimes the colors are wrong. A simple fix is hitting Ctrl-L or scroll back a bit and then forward again. For a real fix, see :sin-sync. Some syntax files have a way to make it look further back. See the help for the specific syntax file. For example, text.vim for the text syntax, or maybe the tech syntax. Chapter 6, Part 3. Different colors. If you don't like the default colors, you can select another color scheme. In the GUI, use the Edit/Color Scheme menu. You can also type the command, :color scheme evening. Evening is the name of the color scheme. There are several others you might want to try out. Look in the directory $vim runtime /colors. When you found the color scheme that you like, add the :color scheme command to your init.vim file. You could also write your own color scheme. This is how you do it. Select a color scheme that comes close. Copy this file to your own Vim directory. For Unix, this should work. Bang make -p ~.config/nvim/colors. Bang cp $vim runtime /colors/morning.vim to ~.config/nvim/colors/mine.vim. This is done for Vim because it knows the value of $vim runtime. 2. Edit the color scheme file. These entries are useful. cterm, attributes in a color terminal. cterm fg, foreground color in a color terminal. cterm bg, background color in a color terminal. GUI, attributes in the GUI. GUI fg, foreground color in the GUI. And GUI bg, background color in the GUI. For example, to make comments green, do :highlight, comment cterm fg equals green, GUI fg equals green. Attributes you can use for cterm and GUI are bold and underline. If you want both, use bold, underline. For details, see the :highlight command. Free. Tell Vim to always use your color scheme. Put this line in your Vim RC. Color scheme mine. If you want to see what the most often used color combinations look like, use this command, :runtime syntax /colortest.vim. You will see text in various color combinations. You can check which ones are readable and look nice. Chapter 6, Part 4. With colors or without colors. Displaying text in color takes a lot of effort. If you find the displaying too slow, you might want to disable syntax highlighting for a moment by doing :syntax clear. When editing another file, or the same one, the colors will come back. If you want to stop highlighting completely, use :syntax off. This will completely disable syntax highlighting and remove it immediately for all buffers. See :syntax-off for more details. If you want syntax highlighting only for specific files, use this, :syntax manual. This will enable the syntax highlighting but not switch it on automatically when starting to edit a buffer. To switch highlighting on for the current buffer, set the syntax option, :set syntax equals on. Chapter 6, Part 5. Further reading. USR_44.txt, your own syntax highlighted, and syntax, all the details. Editing more than one file. No matter how many files you have, you can edit them without leaving Vim. Define a list of files to work on and jump from one to the other. Copy text from one file and put it in another one. Chapter 7, Part 1. Edit another file. So far, you have to start Vim for every file you wanted to edit. There is a simpler way. To start editing another file, use this command, :edit foo.txt. You can use any file name instead of foo.txt. Vim will close the current file and open the new one. If the current file has unsaved changes, however, Vim displays an error message and does not open the new file. E37, no write since last change. Use bang to override. Note: Vim puts an error ID at the start of each error message. If you do not understand the message or what caused it, look in the help system for this ID. In this case, :help E37. At this point you have a number of alternatives. You can write the file using this command, :write, or you can force Vim to discard your changes and edit the new file, using the force or bang character, by doing :edit bang foo.txt. If you want to edit another file but not write the changes in the current file yet, you can make it hidden, :hide edit foo.txt. The text with changes is still there, but you can't see it. This is further explained in section 22.4, the buffer list. Chapter 7, Part 2, a list of files. You can start Vim to edit a sequence of files. For example, vim1.c, 2.c, 3.c. This command starts Vim and tells it that you will be editing 3 files. Vim displays just the first file. After you have done your thing in this file, to edit the next file, you use this command, :next. If you have unsaved changes in the current file, you will get an error message and the :next will not work. This is the same problem as with :edit mentioned in the previous section. To abandon the changes, do :next bang. But mostly you want to save the changes and move on to the next file. There is a special command for this, :wnext. This does the same as using 2 separate commands, :write and :next. Where am I? To see which file in the argument list you are editing, look in the window title. It should show something like 2 of 3. This means you are editing the second file out of 3 files. If you want to see the list of files, use this command, :args, ARGS. This is short for arguments. The output might look like this, 1.c, 2.c in square brackets, 3.c. These are the files you started Vim with. The one you are currently editing, 2.c, is in square brackets. Moving to other arguments. To go back one file, do :previous. This is just like the :next command, except that it moves in the other direction. Again, there is a shortcut command for when you want to write the file first, :w previous. To move to the very last file in the list, you do :last. And to move back to the first one again, do :first. There is no :w last or :w first command though. You can use a count for :next and :previous. To skip 2 files forward, do :2 next. Automatic writing. When moving around the files and making changes, you have to remember to use :write. Otherwise you will get an error message. If you are sure you always want to write modified files, you can tell Vim to automatically write them. :set auto write. When you are editing a file which you may not want to write, switch it off again by doing :set no auto write. Editing another list of files. You can redefine the list of files without the need to exit Vim and start it again. Use this command to edit 3 other files: :args 5.c, 6.c, 7.h. Or use a wildcard like it's used in the shell, :args *.txt. Vim will take you to the first file in the list. Again, if the current file has changes, you can either write the file first or use :args bang with the exclamation mark added to abandon the changes. Did you edit the last file? When you use a list of files, Vim assumes you want to edit them all. To protect you from exiting too early, you will get this error when you didn't edit the last file in the list yet. E173 46 more files to edit. If you really want to exit, just do it again. Then it will work, but not when you did other commands in between. Chapter 7 Part 3. Jumping from file to file. To quickly jump between 2 files, press Ctrl-. On English US keyboards, the caret is above the 6 key. Example: :args 1.c, 2.c, 3.c. You are now in 1.c. Do :next. Now you are in 2.c. Now use Ctrl-. to go back to 1.c. Another Ctrl-, and you are back in 2.c. Another Ctrl-, and you are in 1.c again. If you now do :next, you are in 3.c. Notice that the Ctrl-. command does not change the idea of where you are in the list of files. Only commands like :next and :previous do that. The file you were previously editing is called the alternate file. When you just started Vim, Ctrl-. will not work since there isn't a previous file. Predefined marks. After jumping to another file, you can use 2 predefined marks which are very useful. !:; this takes you to the position where the cursor was when you left the file. Another mark that is remembered is the position where you made the last change. !:; suppose you are editing the file 1.txt. Somewhere halfway through the file, you use X to delete a character. Then you go to the last line with G and write the file with :w. You edit several other files and then use :edit 1.txt to come back to 1.txt. If you now use !:; Vim jumps to the last line of the file. Using !:; takes you to the position where you deleted the character. Even when you move around in the file, !:; and !:; will take you to the remembered position, at least until you make another change or leave the file. File marks. In section 3.10 was explained how you can place a mark in a file with mx and jump to that position with !x. That works with one file. If you edit another file and place marks there, these are specific for that file. Thus each file has its own set of marks. They are local to the file. So far we were using marks with a lowercase letter. There are also marks with an uppercase letter. These are global, they can be used from any file. For example, suppose that we are editing the file foo.txt. Go to halfway down the file, 50%, and place the F mark there, F for foo. You do this by doing 50% lowercase m uppercase f. Now edit the file bar.txt and place the B mark, B for bar. At its last line, you do G lowercase m B. Now you can use the single quote F command to jump back to halfway of foo.txt, or edit yet another file, type single quote B, and jump to the end of bar.txt. The file marks are remembered until they are placed somewhere else. Thus you can place the mark, do hours of editing, and still be able to jump back to that mark. It's often useful to think of a simple connection between the mark letter and where it is placed. For example, use the uppercase H mark in a header file, uppercase M in a make file, and uppercase C in a C code file. To see where a specific mark is, give an argument to the :marks command. So do :marks M. You can also give several arguments, such as :marks and then MCP in all caps. Don't forget that you can use Ctrl-O and Ctrl-I to jump to older and newer positions without placing marks there. Chapter 7 Part 4 Backup Files. Usually Vim does not produce a backup file. If you want to have one, all you need to do is execute the following command: :set backup. The name of the backup file is the original file with a tilde added to the end. If your file is named data.txt, for example, the backup file name is data.txt tilde. If you do not like the fact that the backup files end with tilde, you can change the extension by doing :set backup ext equals .bak. This will use data.txt.bak instead of data.txt tilde. Another option that matters here is backup dir. It specifies where the backup file is written. The default to write the backup in the same directory as the original file will mostly be the right thing. Note: when the backup option isn't set but the write backup is, Vim will still create a backup file. However, it is deleted as soon as writing the file was completed successfully. This function is a safety against losing your original file when writing fails in some way. Disk full is the most common cause. Being hit by lightning might be another, although less common. Keeping the original file. If you are editing source files, you might want to keep the original before you make any changes, but the backup file will be overwritten each time you write the file. Thus it only contains the previous version, not the first one. To make Vim keep the original file, set the patch mode option. This specifies the extensions used for the first backup of a changed file. Usually you should do this: :set patch mode equals .orig. When you now edit the file data.txt for the first time, make changes and write the file. Vim will keep a copy of the unchanged file under the name data.txt.orig. If you make further changes to the file, Vim will notice that data.txt.orig already exists and leave it alone. Further backup files will then be called data.txt tilde or whatever you specified with backup ext. If you leave patch mode empty, that is the default, the original file will not be kept. Editor's note: a simpler way to do this is just to use git, and then you won't have to worry about making sure that the original hasn't been overwritten. Your version control will pretty much just be managed by git. Chapter 7 Part 5 Copy text between files. This explains how to copy text from one file to another. Let's start with a simple example. Edit the file that contains the text you want to copy. Move the cursor to the start of the text and press v. This starts visual mode. Now move the cursor to the end of the text and press y. This yanks or copies the selected text. To copy the above paragraph, you could do :edit this file /this with a capital T, then $y. Now edit the file you want to put the text in, move the cursor to the character where you want the text to appear after. Use P to put the text there. :edit other file /there, and then P. Of course, you can use many other commands to yank the text. For example, to select whole lines, start visual mode with capital V, or use Ctrl-V to select a rectangular block, or use YY to yank a single line, YAW to yank a word, etc. The :P command puts the text after the cursor. Use capital P to put the text before the cursor. Notice that Vim remembers if you yanked a whole line or a block and puts it back that way. Using registers. When you want to copy several pieces of text from one file to another, having to switch between the files and writing the target files takes a lot of time. To avoid this, copy each file of text to its own register. A register is a place where Vim stores text. Here we will use the registers named A to Z, later you will find out that there are others. Let's copy a sentence to the F register, F for first. You do double quote FYAS. The YAS command yanks a sentence like before. It's the double quote F that tells Vim the text should be placed in the F register. This must come just before the yank command. Now yank 3 whole lines to the L register, L for line. Double quote L3YY. The count could be before the double quote L just as well. To yank a block of text to the B for block register, do Ctrl V JJWW double quote BY. Notice that the register specifies double quote B is just before the Y command. This is required. If you would have put it before the W command, it would not have worked. Now you have 3 pieces of text in the F, L, and B registers. Edit another file, move around, and place the text where you want it. Double quote FP. Again, the register specification double quote F comes before the P command. You can put the registers in any order, and the text stays in the register until you yank something else into it. Thus you can put it as many times as you like. When you delete text, you can also specify a register. Use this to move several pieces of text around. For example, to delete a word and write it in the W register, do double quote WDAW. Again, the register specification comes before the delete command D. Appending to a file. When collecting lines of text into one file, you can use this command: :write > log file. This will write the text of the current file to the end of log file. Thus it is appended. This avoids that you have to copy the lines, edit the log file, and put them there. Thus you save 2 steps. But you can only append to the end of a file. To append only a few lines, select them in visual mode before typing :write. In Chapter 10 you will learn other ways to select a range of lines. Chapter 7 Part 6 Viewing a file. Sometimes you only want to see what a file contains without the intention to ever write it back. There is the risk that you type :W without thinking and overwrite the original file anyway. To avoid this, edit the file read-only. To start Vim in read-only mode, use this command: vim-R file. On Unix, this command should do the same thing: view file. You are now editing file in read-only mode. When you try using :W, you will get an error message and the file won't be written. When you try to make a change to the file, Vim will give you a warning: W10, warning, changing a read-only file. The change will be done though. This allows for formatting the file, for example, to be able to read it easily. If you make changes to a file and forgot that it was read-only, you can still write it, and debang to the write command to force writing. If you really want to forbid making changes in a file, do this: vim-M file. Now every attempt to change the text will fail. The help files are like this, for example. If you try to make a change, you get this error message: E21 cannot make changes, modifiable is off. You could use the M argument to set up Vim to work in a viewer mode. This is only voluntary though, since these commands will remove the protection: :set modifiable, :set write. Chapter 7 Part 7 Changing the file name. A clever way to start editing a new file is by using an existing file that contains most of what you need. For example, you start writing a new program to move a file. You know that you already have a program that copies a file, thus you start with :edit copy.c. You can delete the stuff you don't need. Now you need to save the file under a new name. The :save as command can be used for this. :save as move.c. Vim will write the file under the given name and edit that file. Thus the next time you do :write, it will write move.c. Copy.c remains unmodified. When you want to change the name of the file you are editing but don't want to write the file, you can use this command: :file move.c. Vim will mark the file as not edited. This means that Vim knows this is not the file you started editing. When you try to write the file, you might get this message: E13, file exists, use bang to overwrite. This protects you from accidentally overwriting another file. Splitting windows. display two different files above each other, or view two locations in the file at the same time. See the difference between two files by putting them side by side. All this is possible with split windows. Chapter 8 Part 1 Split a window. The easiest way to open a new window is to use the following command: :split. This command splits the screen into two windows and leaves the cursor in the top one. So like that, essentially. What you see here is two windows on the same file. The line with equals is the status line. It displays information about the window above it. In practice, the status line will be in reverse video. The two windows allow you to view two parts of the same file. For example, you can make the top window show the variable declarations of a program, and the bottom one the code that uses these variables. The Ctrl+W command can be used to jump between the windows. If you are in the top window, Ctrl+W jumps to the window below it. If you are in the bottom window, it will jump to the first window. Ctrl+W does the same thing in case you let go of the Control key a bit later. Editor's note. What Ctrl+W means is you hold down Control, you hit W, you then release W and you hit it again whilst holding down Control, and that will allow you to jump between the windows. Close the window. To close a window, use the command :close. Actually, any command that quits editing a file works, like :quit and ZZ, but :close prevents you from accidentally exiting Vim when you close the last window. Closing all other windows. If you have opened a whole bunch of windows, but now want to concentrate on one of them, this command will be useful, :only. This closes all windows except for the current one. If any of the other windows has changed, you will get an error message and that window won't be closed. Chapter 8 Part 2 Split a window on another file. The following command opens a second window and starts editing the given file: :split2.c. If you were editing 1.c, then the result looks like this. To open a window on a new, empty file, use this: :new. You can repeat the :split and :new commands to create as many windows as you like. Chapter 8 Part 3 Window Size. The :split command can take a number argument. If specified, this will be the height of the new window. For example, the following opens a new window 3 lines high and starts editing the file alpha.c: :free split alpha.c. For existing windows, you can change the size in several ways. When you have a working mouse, it is easy. Move the mouse pointer to the status line that separates two windows and drag it up or down. To increase the size of a window, do Ctrl+W+. To decrease it, Ctrl+W-. Both of these commands take account and increase or decrease the window size by that many lines. Thus 4 Ctrl+W+ takes the window 4 lines higher. To set the window height to a specified number of lines, do height Ctrl+W_. That's a number, height, Ctrl+W, and then an underscore, the dash key with Shift on English US keyboards. To make a window as high as it can be, use Ctrl+W_ command without a count. Using the mouse. In Vim you can do many things very quickly from the keyboard. Unfortunately, the window resizing commands require quite a bit of typing. In this case, using the mouse is faster. Position the mouse pointer on a status line. Now press the left mouse button and drag. The status line will move, thus making the window on one side higher and the other smaller. Options. The win height option can be set to a minimal desired height of a window and win min height to a hard minimum height. Likewise, there is win width for the minimal desired width and win min width for the hard minimum width. The equal always option, when set, makes Vim equalize the window sizes when a window is closed or open. Chapter 8 Part 4 Vertical Splits. The :split command creates the new window above the current one. To make the window appear at the left side, use :v split or :v split 2.c. The result looks something like this. Actually, the bar lines in the middle will be in reverse video. This is called the vertical separator. It separates the two windows left and right of it. There is also the :vnew command to open a vertically split window on a new empty file. Another way to do this is :vertical new. The :vertical command can be inserted before another command that splits a window. This will cause that command to split the window vertically instead of horizontally. If the command doesn't split a window, it works unmodified. Moving between windows. Since you can split windows horizontally and vertically as much as you like, you can create almost any layout of windows. Then you can use these commands to move between them. Ctrl-WH, move to the window on the left. Ctrl-WJ, move to the window below. Ctrl-WK, move to the window above. And Ctrl-WL, move to the window on the right. Ctrl-WT will move to the top window, and Ctrl-WB will move to the bottom window. You will notice the same letters are used for moving the cursor, and the cursor keys can also be used if you like. More commands to move to other windows can be found at Q_WI. Chapter 8, Part 5, Moving Windows. You have split a few windows, but now they are in the wrong place. Then you need a command to move the window somewhere else. For example, you have 3 windows like this. Clearly the last one should be at the top. Go to that window using Ctrl-WW and then type this command, Ctrl-WK. This uses the uppercase letter K. What happens is that the window is moved to the very top. You will notice that K is again used for moving upwards. When you have vertical splits, Ctrl-WK will move the current window to the top and make it occupy the full width of the Vim window. If this is your layout, then using Ctrl-WK in the middle window, 3.c, will result in this. So it'll be moved above the other two. The other 3 similar commands, you can probably guess these now, are Ctrl-WH, move window to the far left, Ctrl-WJ, move window to the bottom, and Ctrl-WL, move window to the far right. Chapter 8, Part 6, Commands for all windows. When you have several windows open and you want to quit Vim, you can close each window separately. A quicker way is using this command, :Q all. This stands for quit all. If any of the windows contain changes, Vim will not exit. The cursor will automatically be positioned in a window with changes. You can then either use :right to save the changes, or :quit bang to throw them away. If you know there are windows with changes, and you want to save all of these changes, use this command, :W all. This stands for write all. But actually, it only writes files with changes. Vim knows it doesn't make sense to write files that were not changed. And then there is the combination of :Q all and :W all, the write and quit all command. :WQ all. This writes all modified files and quits Vim. Finally, there is a command that quits Vim and throws away all changes, :Q all bang. Be careful, there is no way to undo this command. Opening a window for all arguments. To make Vim open a window for each file, start it with the -o argument. Vim -o 1.txt, 2.txt, and 3.txt. This results in each file being opened on its own window. The $O argument is used to get vertically split windows. When Vim is already running, the :all command opens a window for each file in the argument list. :vertical all does it with vertical splits. Chapter 8, Part 7, Viewing Differences with Diff Mode. There is a special way to start Neovim, which shows the differences between 2 files. Let's take a file main.c and insert a few characters in one line. Write this file with the backup option set so that the backup file main.c tilde will contain the previous version of the file. Type this command in a shell to start Neovim in diff mode, nvim-d main.c tilde main.c. Vim will start with two windows side by side. You will only see the line in which you added characters and a few lines above and below it. This picture doesn't show the highlighting. Use nvim-d for that. The lines that were not modified have been collapsed into one line. This is called a closed fold. They are indicated in the picture with left arrow fold. Thus the single fold line at the top stands for 123 text lines. These lines are equal in both files. The line marked with left arrow changed file is highlighted, and the inserted text is displayed with another color. This clearly shows what the difference is between the two files. The line that was deleted is displayed with 3 dashes in the main.c window. See the left arrow deleted line marker in the picture. These characters are not really there. They just fill up main.c so that it displays the same number of lines as the other window. The fold column. Each window has a column on the left with a slightly different background. In the picture above, these are indicated with capital V. You notice there is a plus character there in front of each closed fold. Move the mouse pointer to that plus and click the left button. The fold will open and you can see the text that it contains. The fold column contains a minus sign for an open fold. If you click on this dash, the fold will close. Obviously, this only works when you have a working mouse. You can also use ZO to open a fold and ZC to close it. Diffing in Vim. Another way to start in diff mode can be done from inside Vim. Edit the main.c file, then make a split and show the differences. Do :edit main.c and then :vertical diff split main.c tilde. The :vertical command is used to make the window split vertically. If you omit this, you will get a horizontal split. If you have a patch of diff files, you can use the third way to start diff mode. First, edit the file to which the patch applies. Then tell Vim the name of the patch file, :edit main.c, :vertical diff patch main.c.diff. Warning: the patch file must contain only one patch, for the file you are editing. Otherwise, you will get a lot of error messages, and some files might be patched unexpectedly. The patching will only be done to the copy of the file in Vim. The file on your hard disk will remain unmodified until you decide to write the file. Scroll binding. When the files have more changes, you can scroll in the usual way. Vim will try to keep both the windows start at the same position, so you can easily see the differences side by side. When you don't want this for a moment, use this command, :set no scroll bind. Jumping to changes. When you have disabled folding in some way, it may be difficult to find the changes. Use this command to jump forward to the next change. Close square bracket C. To go the other way, use open square bracket C. Prepend a count to jump further away. Removing changes. You can move text from one window to the other. This either removes differences or adds new ones. Vim doesn't keep the highlighting updated in all situations. To update it, use this command, :diff update. To remove a difference, you can move the text in a highlighted block from one window to another. Take the main.c and main.c tilde example above. Move the cursor to the left window on the line that was deleted in the other window. Now type this command, dp. The change will be removed by putting the text of the current window in the other window. dp stands for diff put. You can also do it the other way around. Move the cursor to the right window to the line where changed was inserted. Now type this command, do. The change will now be removed by getting the text from the other window. Since there are no changes left now, Vim puts all the text in a closed fold. Do stands for diff obtain. dg would have been better, but that already has a different meaning. dgg deletes from the cursor until the first line. For details about diff mode, see diff-mode. Chapter 8, Part 8. Various. The last status option can be used to specify when the last window has a status line. 0 is never, 1 is only when there are split windows, the default, 2 is always, 3 is have a global status line at the bottom instead of one for each window. Many commands that edit another file have a variant that splits the window. For command line commands, this is done by prepending an S. For example, :tag jumps to a tag, :s tag splits the window and jumps to a tag. For normal mode commands, a Ctrl-W is prepended. Ctrl-caret jumps to the alternate file. Ctrl-W, Ctrl-caret splits the window and edits the alternate file. The split below option can be set to make a new window appear below the current window. The split right option can be set to make a vertically split window appear right of the current window. When splitting a window, you can prepend the modified command to tell where the window is to appear. :left above command, left or above the current window. :above left command, idem. Editor's note, idem just means identical or the same, so just as above essentially. Right below command, right or below the current window, :below right command, idem, :top left command at the top or left of the Vim window, :bot right command at the bottom or right of the Vim window. Chapter 8, Part 9, Tab Pages. You will have noticed that windows never overlap. That means you quickly run out of screen space. The solution for this is called tab pages. Assume you are editing this file. To create a new tab page, use this command: :tab edit that file. This will edit the file that file in a window that occupies the whole Vim window, and you will notice a bar at the top with the two file names. That file is bold. You now have two tab pages. The first one has a window for this file, and the second one a window for that file. It's like two pages that are on top of each other, with a tab sticking out of each page showing the file name. Now use the mouse to click on this file in the top line. The result is this. This file is bold. Thus you can switch between tab pages by clicking on the label in the top line. If you don't have a mouse or don't want to use it, you can use the GT command, mnemonic, go to tab. Now let's create another tab page with the command, :tab split. This makes a new tab page with one window that is editing the same buffer as the window we are in. This file is bold. You can put :tab before any EX command that opens a window. The window will be opened in a new tab page. Another example. :tab help GT. We'll show the help text for GT in the new tab page. A few more things you can do with tab pages. Click with the mouse in the space after the last label. The next tab page will be selected, like with GT. Click with the mouse on the X in the top right corner. Current tab page will be closed, unless there are unsaved changes in the current tab page. Double-click with the mouse in the top line. A new tab page will be created. The tab-only command closes all tab pages except the current one, unless there are unsaved changes in other tab pages. For more information about tab pages, see tab-page. Vim works in an ordinary terminal, while gvim has a graphical user interface, or GUI. It can do the same things and a few more. The GUI offers menus, a toolbar, scroll bars, and other items. This chapter is about these extra things that the GUI offers. Chapter 9, Part 1, Parts of the GUI. You might have an icon on your desktop that starts gvim. Otherwise, one of these commands should do it. gvim file.txt or vim-g file.txt. If this doesn't work, you don't have a version of Vim with GUI support. You will have to install one first. Vim will now open a window and display file.txt in it. What the window looks like depends on the version of Vim. It should resemble the following picture, for as far as this can be shown in ASCII. The largest space is occupied by the file text. This shows the file in the same way as in a terminal, with some different colors and another font perhaps. The window title. At the very top is the window title. This is drawn by your window system. Vim will set the title to show the name of the current file. First comes the name of the file. then some special characters, and the directory of the file in parents. These special characters can be present. Dash, the file cannot be modified, example, a help file. Plus, the file contains changes. Equals, the file is read-only. Equals plus, the file is read-only, contains changes anyway. If nothing is shown, you have an ordinary unchanged file. The menu bar. You know how menus work, right? Vim has the usual items, plus a few more. Browse them to get an idea of what you can use them for. A relevant submenu is Edit/Global Settings. You will find these entries. Toggle Toolbar, make the toolbar appear/disappear. Toggle Bottom Scroll Bar, makes the scroll bar appear/disappear at the bottom. Toggle Left Scroll Bar, makes the scroll bar appear/disappear at the left. Toggle Right Scroll Bar, makes the scroll bar appear/disappear at the right. The toolbar. This contains icons for the most often used actions. Hopefully, the icons are self-explanatory. There are tooltips to get an extra hint. Move the mouse pointer to the icon without clicking and don't move it for a second. The Edit/Global Settings/Toggle Toolbar menu item can be used to make the toolbar disappear. If you never want a toolbar, use this command in your vimrc file. Set GUI options -= T. This removes the T flag from the GUI options option. Other parts of the GUI can also be enabled or disabled with this option. See the help for it. By default, there is one scroll bar on the right. It does the obvious thing. When you split the window, each window will get its own scroll bar. You can make a horizontal scroll bar appear with the menu item, Edit, Global Settings, Toggle Bottom, Scroll Bar. This is useful in diff mode, or when the wrap option has been reset. More about that later. When there are vertically split windows, only the windows on the right side will have a scroll bar. However, when you move the cursor to a window on the left, it will be this one that the scroll bar controls. This takes a bit of time to get used to. When you work with vertically split windows, consider adding a scroll bar on the left. This can be done with a menu item or with the GUI options option. Set GUI options += L. This adds the L flag to GUI options. Chapter 9 Part 2. Using the mouse. Standards are wonderful. In Microsoft Windows, you can use the mouse to select text in a standard manner. The X Windows system also has a standard system for using the mouse. Unfortunately, these two standards are not the same. Fortunately, you can customize Vim. The following commands make the mouse work more like a Microsoft Windows mouse. Set selection = exclusive. Set selection mode = mouse, key. Set key model = start cell, stop cell. The mouse can be further tuned. Check out these options if you want to change the way the mouse works. Mouse, in which mode the mouse is used by Vim. Mouse model, what effect a mouse click has. Mouse time, time between clicks for a double click. Mouse hide, hide the mouse while typing. Select mode, whether the mouse starts visual or select mode. Chapter 9 Part 3. The clipboard. In Section 4 Part 7, the basic use of the clipboard was explained. There is one essential thing to explain about X Windows. There are actually two places to exchange text between programs. Microsoft Windows doesn't have this. In X Windows, there is the current selection. This is the text that is currently highlighted. In Vim, this is the visual area. This assumes you are using the default option settings. You can paste this selection in another application without any further action. For example, in this text, select a few words with the mouse. Vim will switch to visual mode and highlight the text. Now start another gvim without a file name argument, so that it displays an empty window. Click the middle mouse button. The selection text will be inserted. Editor's note: that's very interesting that the middle mouse button would paste the text. The current selection will only remain valid until some other text is selected. After doing the paste in the other gvim, now select some characters in that window. You will notice that the words that were previously selected in the other GVim window are displayed differently. This means that it no longer is the current selection. You don't need to select text with the mouse. Using the keyboard commands for visual mode works just as well. The real clipboard. Now for the other place with which text can be exchanged. We call this the real clipboard to avoid confusion. Often both the current selection and the real clipboard are called clipboard. You'll have to get used to that. To put text on the real clipboard, select a few different words in one of the GVims you have running. Then use the Edit Copy menu entry. Now the text has been copied to the real clipboard. You can't see this unless you have some application that shows the clipboard contents. Example, KDE's Clipper. Now select the other GVim, position the cursor somewhere, and use the Edit Paste menu. You will see the text from the real clipboard is inserted. Using both. This use of both the current selection and the real clipboard might sound a bit confusing, but it is very useful. Let's show this with an example. Use one GVim with a text file and perform these actions. Select two words in visual mode. Use the Edit Copy menu to get these words onto the clipboard. Select one other word in visual mode. Use the Edit Paste menu item. What will happen is that the single selected word is replaced with the two words from the clipboard. Move the mouse pointer somewhere else and click the middle button. You will see that the word you just overwrote with the clipboard is inserted here. If you use the current selection and the real clipboard with care, you can do a lot of useful editing with them. Using the keyboard. If you don't like using the mouse, you can access the current selection and the real clipboard with two registers. The ** register is for the current selection. To make text become the current selection, use visual mode. For example, to select a whole line, just press capital V. To insert the current selection before the cursor, do ** P. Notice the uppercase P. The lowercase p puts the text after the cursor. The ++ register is used for the real clipboard. For example, to copy the text from the cursor position until the end of the line to the clipboard, do $y $. Remember, Y is yank, which is Vim's copy command. To insert the contents of the real clipboard before the cursor, do +* P. It's the same as for the current selection, but uses the plus register instead of the star register. Chapter 9 Part 4 Select Mode. And now something that is used more often on Microsoft Windows than on X Windows. But both can do it. You already know about visual mode. Select mode is like visual mode because it is also used to select text. But there is an obvious difference. When typing text, the select text is deleted, and the typed text replaces it. To start working with select mode, you must first enable it. For Microsoft Windows, it is probably already enabled, but you can do this anyway. Set select mode + mouse. Now use the mouse to select some text. It is highlighted like in visual mode. Now press a letter. The selected text is deleted and the single letter replaces it. You are in insert mode now, thus you can continue typing. Since typing normal text causes the selected text to be deleted, you cannot use the normal movement commands H, J, K, L, W, etc. Instead, use the shifted function keys. Shift left, shifted cursor left key, moves the cursor left. The selected text is changed, like in visual mode. The other shifted cursor keys do what you expect. Shift N and Shift Home also work. You can tune the way select mode works with the select mode option. Making big changes. In Chapter 4, several ways to make small changes were explained. This chapter goes into making changes that are repeated or can affect a large amount of text. The visual mode allows doing various things with blocks of text. Use an external program to do really complicated things. Chapter 10 Part 1 Record and playback commands. The period command repeats the preceding change. But what if you want to do something more complex than a single change? That's where command recording comes in. There are 3 steps. 1. The Q register command starts recording keystrokes into the register named register. The register name must be between A and Z. 2. Type your commands. 3. To finish recording, press Q without any extra characters. You can now execute the macro by typing the command @register. Take a look at how to use these commands in practice. You have a list of file names that look like this: standardIO.h, fcntl.h, unistd.h, stdlib.h. And what you want is the following, including #include before them and adding double quotes around them. You start by moving to the first character of the first line. Next, you execute the following commands. QA, start recording a macro in register A. Caret, move to the beginning of the line. #include, double quote, escape. Insert the string #include, double quote at the beginning of the line. $, move to the end of the line. A double quote escape, append the character double quotation mark to the end of the line and then go back into normal mode by doing escape. J, go to the next line. Q, stop recording the macro. Now that you have done the work once, you can repeat any change by typing the command @A 3 times. The @A command can be preceded by a count, which will cause the macro to be executed that number of times. In this case, you would type 3 @A. Move and execute. You might have the lines you want to change in various places. Just move the cursor to each location and use the @A command. If you have done that once, you can do it again with @@. That's a bit easier to type. If you now execute register B with @B, the next @@ will use register B. If you compare the playback method with using period, there are several differences. First of all, period can only repeat one change. As seen in the example above, @A can do several changes and move around as well. Secondly, period can only remember the last change. Executing a register allows you to make any changes and then still use @A to replay the recorded commands. Finally, you can use 26 different registers. Thus, you can remember 26 different command sequences to execute. Using registers. The registers used for recording are the same ones you used for yank and delete commands. This allows you to mix recording with other commands to manipulate the registers. Suppose you have recorded a few commands in register N. When you execute this with @N, you notice you did something wrong. You could try recording again, but perhaps you will make another mistake. Instead, use this trick. Capital G to go to the end of the file. O escape, create an empty line. Double quote NP, put the text from the N register. You now see the command you typed as text in the file. Change the commands that are wrong. This is just like editing text. Then you do 0, go to the start of the line. Double quote NY $, yank the corrected commands into the N register, and then do DD to delete the scratch line. Now you can execute the corrected commands with @N. If your recorded commands include line breaks, adjust the last two items in the example to include all the lines. Appending to a register. So far we have used a lowercase letter for the register name. To append to a register, use an uppercase letter. Suppose you have recorded a command to change a word to register C. It works properly, but you would like to add a search for the text word to change. This can be done with lowercase q capital C /word less than enter greater than lowercase q. You start with lowercase q capital KC, which records to the C register and appends. Thus, writing to an uppercase register name means to append to the register with the same letter, but lowercase. This works both with recording and with yank and delete commands. For example, you want to collect a sentence of lines into the A register. Yank the first line with double quote AYY. Now move to the second line and type double quote capital AYY. Repeat this command for all lines. Then the register now contains all those lines in the order you yanked them. Chapter 10 Part 2 Substitution. The :substitute command enables you to perform string replacements on a whole range of lines. The general form of this command is as follows: range in square brackets, substitute /from /2 / flags in square brackets. This command changes the from string to the to string in the line specified with range. For example, you can change professor to teacher in all lines with the following command: %, substitute /professor /teacher /. Note, the :substitute command is almost never spelled out completely. Most of the time people use the abbreviated version $s. From here on the abbreviation will be used. The % before the command specifies the command works on all lines. Without a range, $s only works on the current line. More about ranges in the next section, 10.3. By default, the :substitute command changes only the first occurrence on each line. For example, the preceding command changes the line Professor Smith criticized Professor Johnson today to Teacher Smith criticized Professor Johnson today. To change every occurrence on the line, you need to add the G for global flag. The command %s /professor /teacher /g results in, starting with the original line, Teacher Smith criticized Teacher Johnson today. Other flags include P for print, which causes the :substitute command to print out the last line it changes. The C confirm flag tells :substitute to ask you for confirmation before it performs each substitution. Enter the following: %s /professor /teacher /c. Vim finds the first occurrence of professor and displays the text that is about to change. You will get the following prompt: replace with teacher, yes, no, all, quit, last, scroll up, or scroll down. At this point, you must enter one of the following answers: Y for yes, make this change; N for no, skip this match; A for all, make this change and all remaining ones without further confirmation; Q for quit, don't make any more changes; L for last, make this change and then quit; Control E, scroll the text one line up; Control Y, scroll the text one line down. The from part of the substitute command is actually a pattern, the same kind as used for the search command. For example, this command only substitutes the when it appears at the start of a line: $s / the /these /. If you are substituting with a from or to part that includes a slash, you need to put a backslash before it. A simpler way is to use another character instead of the slash, a plus for example, $s + 1 / 2 + 1 or 2 plus. Chapter 10, Part 3. Command ranges. The :substitute command and many other commands can be applied to a selection of lines. This is called a range. The simple form of a range is number: number. For example, :1, 5s /this /that /g. Executes the substitute command on the lines 1 to 5. Line 5 is included. The range is always placed before the command. The single number can be used to address one single line. $54s /president /fool /. Some commands work on the whole line when you do not specify a range. To make them work on the current line, the period address is used. The :write command works like that. Without a range, it writes the whole file. To make it write only the current line into a file, do :write other file. The first line always has number 1. How about the last line? The $sign character is used for this. For example, to substitute in the lines from the cursor to the end, do $, $s /yes /no /. The % range that was used before is actually a short way to say 1 to $, from the first to the last line. Using a pattern in a range. Suppose you are editing a chapter in a book, and you want to replace all occurrences of gray with gray, but only in this chapter, not in the next one. You know that only chapter boundaries have the word chapter in the first column. This command will work then. $?chapter ? chapter / s equals gray equals gray equals g. You can see a search pattern is used twice. The first chapter ? finds the line above the current position that matches this pattern. Thus the pattern range is used to search backwards. Similarly, chapter / is used to search forward for the start of the next chapter. To avoid confusion with these slashes, the equals character was used in the substitute command here. A slash or another character would have worked as well. Add and subtract. There is a slight error in the above command. If the title of the next character had included gray, it would be replaced as well. Maybe that's what you wanted, but what if you didn't? Then you can specify an offset. To search for a pattern and then use the line above it, do /chapter /-1. You can use any number instead of the 1. To address the second line below the match, do /chapter /+2. The offsets can also be used with the other items in a range. Look at this one. :period +3, $5. This specifies the range that starts 3 lines below the cursor and ends 5 lines before the last line in the file. Using marks. Instead of figuring out the line numbers of certain positions, remembering them and typing them in a range, you can use marks. Place the marks as mentioned in Chapter 3. For example, use MT to mark the top of an area and MB to mark the bottom. Then you can use this range to specify the lines between the marks, including the lines with the marks. You do : T, :B. Visual mode and ranges. You can select text with visual mode. If you then press : to start a : command, you will see this: : less than, greater than. Now you can type the command and it will be applied to the range of lines that was visually selected. Note: when using visual mode to select parts of a line or using Ctrl-V to select a block of text, the : commands will simply apply to whole lines. This might change in a future version of Vim. The :less than and :greater than are actually marks, placed at the start and end of the visual selection. The marks remain at their position until another visual selection is made. Thus you can use the :less than command to jump to position where the visual area started. And you can mix the marks with other items. For example, : greater than, $. This addresses the lines from the end of the visual area to the end of the file. A number of lines. When you know how many lines you want to change, you can type the number and then colon. For example, when you type 5 : you will get : period, period +4. Now you can type the command you want to use. It will use the range period, current line, until period +4, 4 lines down. Thus it spans 5 lines. Chapter 10, Part 4, the global command. The :global command is one of the more powerful features of Vim. It allows you to find a match for a pattern and execute a command there. The general form is : range in square brackets global / pattern and curly braces / command and curly braces. This is similar to the : substitute command, but instead of replacing the match text with other text, the command is executed. Note: the command executed for a :global must be one that starts with a colon. Normal mode commands cannot be used directly. The :normal command can do this for you. Suppose you want to change foobar to barfoo, but only in C++ style comments. These comments start with /. Use this command: :g +/+s /foobar /barfoo /g. This starts with :g. That is short for :global, just like :s is short for a : substitute. Then the pattern enclosed in plus characters. Since the pattern we are looking for contains a slash, this uses the plus character to separate the pattern. Next comes the substitute command that changes foobar into barfoo. The default range for the global command is the whole file, thus no range was specified in this example. This is different from : substitute, which works on one line without a range. The command isn't perfect since it also matches lines where / appears halfway through a line, and the substitution will also take place before the /. Just like with colon substitute, any pattern can be used. When you learn more complicated patterns later, you can use them here. Chapter 10, Part 5, Visual Block Mode. With Ctrl-V, you can start selection of a rectangular area of text. There are a few commands that do something special with the text block. There is something special about using the $ command in Visual Block Mode. When the last motion command used was $, all lines in the visual selection will extend until the end of the line. Also when the line with the cursor is shorter. This remains effective until you use a motion command that moves the cursor horizontally. Thus using J keeps it, H stops it. Inserting text. The command I string escape inserts the text string in each line, just left of the visual block. You start by pressing Ctrl-V to enter Visual Block Mode. Now you move the cursor to define your block. Next you type I to enter insert mode, followed by the text to insert. As you type, the text appears on the first line only. After you press escape to end the insert, the text will magically be inserted in the rest of the lines contained in the visual selection. Example: include 1, include 2, include 3, include 4. Move the cursor to the O of 1 and press Ctrl-V. Move it down with 3J to 4. You now have a block selection that spans 4 lines. Now type I main period escape. The result: include main.1, include main.2, include main.3, include main.4. If the block spans short lines that do not extend into the block, the text is not inserted in that line. For example, make a visual block selection that includes the word long in the first line and last line of this text, and thus has no text selected in the second line. This is a long line, short, any other long line, and this indicates the selected block. Now use the command I very space escape. The result is this is a very long line, short, any other very long line. In the short line, no text was inserted. If the string you insert contains a new line, the I acts just like a normal insert command and affects only the first line of the block. The A command works the same way, except that it appends after the right side of the block. And it does insert mode in a short line. Thus you can make a choice whether you want or don't want to append text to a short line. There is one special case for A. Select a visual block and then use $ to make the block extend to the end of each line. Using A now will append the text to the end of each line. Using the same example from above and then typing $A, XXX escape, you get this result. This is a long line XXX, short XXX, any other long line XXX. This really requires using the $ command. Vim remembers that it was used. Making the same selection by moving the cursor to the end of the longest line with other movement commands will not have the same result. Changing text. The visual block C command deletes the block and then throws you into insert mode to enable you to type in a string. This string will be inserted in each line in the block. Starting with the same selection of the long words above, then typing C_long_escape, you get this. This is a _long line, short, any other _long line. Just like with I, the short line is not changed. Also, you can't enter a new line in the new text. The C command deletes text from the left edge of the block to the end of the line. It then puts you in insert mode so that you can type in a string, which is added to the end of each line. Starting with the same text again and typing C new space text escape, you get this is a new text, short, any other new text. Notice that even though only the long word was selected, the text after it is deleted as well. Thus, only the location of the left edge of the visual block really matters. Again, short lines that do not reach into the block are excluded. Other commands that change the characters in the block are tilde, swap case, so lowercase a turns into uppercase A and vice versa. Uppercase U make uppercase, which will turn lowercase a into uppercase A, but uppercase A will still be uppercase A, and lowercase u make lowercase, which means that lowercase a will remain lowercase a, but uppercase A will turn into lowercase a. Filling with a character. To fill the whole block with one character, use the lowercase r command. Again, starting with the same example text from above, and then typing rx. This is a XXXX line, short, any other XXXX line. Note, if you want to include characters beyond the end of the line in the block, check out the virtual edit feature in chapter 25. Shifting. The command > shifts the selected text to the right one shift amount, inserting whitespace. The starting point for this shift is the left edge of the visual block. With the same example again, > gives this result. This is a space long line, short any other space long line. The shift amount is specified with the shift width option. To change it to use 4 spaces, do set shift width equals 4. The less than command reverses one shift amount of whitespace at the left edge of the block. This command is limited by the amount of text that is there, so if there is less than a shift amount of whitespace available, it removes what it can. Joining lines. The J command joins all selected lines together into one line, thus it removes the line breaks. Actually, the line break, leading whitespace and trailing whitespace, is replaced by one space. 2 spaces are used after a line ending that can be changed with the join space option. Let's use the example that we got so familiar with now. The result of using the J command is this is a long line short any other long line. The J command doesn't require a blockwise selection. It works with V and uppercase V selection in exactly the same way. If you don't want the whitespace to be changed, use the lowercase g uppercase J command. Chapter 10, Part 6. Reading and writing part of a file. When you are writing an email message, you may want to include another file. This can be done with the :read file name command. The text of the file is put below the cursor line. Starting with this text. Hi John, here is the diff that fixed the bug. By Pierre. Move the cursor to the second line and type :read patch. The file named patch will be inserted with this result. Hi John, here is the diff that fixes the bug, and then, there's the diff, and then by Pierre. The :read command accepts a range. The file will be put below the last line number of this range. Thus, $R patch appends the file patch at the end of the file. What if you want to read the file above the first line? This can be done with the line number 0. This line doesn't really exist. You will get an error message when using it with most commands, but this command is allowed. :0 read patch. The file patch will be put above the first line of the file. Writing a range of lines. To write a range of lines to a file, the :write command can be used. Without a range, it writes the whole file. With a range, only the specified lines are written. $write tempo. This writes the lines from the cursor until the end of the file into the file tempo. If this file already exists, you will get an error message. Vim protects you from accidentally overwriting an existing file. If you know what you are doing and want to overwrite the file, append bang. So do $write bang tempo. Careful, the bang must follow the :write command immediately, without whitespace, otherwise it becomes a filter command, which is explained later in this chapter. Appending to a file. In the first section of this chapter was explained how to collect a number of lines into a register. The same can be done to collect lines in a file. Write the first line with this command, : write collection. Now move the cursor to the second line you want to collect and type this, : write collection. The greater than tells Vim the collection file is not to be written as a new file, but the line must be appended at the end. You can repeat this as many times as you like. Chapter 10 Part 7 Formatting Text. When you are typing plain text, it's nice if the length of each line is automatically trimmed to fit in the window. To make this happen while inserting text, set the text width option by doing : set text width equals 78. You might remember that in the example vimrc file, this command was used for every text file. Thus, if you are using that vimrc file, you are already using it. To check the current value of text width, do : set text width. Now lines will be broken to take only up to 78 characters. However, when you insert text halfway through a line or when you delete a few words, the lines will get too long or too short. Vim doesn't automatically reformat the text. To tell Vim to format the current paragraph, do gqap. This starts with the gq command, which is an operator. Following is ap, the text object that stands for a paragraph. A paragraph is separated from the next paragraph by an empty line. Note: a blank line, which contains white space, does not separate paragraphs. This is hard to notice. Instead of AP, you could use any motion or text object. If your paragraphs are properly separated, you can use this command to format the whole file. GGGQ capital G. GG takes you to the first line, GQ is the format operator, and capital G the motion that jumps to the last line. In case your paragraphs aren't clearly defined, you can format just the lines you manually select. Move the cursor to the first line you want to format. Start with the command gqj. This formats the current line and the one below it. If the first line was short, words from the next line will be appended. If it was too long, words will be moved to the next line. The cursor moves to the second line. Now you can use period to repeat the command. Keep doing this until you are at the end of the text you want to format. Chapter 10, Part 8, Changing Case. You have text with section headers in lowercase. You want to make the word section all uppercase. Do this with the GU operator. Start with the cursor in the first column. So you would do GU, and that will turn section into uppercase. The GU operator does exactly the opposite. So it will turn section, uppercase, into lowercase. You can also use G tilde to swap case. All these are operators, thus they work with any motion command with text objects and in visual mode. To make an operator work on lines, you double it. The delete operator is D, thus to delete a line you use DD. Similarly, GU or GUGU makes a whole line lowercase. This can be shorthanded to GUU. G uppercase U, lowercase g uppercase u is shortened to lowercase g two uppercase u's, and G tilde to G tilde tilde. Example: so G tilde tilde will invert the case of the sentence. Chapter 10, Part 9, Using an external program. Vim has a very powerful set of commands. It can do anything, but there may still be something that an external command can do better or faster. The command bang motion program takes a block of text and filters it through an external program. In other words, it runs the system command represented by program, giving it the block of text represented by motion as input. The output of this command then replaces the selected block. Because this summarizes badly if you are unfamiliar with Unix filters, take a look at an example. The sort command sorts a file. If you execute the following command, the unsorted file input.txt will be sorted and written to output.txt. This works on both Unix and Windows. Sort input.txt greater than output.txt. Now do the same thing in Vim. You want to sort lines 1 through 5 of a file. You start by putting the cursor on line 1. Next, you execute the following command: bang 5 uppercase G. The bang tells Vim that you are referring to a filter operation. The Vim editor expects a motion command to follow, indicating which part of the file to filter. The 5 capital G command tells Vim to go to line 5, so it now knows that it is to filter lines 1, the current line, through 5. In anticipation of the filtering, the cursor drops to the bottom of the screen and a bang prompt displays. You can now type in the name of the filter program, in this case sort. Therefore, your full command is as follows: bang 5 uppercase G sort enter. The result is that the sort program is run on the first 5 lines. The output of the program replaces these lines. So the lines get sorted. The double bang command filters the current line through a filter. In Unix, the date command prints the current date and time. Bang bang date enter replaces the current line with the output of date. This is useful to add a timestamp to a file. Note: there is a difference between bang cmd, example using it without any file range, or range bang cmd. While the former will simply execute the external command and Vim will show the output, the latter will filter range lines through the filter and replace that range by the result of the filter command. See :bang and :range bang for details. Editor's note: saying the word bang is very fun. When it doesn't work. Starting a shell, sending it text and capturing the output requires that Vim know how the shell works exactly. When you have problems with filtering, check the values of these options. Shell specifies the program that Vim uses to execute external programs. Shell cmd flag, argument to pass a command to the shell. Shell quote to be used around the command. Shell xquote, quote to be used around the command and redirection. Shell / use forward slashes in the command, only for Microsoft Windows and the likes. Shell reader, string used to write the command output into a file. On Unix, this is hardly ever a problem because there are 2 kinds of shells, sh-like and csh-like. Vim checks the shell option and sets related options automatically, depending on whether it sees csh somewhere in shell. On Microsoft Windows, however, there are many different shells and you might have to tune the options to make filtering work. Check the help for the options for more information. Reading command output. To read the context of the current directory into the file, use this. On Unix, do :read bang ls. On Microsoft, do :read bang dir. The output of the ls and dir command is captured and inserted into the text, below the cursor. This is similar to reading a file, except that the bang is used to tell Vim that a command follows. The command may have arguments, and a range can be used to tell where Vim should put the lines. :0 read bang date -u. This inserts the current time and date in UTC format at the top of the file. Well, if you have a date command that accepts the -u argument. Note the difference with using bang bang date. That replaced a line, while :read bang date will insert a line. Writing text to a command. The Unix command wc counts words. To count the words in the current file, do :write bang wc. This is the same write command as before, but instead of a file name, bang character is used and the name of an external command. The written text will be passed to the specified command as its standard input. The output could look like this: 447249. The wc command isn't verbose. This means you have 4 lines, 47 words, and 249 characters. Watch out for this mistake: :write bang wc. This will write the file wc in the current directory with force. White space is important here. Redrawing the screen. If the external command produced an error message, the display may have been messed up. Vim is very efficient and only redraws those parts of the screen that it knows need redrawing. But it can't know about what another program has written. To tell Vim to redraw the screen, do Ctrl-L. Recovering from a crash. Did your computer crash and you just spent hours editing? Don't panic. Vim stores enough information to be able to restore most of your work. This chapter shows you how to get your work back and explains how the swap file is used. Chapter 11 Part 1 Basic Recovery. In most cases, recovering a file is quite simple, assuming you know which file you were editing and the hard disk is still working. Start Vim on the file with the -r argument added, vim-r help.txt. Vim will read the swap file used to store text you are editing and may read bits and pieces of the original file. If Vim recovered your changes, you will see these messages with different file names, of course, using swapfile.help.txt.swp, original file ~vim/runtime/doc/help.txt. Recovery complete. You should check if everything is okay. You might want to write out this file under another name and run def with the original file to check for changes. You may want to delete the swp file now. To be on the safe side, write this file under another name. By doing : write help.txt.recovered. Compare the file with the original file to check if you ended up with what you expected. Diff mode is very useful for this. Chapter 8 Part 7. For example, : write help.txt.recovered, : edit hash, : diff sp help.txt. Watch out for the original file to contain a more recent version. You saved the file just before the computer crashed. And check that no lines are missing, something went wrong that Vim could not recover. If Vim produces warning messages when recovering, read them carefully. This is rare though. If the recovery resulted in text that is exactly the same as the file contents, you will get this message, using swapfile.help.txt.swp. Original file ~vim/runtime/doc/help.txt. Recovery completed. Buffer contains equals file contents. You may want to delete the .swp file now. This usually means if you already recover your changes, or you wrote the file after making changes. It is safe to delete the swap file now. It is normal that the last few changes cannot be recovered. Vim flushes the changes to disk when you don't type for about 4 seconds, or after typing about 200 characters. This is set with the update time and update count options. Thus, when Vim didn't get a chance to save itself when the system went down, the changes after the last flush will be lost. If you were editing without a file name, give an empty string as argument, vim-r ... You must be in the right directory, otherwise Vim can't find the swap file. Chapter 11 Part 2 Where is the swap file? Vim can store the swap file in several places. To find it, change to the directory of the file and use vim-r. Vim will list the swap files that it can find. It will also look in other directories where the swap file for files in the current directory may be located. It will not find swap files in any other directories though. It doesn't search for the directory tree. The output could look like this. If there are several swap files that look like they may be the one you want to use, a list is given of those swap files and you are requested to enter the number of the one you want to use. Carefully look at the dates to decide which one you want to use. In case you don't know which one to use, just try them one by one and check the resulting files if they are what you expected. Using a specific swap file. If you know which swap file needs to be used, you can recover by giving the swap file name. Vim will then find out the name of the original file from the swap file. Example, vim-r.help.txt.swo. This is also handy when the swap file is in another directory than expected. Vim recognizes files with the pattern .s uvw in square brackets 8z in square brackets as swap files. If this still does not work, see what file names Vim reports and rename the files accordingly. Check the directory option to see where Vim may have put the swap file. Note: Vim tries to find the swap file by searching the directories in the dir option, looking for files that match filename.sw something. If wildcard extension doesn't work, example when the shell option is invalid, Vim does a desperate try to find the file filename.swp. If that fails too, you will have to give the name of the swap file itself to be able to recover the file. Chapter 11 Part 3 Crash or Not. Vim tries to protect you from doing stupid things. Suppose you innocently start editing a file expecting the contents of the file to show up. Instead, Vim produces a very long message. So it gives you this error. You get this message because when starting to edit a file, Vim checks if a swap file already exists for that file. If there is one, there must be something wrong. It may be one of these two situations. 1. Another edit session is active on this file. Look in the message for the line with process ID. It might look like this. Process ID 12559 is still running. The text still running indicates that the process editing this file runs on the same computer. When working on a non-Unix system, you will not get this exact hint. When editing a file over a network, you may not see the hint because the process might be running on another computer. In those two cases, you must find out what the situation is yourself. If there is another Vim editing the same file, continuing to edit will result in two versions of the same file. The one that is written last will override the other one, resulting in loss of changes. You better quit this Vim. 2. The swap file might be the result from a previous crash of Vim or the computer. Check the dates mentioned in the message. If the date of the swap file is newer than the file you are editing, and this line appears, modified yes, then you very likely had a crashed edit session that is worth recovering. If the date of the file is newer than the date of the swap file, then either it was changed after the crash, perhaps you recovered it earlier but didn't delete the swap file, or else the file was saved before the crash but after the last write of the swap file. Then you're lucky, you don't even need that old swap file. Vim will warn you for this with this extra line, newer than swap file. Note that in the following situation, Vim knows the swap file is not useful and will automatically delete it. The file is a valid swap file, magic number is correct, the flag that the file was modified is not set, or the process is not running. You can programmatically deal with the situation with the file changed shell auto command event. Unreadable swap file. Sometimes this line, cannot be read, will appear under the name of the swap file. This can be good or bad, depending on circumstances. It is good if a previous editing session crashed without having any changes to the file. Then a directory listing of the swap file will show that it has 0 bytes. You may delete it and proceed. It is slightly bad if you don't have read permissions for the swap file. You may want to view the file read-only or quit. On multi-user systems, if you yourself did the last changes under a different login name, a logout followed by a login under that other name might cure the read error. Or else you might want to find out who last edited or is editing the file and have a talk with them. It is very bad if it means there is a physical error read on the disk containing the swap file. Fortunately, this almost never happens. You may want to view the file read-only at first if you can to see the extent of the changes that were forgotten. If you are the one in charge of that file, be prepared to redo your last changes. What to do? If dialogues are supported, you will be asked to select one of 6 choices. swapfile.main.c.swap already exists. Open, read-only, edit anyway, recover, quit, abort, delete it. O. Open the file read-only. Use this when you just want to view the file and don't need to recover it. You might want to use this when you know someone else is editing the file, but you just want to look in it and not make changes. E. Edit the file anyway. Use this with caution. If the file is being edited in another Vim, you might end up with 2 versions of the file. Vim will try to warn you when this happens, but better be safe than sorry. R. Recover the file from the swap file. Use this if you know that the swap file contains changes that you want to recover. Q for quit. This avoids starting to edit the file. Use this if there is another Vim editing the same file. When you just started Vim, this will exit Vim. When starting Vim with files in several windows, Vim quits only if there is a swap file for the first one. When using an edit command, the file will not be loaded and you are taken back to the previously edited file. A for abort, like quit, but also abort further commands. This is useful when loading a script that edits several files, such as a session with multiple windows. D for delete the swap file. Use this when you are sure you no longer need it. For example, when it doesn't contain changes or when the file itself is newer than the swap file. On Unix, this choice is only offered when the process that created the swap file does not appear to be running. If you do not get the dialog, you are running a version of Vim that does not support it, you will have to do it manually. To recover the file, use this command, :recover. Vim cannot always detect that a swap file already exists for a file. This is the case when the other edit session puts the swap files in another directory, or when the path name for the file is different when editing it on different machines. Therefore, don't rely on Vim always warning you. If you really don't want to see this message, you can add the A flag to the short mess option, but it's very unusual that you need this. For programmatic access to the swap file, see swap info. Chapter 11, Part 4. Further reading, swap-file, an explanation about where the swap file will be created and what its name is. :preserve, manually flushing the swap file to disk. :swap name, see the name of the swap file for the current file. Update count, number of keystrokes after which the swap file is flushed to disk. Update time, timeout after which the swap file is flushed to disk. And directory, list of directory names where to store the swap file. Clever tricks. By combining several commands, you can make Vim do nearly everything. In this chapter, a number of useful combinations will be presented. This uses the commands introduced in the previous chapter and a few more. Chapter 12, Part 1. Replace a word. The substitute command can be used to replace all occurrences of a word with another word. $s/4/4/4/G. The percentage range means to replace in all lines. The G flag at the end causes all words in the line to be replaced. This will not do the right thing if your file also contains 34. It would be replaced with 30 and then the number 4. To avoid this, use the \less than item to match the start of a word. $s/less than 4/4/G. Obviously, this still goes wrong on 14. Use \greater than to match the end of a word. So do $s/less than 4 \greater than the number 4/G. If you are programming, you might want to replace 4 in comments but not in the code. Since this is difficult to specify, add the C flag to have the substitute command prompt you for each replacement. $s/\\less than 4 \greater than the number 4/GC. Replacing in several files. Suppose you want to replace a word in more than one file. You could edit each file and type the command manually. It's a lot faster to use record and playback. Let's assume you have a directory with C++ files, all ending in .cpp. There is a function called getResp that you want to rename to getAnswer. Vim *.cpp. Start Vim, defining the argument list to contain all the C++ files. You are now in the first file. QQ. Start recording into the Q register. $s/\less than getResp \greater than /getanswer/G. Do the replacement in the first file. $W next. Write this file and move to the next one. Press Q to stop recording. Now do @Q. Execute the Q register. This will replay the substitution and W next. You can verify that this doesn't produce an error message. 999 @Q. Execute the Q register on the remaining files. At the last file, you will get an error message because wnext cannot move to the next file. This stops the execution and everything is done. Note, when playing back your recorded sequence, an error stops the execution. Therefore, make sure you don't get an error message when recording. There is one catch. If one of the .cpp files does not contain the word getResp, you will get an error and replacing will stop. To avoid this, add the E flag to the substitute command. $%s / less than getResp / greater than / getAnswer / ge. The E flag tells :substitute that not finding a match is not an error. Chapter 12 Part 2. Change last comma first to first last. You have a list of names in this form: Doe, John, Smith, Peter. You want to change that to John Doe and Peter Smith. This can be done with just one command: $%s / open parentheses open square bracket caret comma close square bracket asterisk / close parentheses comma / open parentheses period asterisk / close parentheses / /2 /1 /. Let's break this down in parts. Obviously starts with a substitute command. The percentage is the line range, which stands for the whole file. Thus the substitution is done in every line in the file. The arguments for the substitute command are /from, /to, /. The slashes separate the from pattern and the to string. This is what the from pattern contains. So the first part between / open parentheses and then / close parentheses matches last. This portion, the caret and comma in square brackets, will match anything but a comma. The asterisk will match any number of times. Period matches period space, literally, and that is a period space there. The second part between the / open parentheses / close parentheses matches first. Then period matches any character, and asterisk matches any number of times. In the to part, we have /2 and /1. These are called back references. They refer to the text matched by the / open parentheses / close parentheses parts in the pattern. /2 refers to the text matched by the second / open parentheses / close parentheses, which is the first name. /1 refers to the first / open parentheses / close parentheses, which is the last name. You can use up to 9 back references in the to part of a substitute command. /0 stands for the whole matched pattern. There are a few more special items in a substitute command. See sub-replace-special. Chapter 12 Part 3. Sort a list. In a makefile, you often have a list of files. For example, let me have a list here. To sort this list, filter the text through the external sort command. / caret objs j, and then do : period comma / caret $, -1 bang sort. This goes to the first line where objs is the first thing in the line. Then it goes one line down and filters the lines until the next empty line. You could also select the lines in visual mode and then use bang sort. That's easier to type, but more work when there are many lines. The result is this. Notice that a / at the end of each line is used to indicate the line continues. After sorting, this is wrong. The backup.o line that was at the end didn't have a /. Now that it sorts to another place, it must have a /. The simplest solution is to add the / with capital A / escape. You can keep the / in the last line if you make sure an empty line comes after it. That way you don't have this problem again. Chapter 12 Part 4. Reverse line order. The :global command can be combined with the :move command to move all the lines before the first line, resulting in a reversed file. The command is :global / caret / move 0. Abbreviated, this is :g / caret / m0. The caret regular expression matches the beginning of the line even if the line is blank. The move command moves the matching line to after the imaginary zeroth line, so the current matching line becomes the first line of the file. As the :global command is not confused by the changing line numbering, :global proceeds to match all remaining lines of the file and puts each as the first. This also works on a range of lines. First move to above the first line and mark it with MT. Then move the cursor to the last line in the range and type :T+1, period G / M :T. Chapter 12, Part 5, Count Words. Sometimes you have to write a text with a maximum number of words. Vim can count the words for you. When the whole file is what you want to count the words in, use this command, G, G. Do not type a space after the G. This is just used here to make the command easy to read. The output looks like this: column 1 of 0, line 141 of 157, word 748 of 774, byte 4489 of 4976. You can see on which word you are, 748, and the total number of words in the file, 774. When the text is only part of a file, you could move to the start of the text. Type G, G, move to the end of the text, type G, G again, and then use your brain to compute the difference in the word position. That's a good exercise, but there is an easier way. With visual mode, select the text you want to count words in, then type G, G. The result? Selected 5 of 293 lines, 70 of 1884 words, 359 of 10928 bytes. For other ways to count words, lines, and other items, see count-items. Chapter 12, Part 6, Find the man page. While editing a shell script or C program, you are using a command or function that you want to find the man page for. This is on Unix. Let's first use a simple way. Move the cursor to the word you want to find help on and press capital K. Neovim will run :man on the word. If the man page is found, it is displayed. You can also use the :man command to open a window on a man page, :man CSH. You can scroll around and the text is highlighted. This allows you to find the help you were looking for. Use Ctrl+W to jump to the window with the text you are working on. To find the man page in a specific section, put the section number first. For example, to look in section 3 for echo, do man free echo. To jump to another man page, which is in the text with the typical form word 1, press Ctrl close square bracket on it. Further, man commands will use the same window. To display a man page for the word under the cursor, use this, capital K. For example, you want to know the return value of str open parentheses close parentheses while editing this line. If open parentheses str open parentheses input comma double quote aap double quote close parentheses equals close parentheses, move the cursor to somewhere on str and type capital K. A window will open to display the man page for str open parentheses close parentheses. Chapter 12, Part 7, Trim Blanks. Some people find spaces and tabs at the end of a line useless, wasteful, and ugly. To remove white space at the end of every line, execute the following command: %s /s +$+. The line range % is used, thus this works on the whole file. The pattern that the :substitute command matches with is \s +$. This finds white space characters \s, one or more of them \+, before the end of line $. Later will be explained how you write patterns like this. See usr_27.txt. The to part of the substitute command is empty, //. Thus it replaces with nothing, effectively deleting the matched white space. Another wasteful use of spaces is placing them before a tab. Often these can be deleted without changing the amount of white space, but not always. Therefore, you can best do this manually. Use this search command, / tab. You cannot see it, but there is a space before a tab in this command. Thus it's / tab. Now use X to delete the space and check that the amount of white space doesn't change. You might have to insert a tab if it does change. Type N to find the next match. Repeat this until no more matches can be found. Chapter 12, Part 8. Find where a word is used. If you are a Unix user, you can use a combination of vim and the grep command to edit all the files that contain a given word. This is extremely useful if you are working on a program and want to view or edit all the files that contain a specific variable. For example, suppose you want to edit all the C program files that contain the word frame_counter. To do this, you use the command vim backtick grep -l frame_counter *.c backtick. Let's look at this command in detail. The grep command searches through a set of files for a given word. Because the -l argument is specified, the command will only list the files containing the word and not print the matching lines. The word it is searching for is frame_counter. Actually, this can be any regular expression. Note, what grep uses for regular expressions is not exactly the same as what vim uses. The entire command is enclosed in backticks. This tells the Unix shell to run this command and pretend that the results were typed on the command line. So what happens is that the grep command is run and produces a list of files. These files are put on the vim command line. This results in vim editing the file list that is the output of grep. You can then use commands like :next and :first to browse through the files. Finding each line. The above command only finds the files in which the word is found. You still have to find the word within the files. Vim has a built-in command that you can use to search a set of files for a given string. If you want to find all occurrences of error_string and all C program files, for example, enter the following command: :grep error_string *.c. This causes Vim to search for the string error_string and all the specified files *.c. The editor will now open the first file where a match is found and position the cursor on the first matching line. To go to the next matching line, no matter in what file it is, use the :c next command. To go to the previous match, use the :c prev command. Use :c list to see all the matches and where they are. The :grep command uses the external commands grep on Unix or findstr on Windows. You can change this by setting the option grep prg. Typing command line commands quickly. Vim has a few generic features that makes it easier to enter commands. Commands can be abbreviated, edited, and repeated. Completion is available for nearly everything. Chapter 20, Part 1. Command line editing. When you use a command or search for a string with / or question mark, Vim puts the cursor on the bottom of the screen. There you type the command or search pattern. This is called the command line. Also, when it's used for entering a search command. The most obvious way to edit the command you type is by pressing the backspace key. This erases the character before the cursor. To erase another character, typed earlier, first move the cursor with the cursor keys. For example, you have typed this: :s /call /pig /. Before you hit enter, you notice that call should be cow. To correct this, you type left 5 times. The cursor is now just after call. Type backspace and W to correct. So now you have :s /cow /pig /. Now you can press enter directly. You don't have to move the cursor to the end of the line before executing the command. The most often used keys to move around in the command line are left, 1 character left, right, 1 character right, shift left or control left, 1 word left, shift right or control right, 1 word right, control B or home to begin of command line, control E or end to end of command line. Note: shift left, cursor left key with shift key pressed, and control left, cursor left key with control pressed will not work on all keyboards. Same for the other shift and control combinations. You can also use the mouse to move the cursor. Deleting. As mentioned, backspace deletes the character before the cursor. To delete a whole word, use Ctrl-W. So if we have /d fine pig, Ctrl-W at the end would leave you with the fine. Ctrl-U removes all text, thus allows you to start all over again. Overstrike. The insert key toggles between inserting characters and replacing the existing ones. Start with this text, /the fine pig. Move the cursor to the start of fine with Shift left twice, or left 8 times if Shift left doesn't work. Now press Insert to switch to overstrike and type great. You are now left with /the great pig. Whoops, we lost the space. Now don't use backspace because it would delete the T. This is different from replace mode. Instead, press Insert to switch from overstrike to inserting and type the space, /the great pig. Cancelling. You thought of executing a : or / command, but changed your mind. To get rid of what you already typed without executing it, press Ctrl-C or Escape. Note: Escape is the universal get out key. Unfortunately, in the good old Vi, pressing Escape in a command line executed the command. Since that might be considered to be a bug, Vim uses Escape to cancel the command. But with the CP options option, it can be made Vi compatible. And when using a mapping, which might be written for Vi, Escape also works Vi compatible. Therefore, using Ctrl-C is a method that always works. If you are at the start of the command line, pressing backspace will cancel the command. It's like deleting the : or / that the line starts with. Chapter 20, Part 2. Command line abbreviations. Some of the : commands are really long. We already mentioned that : substitute can be abbreviated to :s. This is a generic mechanism. All : commands can be abbreviated. How short can a command get? There are 26 letters and many more commands. For example, :set also starts with s, but :s doesn't start a :set command. Instead, :set can be abbreviated with :se. When the shorter form of a command could be used for 2 commands, it stands for only one of them. There is no logic behind which one, you have to learn them. In the help files, the shortest form that works is mentioned. For example, :s for substitute. This means that the shortest form of :substitute is :s. The following characters are optional, thus :su and :sub also work. In the user manual, we will either use the full name of command or a short version that is still readable. For example, :function can be abbreviated to :foo, but since most people don't understand what that stands for, we will use :fun. Vim doesn't have a :funny command, otherwise :fun would be confusing too. It is recommended that in Vim scripts you write the full command name. That makes it easier to read back when you make later changes. Except for some often used commands like :w for write and :r for read. A particularly confusing one is :end, which could stand for :end if, :end while, or :end function. Therefore, always use the full name. Short option names. In the user manual, the long version of the option name is used. Many options also have a short name. Unlike : commands, there is only one short name that works. For example, the short name of auto indent is AI. Thus these 2 commands do the same thing: :set auto indent and :set AI. You can find the full list of long and short names here, option-list. Chapter 20, Part 3. Command line completion. This is one of those Vim features that by itself is a reason to switch from Vi to Vim. Once you've used this, you can't do without. Suppose you have a directory that contains these files: info.txt, intro.txt, and bodyofthepaper.txt. To edit the last one, you use the command :edit bodyofthepaper.txt. It's easy to type this wrong. A much quicker way is :edit b-tab, which will result in the same command. What happened? The tab key does completion of the word before the cursor. In this case, B. Vim looks in the directory and finds only one file that starts with a B. That must be the one you are looking for, thus Vim completes the file name for you. Now type :edit I tab. Vim will beep and give you :edit info.txt. The beep means that Vim has found more than one match. It then uses the first match it found alphabetically. If you press tab again, you get :edit intro.txt. Thus, if the first tab doesn't give you the file you were looking for, press it again. If there are more matches, you will see them all one at a time. If you press tab on the last matching entry, you will go back to what you first typed, :edit I. Then it starts all over again. Thus Vim cycles through the list of matches. Use Ctrl-P to go through the list in the other direction. When you type :set I instead of :edit I and press tab, you get :set icon. Hey, why didn't you get :set info.txt? That's because Vim has context-sensitive completion. The kind of words Vim will look for depends on the command before it. Vim knows that you cannot use a file name just after a :set command, but you can use an option name. Again, if you repeat typing the tab, Vim will cycle through all matches. There are quite a few, it's better to type more characters first. :set isk tab gives :set is keyword. Now type equals and press tab. :set is keyword equals at, 48-57, _, 192-255. What happens here is that Vim inserts the old value of the option. Now you can edit it. What is completed with tab is what Vim expects in the place. Just try it out to see how it works. In some situations you will not get what you want. That's either because Vim doesn't know what you want, or because completion was not implemented for that situation. In that case, you will get a tab inserted, displayed as $I. List matches. When there are many matches, you would like to see an overview. Do this by pressing Ctrl-D. For example, pressing Ctrl-D after :set is results in set is, in C search, is fname, is ident, is keyword, is print, :set is. Vim lists the matches and then comes back with the text you typed. You can now check the list for the item you wanted. If it isn't there, you can use backspace to correct the word. If there are many matches, type a few more characters before pressing tab to complete the rest. If you have watched carefully, you will have noticed that in C search doesn't start with is. In this case, is stands for the short name of in C search. Many options have a short and long name. Vim is clever enough to know that you might have wanted to expand the short name of the option into the long name. There is more. The Ctrl-L command completes the word to the longest unambiguous string. If you type :edit I, and there are files info.txt and info_backup.txt, you will get :edit info. The wild mode option can be used to change the way completion works. The wild menu option can be used to get a menu-like list of matches. Use the suffixes options to specify files that are less important and appear at the end of the list of files. The wild ignore option specifies files that are not listed at all. More about all of this here, command line-completion. Chapter 20 Part 4, Command Line History. In Chapter 3 we briefly mentioned the history. The basics are that you can use the up key to recall an older command line. Down then takes you back to newer commands. There are actually 5 histories. The ones we will mention here are for : commands and for / and question mark search commands. The / and question mark commands share the same history because they are both search commands. The 3 other histories are for expressions, debug mode commands, and input lines for the input function, command line-history. Suppose you have done a :set command, typed 10 more : commands, and then want to repeat that :set command again. You could press : and then 10 times up. There is a quicker way. :se up. Vim will now go back to the previous command that started with se. You have a good chance that this is the :set command you were looking for. At least you should not have to press up very often, unless :set commands is all you have done. The up key will use the text typed so far and compare it with the lines of the history. Only matching lines will be used. If you do not find the line you were looking for, use down to go back to what you typed and correct that, or use Ctrl-U to start all over again. To see all the lines in the history, do :history. That's the history of : commands. The search history is displayed with this command, :history/. Ctrl-P will still work like up, except that it doesn't matter what you already typed. Similarly for Ctrl-N and down. Ctrl-P stands for previous, Ctrl-N for next. Chapter 20, Part 5, Command Line Window. Typing the text in the command line works differently from typing text in insert mode. It doesn't allow many commands to change the text. For most commands, that's okay, but sometimes you have to type a complicated command. That's where the command line window is useful. Open the command line window with this command, Q:. Vim now opens a small window at the bottom. It contains the command line history and an empty line at the end. You are now in normal mode. You can use the H-J-K-L keys to move around. For example, move up with 5k to the :econfig.h.in line. Type $h to go to the I of in and type CW out. Now you have changed the line to :econfig.h.out. Now press enter and this command will be executed. The command line window will close. The enter command will execute the line under the cursor. It doesn't matter whether Vim is in insert mode or in normal mode. Changes in the command line window are lost. They do not result in the history to be changed, except that the command you execute will be added to the end of the history, like with all executed commands. The command line window is very useful when you want to have overview of the history, look up a similar command, change it a bit and execute it. A search command can be used to find something. In the previous example, the $config search command could have been used to find the previous command that contains config. It's a bit strange because you are using a command line to search in the command line window. While typing that search command, you can't open another command line window. There can be only one. Go away and come back. This chapter goes into mixing the use of other programs with Vim, either by executing program from inside Vim, or by leaving Vim and coming back later. Furthermore, this is about the ways to remember the state of Vim and restore it later. Chapter 21, Part 1, Suspend and Resume. Like most Unix programs, Vim can be suspended by pressing Ctrl-Z. This stops Vim and takes you back to the shell it was started in. You can then do any other commands until you are bored with them, then bring back Vim with the FG command. So you do Ctrl-Z, any sequence of shell commands, and then FG. Editor's note, the FG stands for foreground. You are right back where you left Vim, nothing has changed. In case pressing Ctrl-Z doesn't work, you can also use :suspend. Don't forget to bring Vim back to the foreground, you would lose any changes that you made. Only Unix has support for this. On other systems, Vim will start a shell for you. This also has the functionality of being able to execute shell commands, but it's a new shell, not the one that you started Vim from. When you are running the GUI, you can't go back to the shell where Vim was started. Ctrl-Z will minimize the Vim window instead. Chapter 21, Part 2, Executing Shell Commands. To execute a single shell command from Vim, use :bang command. For example, to see a directory listing, do :bang ls, :bang dir. The first one is for Unix, the second one for Microsoft Windows. Vim will execute the program. When it ends, you will get a prompt to hit enter. This allows you to have a look at the output from the command before returning to the text you were editing. The bang is also used in other places where a program is run. Let's take a look at an overview. :bang program will execute program. :r bang program will execute the program and read its output. :w bang program will execute program and send text to its input. :range bang program will filter text through program. Notice that the presence of a range before bang program makes a big difference. Without, it executes the program normally. With the range, a number of text lines is filtered through the program. Executing a whole row of programs this way is possible, but a shell is much better at it. You can start a new shell with :terminal. This is similar to using Ctrl-Z to suspend Vim. The difference is that a new shell is started. Chapter 21, Part 3, Remembering Information. After editing for a while, you will have text in registers, marks in various files, and a command line history filled with carefully crafted commands. When you exit Vim, all of this is lost, but you can get it back. The SHADA, abbreviation of Shared Data file, is designed to store status information. Command line and search pattern history, text in registers, marks for various files, the buffer list, and global variables. Each time you exit Vim, it will store this information in a file, the SHADA file. When Vim starts again, the SHADA file is read and the information restored. The SHADA option is set by default to restore a limited number of items. You might want to set it to remember more information. This is done through the following command: :set SHADA equals string. The string specifies what to save. The syntax of this string is an option character followed by an argument. The option argument pairs are separated by commas. Take a look at how you can build up your own SHADA string. First, the single quote option is used to specify how many files for which you save marks, A to Z. Pick a nice even number for this option, 1000 for instance. Your command now looks like this: :set SHADA equals single quote 1000. The F option controls where the global marks, capital A to capital Z and 0 to 9, are stored. If this option is 0, none are stored. If it is 1 or you do not specify an F option, the marks are stored. You want this feature, so now you have this: :set SHADA equals single quote 1000, F1. The less than option controls how many lines are saved for each of the registers. By default, all the lines are saved. If 0, nothing is saved. To avoid adding thousands of lines to your SHADA file, which might never get used and makes starting Vim slower, you use a maximum of 500 lines. :set SHADA equals single quote 1000, F1, less than 500. Other options you might want to use: number of lines to save from the command line history, number of lines to save from the input line history, / number of lines to save from the search history. Removable media for which no marks will be stored, can be used several times. Bang, global variables that start with an uppercase letter and don't contain lowercase letters. Disable HL search highlighting when starting. The buffer list, only restored when starting Vim without file arguments. Convert the text using encoding. Name used for the SHADA file must be the last option. See the SHADA option and SHADA- file for more information. When you run Vim multiple times, the last one exiting will store its information. This may cause information that previously exiting Vim stored to be lost. Each item can be remembered only once. Getting back to where you stopped Vim. You are halfway through editing a file and it's time to leave for holidays. You exit Vim and go enjoy yourselves, forgetting all about your work. After a couple of weeks, you start Vim and type :0. And you are right back where you left Vim. So you can go on with your work. Vim creates a mark each time you exit Vim. The last one is :0. The position that :0 pointed to is made :1, and :1 is made to :2, and so forth. Mark :9 is lost. The :marks command is useful to find out where 0 to 9 will take you. Getting back to some file. If you want to go back to a file that you edited recently, but not when exiting Vim, there is a slightly more complicated way. You can see a list of files by typing the command: :old files, 1:/.config/nvim/init.vim, 2:/text/resume/txt, 3:/temp/draft. Now you would like to edit the second file, which is in the list preceded by 2:. You type :e#2. Instead of :E, you can use any command that has a file name argument. The #2 item works in the same place as %, or current file name, and # alternate file name. So you can also split the window to edit the third file. :split #3. That #123 thing is a bit complicated when you just want to edit a file. Fortunately, there is a simpler way. :browse old files, $.config/.nvim/init.vim, 2:text/resume/text, 3:temp/draft, more. You get the same list of files as with :old files. If you want to edit resume.txt, first press Q to stop the listing. You will get a prompt. Type number and enter, empty cancels. Type 2 and press enter to edit the second file. More info at :old files, v::old files, and c_#. Move info from one Vim to another. You can use the :w shader and :r shader commands to save and restore the information while still running Vim. This is useful for exchanging register contents between two instances of Vim, for example. In the first Vim, do :w shader bang ~temp/shader. And in the second Vim, do :r shader bang ~temp/shader. Obviously, the W stands for write and the R for read. The bang character is used by :w shader to forcefully overwrite an existing file. When it is omitted and the file exists, the information is merged into the file. The bang character used for :r shader means that all the information in shader file has priority over existing information. This may overwrite it. Without the bang, only information that wasn't set is used. These commands can also be used to store info and use it again later. You could make a directory full of shader files, each containing info for a different purpose. Chapter 21, Part 4, Sessions. Suppose you are editing along, and it is the end of the day. You want to quit work and pick up where you left off the next day. You can do this by saving your editing session and restoring it the next day. A Vim session contains all the information about what you are editing. This includes things such as the file list, window layout, global variables, options, and other information. Exactly what is remembered is controlled by the session options option described below. The following command creates a session file: :mk_session vimbook.vim. Later, if you want to restore this session, you can use this command: :source vimbook.vim. If you want to start Vim and restore a specific session, you can use the following command: vim-S vimbook.vim. This tells Vim to read a specific file on startup. The :S stands for session. Actually, you can source any Vim script with -S, thus it might as well stand for source. The windows that were open are restored with the same position and size as before. Mapping and option values are like before. What exactly is restored depends on the session options option. The default value is blank, buffers, cur-dir, folds, help, options, tab pages, win size, and terminal. Blank means keep empty windows. Buffers, all buffers, not only the ones in a window. Cur-dir, the current directory. Folds, also manually created ones. Help, the help window. Options, all options and mappings. Tab pages, all tab pages. Win size, window sizes. Terminal, include terminal window. Change this to your liking. To also restore the size of the Vim window, for example, use :set session options += resize. Session here, session there. The obvious way to use sessions is when working on different projects. Suppose you store your session files in the directory ~.config/nvim. You are currently working on the secret project and have to switch to the boring project. :wall, :mk_session bang .config/nvim/secret.vim, :source.config/nvim/boring.vim. The first uses :w all to write all modified files. Then the current session is saved using :mk session bang. This overrides the previous session. The next time you load the secret session, you can continue where you were at this point. And finally, you load the new boring session. If you open help windows, split and close various windows, and generally mess up the window layout, you can go back to the last saved session by doing :source.config/nvim/boring.vim. Thus, you have complete control over whether you want to continue next time where you are now, by saving the current setup in a session, or keep the session file as a starting point. Another way of using sessions is to create a window layout that you like to use and save this in a session. Then you can go back to this layout whenever you want. For example, this is a nice layout to use. And it gives an example here. This has a help window at the top so you can read this text. The narrow vertical window on the left contains a file explorer. This is a Vim plugin that lists the contents of a directory. You can select files to edit there. More about this in the next chapter. Create this from a just started Vim with :help, Ctrl-WW, :vertical split ~/. You can resize the window a bit to your liking, then save the session with :mk session .config/nvim/mine.vim. Now you can start a Vim with this layout, vim-S .config/nvim/mine.vim. Hint: to open a file you see listed in the Explorer window, in the empty window, move the cursor to the file name and press O. Double-clicking with the mouse will also do this. Sessions in Shada. Sessions store many things, but not the position of marks, contents of registers, and the command line history. You need to use the Shada feature for these things. In most situations, you will want to use sessions separately from Shada. This can be used to switch to another session, but keep the command line history, and yank text into registers in one session and paste it back in another session. You might prefer to keep the info with the session. You will have to do this yourself then. Example: :mk session bang .config nvim secret.vim. :w shada bang .local state nvim shada secret.shada. And to restore this again, :source.config nvim secret.vim, and then :r shada bang .local state nvim shada secret.shada. Chapter 21, Part 5. Views. A session stores the looks of the whole of Vim. When you want to store the properties for one window only, use a view. The use of a view is for when you want to edit a file in a specific way. For example, you have line numbers enabled with the number option and defined a few folds. Just like with sessions, you can remember this view on the file and restore it later. Actually, when you store a session, it stores the view of each window. There are two basic ways to use views. The first is to let Vim pick a name for the view file. You can restore the view when you later edit the same file. To store the view for the current window, do :mk view. Vim will decide where to store the view. When you later edit the same file, you get the view back with this command, :load view. That's easy, isn't it? Now you want to view the file without the number option on, or with all folds open. You can set the options to make the window look that way. Then store this view with :mk view 1. Obviously, you can get this back with :load view 1. Now you can switch between the two views on the file by using :load view with and without the 1 argument. You can store up to 10 views for the same file this way, 1 unnumbered and 9 numbered 1 to 9. A view with a name. The second basic way to use views is by storing the view in a file with a name you choose. This view can be loaded while editing another file. Vim will then switch to editing the file specified in the view. Thus, you can use this to quickly switch to editing another file with all its options set as you saved them. For example, to save the view of the current file, do :mkview.config nvim main.vim. You can restore it with :source.config nvim main.vim. Chapter 21, Part 6. Mode lines. When editing a specific file, you might set options specifically for that file. Typing these commands each time is boring. Using a session or view for editing a file doesn't work when sharing the file between several people. The solution for this situation is adding a mode line to the file. This is a line of text that tells Vim the values of options to be used in this file only. A typical example is a C program where you make indents by a multiple of 4 spaces. This requires setting the shift width option to 4. This mode line will do that. / vim set shift width equals 4 * tilde. Put this line as one of the first or last 5 lines in the file. When editing the file, you will notice that shift width will have been set to 4. When editing another file, it's set back to the default value of 8. For some files, the mode line fits well in the header, thus it can be put at the top of the file. For text files and other files where the mode line gets in the way of the normal contents, put it at the end of the file. The mode lines option specifies how many lines at the start and end of the file are inspected for containing a mode line. To inspect 10 lines, do :set mode lines equals 10. The mode line option can be used to switch this off. Do this when you are working as root on Unix or administrator on Microsoft Windows, or when you don't trust the files you are editing. :set no mode line. Use this format for the mode line. Any -text vim :set option in curly braces equals value in curly braces 3 dots any -text. The any -text indicates that you can put any text before and after the part that Vim will use. This allows making it look like a comment, like what was done above with / and */. The Vim : part is what makes Vim recognize this line. There must be white space before Vim, or Vim must be at the start of the line. Thus, using something like gvim : will not work. The part between the colons is a :set command. It works the same way as typing the :set command, except that you need to insert a / before a colon. Otherwise, it would be seen as the end of the mode line. Another example: / vim :set text width equals 72 equals c / temp : use c : temp here. There is an exact / before the first colon, so that it's included in the :set command. The text after the second colon is ignored, thus a remark can be placed there. For more information, see mode line. Finding the file to edit. Files can be found everywhere. So how do you find them? Vim offers various ways to browse the directory tree. There are commands to jump to a file that is mentioned in another, and Vim remembers which files have been edited before. Chapter 22, Part 1, The File Browser. Vim has a plugin that makes it possible to edit a directory. Try this: :edit period. Through the magic of auto commands in Vim scripts, the window will be filled with the contents of the directory. It looks like this. You can see these items. 1. The name of the browsing tool and its version number. 2. The name of the browsing directory. 3. The method of sorting, maybe by name, time, or size. 4. How names are to be sorted, directories first, then *.h files, *.c files, etc. 5. How to get help, use the F1 key and an abbreviated listing of available commands. 6. A listing of files including .. which allows one to list the parent directory. If you have syntax highlighting enabled, the different parts are highlighted so as to make it easier to spot them. You can use normal mode Vim commands to move around in the text. For example, move the cursor atop a file and press Enter. You will then be editing that file. To go back to the browser, use :edit period again, or use :explore. Ctrl-O also works. Try using Enter while the cursor is atop a directory name. The result is that the file browser moves into that directory and displays the items found there. Pressing Enter on the first directory : moves you one level higher. Pressing dash does the same thing without the need to move to the / item first. You can press F1 to get help on the things you can do in the netrw file browser. This is what you get. So F1 stands for help, Garage return or enter stands for browsing. Delete, deleting files or directories. Dash stands for going up. A, hiding files or directories. MB, bookmarking a directory. GB, changing to a bookmarked directory. CD, make browsing directory the current directory. Lowercase d, make a new directory. Uppercase D, deleting files or directories. Control H, edit file directory hiding list. I, change listing style. Control L, refreshing the listing. O, browsing with a horizontal split. P, use preview window. Capital P, edit in previous window. Q, listing bookmarks in history. R, reversing sorting order, etc. The F1 key thus brings you to a netrw directory browsing contents help page. It's a regular help page. Use the usual Control right square bracket to jump to tagging help items and Control O to jump back. To select files for display and editing, with the cursor is atop a file name. Enter, open the file in the current window. O, horizontally split window and display file. V, vertically split window and display file. P, use the preview dash window. Capital P, edit in the previous window. T, open file in a new tab. The following normal mode commands may be used to control the browser display. I, controls listing style, thin, long, wide, and tree. The long listing includes size and date information. S, repeatedly pressing S will change the way the files are sorted. One may sort on name, modification time, or size. R, reverse the sorting order. As a sampling of extra normal mode commands, CD will change Vim's notion of the current directory to be the same as the browser directory. CG:netrw_keepdir to control this too. Capital R, rename the file or directory under the cursor. A prompt will be issued for the new name. Capital D, delete the file or directory under the cursor. A confirmation request will be issued. MB/GB, make bookmark / go to bookmark. One may also use command mode, again just a sampling. Explore directory, browse specified / current directory. netrw settings, a comprehensive list of your current netrw settings with help linkage. The netrw browser is not limited to just your local machine. One may use URLs such as explore ftp // some host /path /to /dir /e scp / some host /path /to /dir /. That trailing / is important. See netrw-browse for more. Chapter 22 Part 2, The Current Directory. Just like the shell, Vim has the concept of a current directory. Suppose you are in your home directory and want to edit several files in a directory, very long file name. You could do edit very long file name / file1.txt, file2.txt, file3.txt, or to avoid much of the typing, do this: cd very long file name, edit file1.txt, edit file2.txt, edit file3.txt. The cd command changes the current directory. You can see what the current directory is with the pwd command. pwd, home, bram, very long file name. Vim remembers the last directory that you need. Use cd- to go back to it. Example: pwd, home, bram, very long file name, cd, etc, pwd, etc, cd- pwd, home, bram, very long file name, cd- pwd, etc. Window local directory. When you split a window, both windows use the same current directory. When you want to edit a number of files somewhere else in the new window, you can make it using a different directory without changing the current directory in the other window. This is called a local directory. pwd. Home, bram, very long file name, split, lcd, etc, pwd, etc, control ww, pwd, home, bram, very long file name. So long as no lcd command has been used, all windows share the same current directory. Doing a cd command in one window will also change the current directory of the other window. For a window where :lcd has been used, a different current directory is remembered. Using :cd or :lcd in other windows will not change it. When using a cd command in a window that uses a different current directory, it will go back to using the shared directory, tab local directory. When you open a new tab page, it uses the directory of the window in the previous tab page from which the new tab page was opened. You can change the directory of the current tab page using the :tcd command. All the windows in the tab page share this directory except for windows with a window-local directory. Any new windows opened in this tab page will use this directory as the current working directory. Using a :cd command in a tab page will not change the working directory of tab pages which have a tab local category. When the global working directory is changed using the :cd command in a tab page, it will also change the current tab page working directory. Chapter 22, Part 3, Finding a File. You are editing a C program that contains this line, #include inits.h in double quotes. You want to see what is in that inits.h file. Move the cursor on the name of the file and type gf. Vim will find the file and edit it. What if the file is not in the current directory? The path option to find the file. This option is a list of directory names where to look for your file. Suppose you have your include files located in C prog include. This command will add it to the path option. :set path plus equals C :prog/include. This directory is an absolute path. No matter where you are, it will be the same place. What if you have located files in a subdirectory below where the file is? Then you can specify a relative file path. This starts with a dot. :set path plus equals ;proto. This tells Vim to look in the directory proto, below the directory where the file in which you use gf is. Thus using gf on inits.h will make Vim look for proto:\inits.h, starting in the directory of the file. Without the ;/, thus proto, Vim would look in the proto directory below the current directory, and the current directory might not be where the file that you are editing is located. The path option allows specifying the directories where to search for files in many more ways. See the help on the path option. The isFname option is used to decide which characters are included in the file name and which ones are not. Example, the double quote character in the example above. When you know the file name but it's not to be found in the file, you can type it by doing :find inits.h. Vim will then use the path option to try and locate the file. This is the same as the :edit command except for the use of path. To open the found file in a new window, use Ctrl+WF instead of GF, or use :sfind instead of :find. A nice way to directly start Vim to edit a file somewhere in the path is vim +find stdio.h . This finds the file stdio.h in your value of path. The quotes are necessary to have one argument, --c. Chapter 22, Part 4, The Buffer List. The Vim editor uses the term buffer to describe a file being edited. Actually, a buffer is a copy of the file that you edit. When you finish changing the buffer, you write the contents of the buffer to the file. Buffers not only contain file contents, but also the marks, settings, and other stuff that goes with it. Hidden buffers. Suppose you are editing the file 1.txt and need to edit the file 2.txt. You could simply use :edit 2.txt, but since you made changes to 1.txt, that won't work. You also don't want to write 1.txt yet. Vim has a solution for you. :hide edit 2.txt. The buffer 1.txt disappears from the screen, but Vim still knows that you are editing this buffer, so it keeps the modified text. This is called a hidden buffer. The buffer contains text, but you can't see it. The argument of :hide is another command. :hide makes that command behave as if the hidden option was set. You could also set this option yourself. The effect is that when any buffer is abandoned, it becomes hidden. Be careful, when you have hidden buffers with changes, don't exit Vim without making sure you have saved all the buffers. Inactive buffers. When a buffer has been used once, Vim remembers some information about it. When it is not displayed in a window and it is not hidden, it is still in the buffer list. This is called an inactive buffer. Overview. Active. Appears in a window, text loaded. Hidden. Not in a window, text loaded. Inactive. Not in a window, no text loaded. The inactive buffers are remembered because Vim keeps information about them, like marks. And remembering the file name is useful too, so that you can see which files you have edited, and edit them again. Listing buffers. View the buffer list with this command, :buffers. A command which does the same is not so obvious to list buffers, but is much shorter to type, :ls. The output could look like this. 1. #h help.txt line 62, 2 %a plus usr_21.txt line 1, 3 usr_toc.txt line 1. The first column contains the buffer number. You can use this to edit the buffer without having to type the name, see below. After the buffer number come the flags. Then the name of the file and the line number where the cursor was the last time. The flags that can appear are these from left to right. U, buffer is unlisted, unlisted-buffer, %, current buffer, # alternate buffer, A, buffer is loaded and displayed, H, buffer is loaded but hidden, equals buffer is read-only, dash, buffer is not modifiable, the modifier option is off, plus buffer has been modified. Editing a buffer. You can edit a buffer by its number. That avoids having to type the file name, :buffer2. But the only way to know the number is by looking in the buffer list. You can use the name or part of it instead, :buffer help. Vim will find the best match for the name you type. If there is only one buffer that matches the name, it will be used, in this case help.txt. To open a buffer in a new window, do sbuffer3. This works with a name as well. Using the buffer list. You can move around in the buffer list with these commands. :b next, go to next buffer, :b previous, go to previous buffer, :b first, go to the first buffer, :b last, go to the last buffer. To remove a buffer from the list, use this command, :b delete 3. Again, this also works with a name. If you delete a buffer that was active, visible in a window, that window will be closed. If you delete the current buffer, the current window will be closed. If it was the last window, Vim will find another buffer to edit. You can't be editing nothing. Note: even after removing the buffer with :b delete, Vim still remembers it. It's actually made unlisted. It no longer appears in the list from :buffers. :buffers bang command will list unlisted buffers. Yes, Vim can do the impossible. To really make Vim forget about a buffer, use :b wipe. Also use the buff listed option. Editing other files. This chapter is about editing files that are not ordinary files. With Vim, you can edit files that are compressed. Some files need to be accessed over the internet. With some restrictions, binary files can be edited as well. Chapter 23, Part 1. DOS, Mac, and Unix files. Back in the early days, the old teletype machines used 2 characters to start a new line. One to move the carriage back to the first position, carriage return or CR. Another to move the paper up, line feed or LF. When computers came out, storage was expensive. Some people decided that they did not need 2 characters for end of line. The Unix people decided they could use new line or NL only for end of line. The Apple people standardized on CR. The Microsoft Windows folks decided to keep the old CR-NL. We use NL for line feed in the help text. This means that if you try to move a file from one system to another, you have line break problems. The Vim editor automatically recognizes the different file formats and handles things properly behind your back. The option file formats contains the various formats that will be tried when a new file is edited. The following command, for example, tells Vim to try Unix format first and MS-DOS format second. :set file formats equals Unix, DOS. You will notice the format in the message you got when editing a file. You don't see anything if you edit a native file format, thus editing a Unix file on Unix won't result in a remark. But when you edit a DOS file, Vim will notify you of this. Temp test DOS FreeL71C. For a Mac file, you would see Mac. The detected file format is stored in the file format option. To see which format you have, execute the following command: :set file format ? The three names that Vim uses are Unix, new line, DOS, carriage return, new line, Mac, carriage return. Using the Mac format. On Unix, new line is used to break a line. It's not unusual to have a carriage return character halfway in a line. Incidentally, this happens quite often in Vi and Vim scripts. On the Macintosh, where carriage return is the line break character, it's possible to have a new line character halfway in a line. The result is that it's not possible to be 100% sure whether a file contains both carriage return and new line characters is a Mac or a Unix file. Therefore, Vim assumes that on Unix you probably won't edit a Mac file and doesn't check for this type of file. To check for this type of format anyway, add Mac to file formats. :set file formats plus equals Mac. Then Vim will take a guess at the file format. Watch out for situations where Vim guesses wrong. Overruling the format. If you use the good old Vi and try to edit an MS-DOS format file, you will find that each line ends with a $M character. $M is carriage return. The automatic detection avoids this. Suppose you do want to edit the file that way, then you need to overrule the format. :edit ++ff equals Unix file.txt. The ++ string is an item that tells Vim that an option name follows, which overrules the default for this single command. ++ff is used for file format. You could also use ++ff equals Mac or ++ff equals DOS. This doesn't work for any option, only ++ff and ++enc are currently implemented. The full names ++ file format and ++ encoding also work. Conversion. You can use the file format option to convert from one file format to another. Suppose, for example, that you have an MS-DOS file named readme.txt that you want to convert to Unix format. Start by editing the MS-DOS format file, vim readme.txt. Vim will recognize this as a DOS format file. Now change the file format to Unix, :set file format equals Unix, :write. The file is written in Unix format. Chapter 23, Part 2, Files on the Internet. Someone sends you an email message which refers to a file by its URL. For example, you can find the information here, ftp://ftp.vim.org/pub/vim/readme. You can start a program to download the file, save it in your local disk, and then start Vim to edit it. There is a much simpler way. Move the cursor to any character of the URL, then use this command, gf. With a bit of luck, Vim will figure out which program to use for downloading the file, download it, and edit the copy. To open the file in a new window, use Ctrl+WF. If something goes wrong, you will get an error message. It's possible that the URL is wrong, you don't have permissions to read it, the network connection is down, etc. Unfortunately, it's hard to tell the cause of the error. You might want to try the manual way of downloading the file. Accessing files over the internet works with the netrw plugin. Currently, URLs with these formats are recognized. FTTP uses FTP, RCP uses RCP, SCP uses SCP, HTTP uses wget for reading only. Vim doesn't do the communication itself, it relies on the mentioned programs to be available on your computer. On most Unix systems, FTP and RCP will be present. SCP and wget might need to be installed. Vim detects these URLs for each command that starts editing a new file, also with :edit and :split, for example. Write commands also work except for HTTP. For more information, also about passwords, see netrw. Chapter 23, Part 3, Binary Files. You can edit binary files with Vim. Vim wasn't really made for this, thus there are a few restrictions. But you can read a file, change a character and write it back with the result that only that one character was changed, and the file is identical otherwise. To make sure that Vim does not use its clever tricks in the wrong way, add the -b argument when starting Vim. Vim-b data file. This sets the binary option. The effect of this is that unexpected side effects are turned off. For example, text width is set to 0 to avoid automatic formatting of lines. And files are always read in Unix file format. Binary mode can be used to change a message in a program. Be careful not to insert or delete any characters, it would stop the program from working. Use R to enter replace mode. Many characters in the file will be unprintable. To see them in hex format, do :set display equals uhex. Otherwise, the GA command can be used to see the value of the character under the cursor. The output when the cursor is on an escape looks like this. Less than caret, open square bracket greater than 27, hex 1b, octal 033. There might not be many line breaks in the file. To get some overview, switch the wrap option off, :set no wrap. Byte position. To see on which byte you are in the file, use this command, G-Control-G. The output is verbose. Column 9 to 16 of 9 to 16, line 277 of 330, words 1806 of 2058, byte 10580 of 12206. The last two numbers are the byte position in the file and the total number of bytes. This takes into account how file format changes the number of bytes that a line break uses. To move to a specific byte in the file, use the go command. For example, to move to byte 2345, do 2345 go. Using XXD. A real binary editor shows the text in two ways, as it is and in hex format. You can do this in Vim by first converting the file with the XXD program. This comes with Vim. First edit the file in binary mode, Vim-b data file. Now convert the file to a hex dump with XXD, $bang XXD. The text will look like this. You can now view and edit the text as you like. Vim treats the information as ordinary text. Changing the hex does not cause the printable character to be changed, or the other way around. Finally, convert it back with :bang XXD-R. Only changes in the hex part are used. Changes in the printable text part on the right are ignored. See the manual page of XXD for more information. Chapter 23, Part 4, Compressed Files. This is easy. You can edit a compressed file just like any other file. The gzip plugin takes care of decompressing the file when you edit it, and compressing it again when you write it. These compression methods are currently supported. Z for compress, GZ for gzip, BZ2 for bzip2. Vim uses the mentioned programs to do the actual compression and decompression. You might need to install the programs first. Inserting quickly. When entering text, Vim offers various ways to reduce the number of keystrokes and avoid typing mistakes. Use insert mode completion to repeat previously typed words. Abbreviate long words to short ones. Type characters that aren't on your keyboard. Chapter 24, Part 1, Making Corrections. The backspace key was already mentioned. It deletes the character just before the cursor. The del key does the same for the character under or after the cursor. When you typed a whole wrong word, use Ctrl-W. The horse had fallen to the sky. Doing Ctrl-W will leave you with the horse had fallen to the. If you really messed up a line and want to start over, use Ctrl-U to delete it. This keeps the text after the cursor and the indent. Only the text from the first non-blank to the cursor is deleted. With the cursor on the F of fallen in the next line, pressing Ctrl-U does this. The horse had fallen to thee will do fallen to thee. When you spot a mistake a few words back, you need to move the cursor there to correct it. For example, you typed this: "The horse had fallen to the ground." You need to change fallen to fallen. With the cursor at the end, you would type this to correct it. You would do escape for BLRA and then capital A. Escape would get you out of insert mode. 4B would do 4 words back. L would move on top of the O. RA would replace with A, and capital A would restart insert mode. Another way to do this is Control left, Control left, Control left, Control left, right, delete, A, end. Doing Control left 4 times would go 4 words back. Doing right would move on top of the O. Doing delete would delete the O. Doing A would insert an A. And doing end would go to the end of the line. This uses special keys to move around while remaining in insert mode. This resembles what you would do in a modeless editor. It's easier to remember, but takes more time. You have to move your hands from the letters to the cursor keys, and the N key is hard to press without looking at the keyboard. These special keys are most useful when writing a mapping that doesn't leave insert mode. The extra typing doesn't matter then. An overview of the keys you can use in insert mode is Control Home to start of the file, Page Up a whole screen full up, Home to start of line, Shift Left 1 word left, Control Left 1 word left, Shift Right 1 word right, Control Right 1 word right, End to end of line, Page Down a whole screen full down, Control End to end of file. There are a few more. See INS-special-special. Chapter 24 Part 2, Showing Matches. When you type a close parentheses, it would be nice to see with which open parentheses it matches. To make Vim do that, use this command, :set show match. When you now type a text like example in parentheses, as soon as you type the close parentheses, Vim will briefly move the cursor to the matching open parentheses. Keep it there for half a second and move back to where you were typing. In case there is no matching open parentheses, Vim will beep. Then you know that you might have forgotten the open parentheses somewhere or typed a close parentheses too many. The match will also be shown for square brackets and curly pairs. You don't have to wait with typing the next character. As soon as Vim sees it, the cursor will move back and inserting continues as before. You can change the time Vim waits with the match time option. For example, to make Vim wait 1.5 seconds, do :set match time equals 15. The time is specified in tenths of a second. Chapter 24 Part 3, Completion. Vim can automatically complete words on insertion. You type the first part of a word, press Ctrl P and Vim guesses the rest. Suppose, for example, that you are creating a C program and want to type in the following: total equals ch_array0 plus ch_array1 plus ch_array2. You start by entering the following: total equals ch_array0 plus ch_. At this point, you tell Vim to complete the word using the command Ctrl P. Vim searches for a word that starts with what's in front of the cursor. In this case, it's ch_, which matches with the word ch_array. So typing Ctrl P gives you the following: total equals ch_array0 plus ch_array. After a little more typing, you get to this, ending in a space. Total equals ch_array0 plus ch_array1 plus. If you now type Ctrl P, Vim will search again for a word that completes the word before the cursor. Since there is nothing in front of the cursor, it finds the first word backwards, which is ch_array. Typing Ctrl P again gives you the next word that matches, in this case total. A third Ctrl P searches further back. If there is nothing else, it causes the editor to run out of words, so it returns to the original text, which is nothing. A fourth Ctrl P causes the editor to start over again with ch_array. To search forward, use Ctrl N. Since the search wraps around the end of the file, Ctrl N and Ctrl P will find the same matches, but in a different sequence. Hint: Ctrl N is next match and Ctrl P is previous match. The Vim editor goes through a lot of effort to find words to complete. By default, it searches the following places: 1. Current file. 2. Files in other windows. 3. Other loaded files or hidden buffers. 4. Files which are not loaded, inactive buffers. 5. Tag files. 6. All files # included by the current file. Options. You can customize the search order with the complete option. The ignore case option is used. When it is set, case differences are ignored when searching for matches. A special option for completion is infer case. This is useful to find matches while ignoring case. Ignore case must be set but still using the case of the word typed so far. Thus, if you type 4 and Vim finds a match, fortunately it will result in fortunately. Completing specific items. If you know what you are looking for, you can use these commands to complete with a certain type of item. Ctrl-X, Ctrl-F, file names, Ctrl-X, Ctrl-L, whole lines, Ctrl-X, Ctrl-D, macro definitions, also in included files, Ctrl-X, Ctrl-I, current and included files, Ctrl-X and Ctrl-K, words from a dictionary, Ctrl-X and Ctrl-T, words from a thesaurus, Ctrl-X and Ctrl close square bracket, tags, Ctrl-X and Ctrl-V, Vim command line. After each of them, Ctrl-N can be used to find the next match, Ctrl-P to find the previous match. More information for each of these commands here. ins-completion. Completing file names. Let's take Ctrl-X and Ctrl-F as an example. This will find file names. It scans the current directory for files and displays each one that matches the word in front of the cursor. Suppose, for example, that you have the following files in the current directory: main.c, sub_count.c, sub_done.c, sub_edit.c. Now enter insert mode and start typing. The exit code is in the file sub. At this point you enter the command Ctrl-X, Ctrl-F. Vim now completes the current word sub by looking at the files in the current directory. The first match is sub_count.c. This is not the one you want, so you match the next file by typing Ctrl-N. This match is sub_done.c. Typing Ctrl-N again takes you to the sub_exit.c. The results: the exit code in the file sub_exit.c. If the file name starts with /, like on Unix, or C:\/ like on Microsoft Windows, you can find all files in the file system. For example, type /u and Ctrl-X, Ctrl-F. This will match /user, this is on Unix. The file is found in /usr/. If you now press Ctrl-N, you go back to /u. Instead, to accept the /usr/ and go one directory level deeper, use Ctrl-X, Ctrl-F again. The file is found in /usr/x11r6. The results depend on what is found in your file system, of course. The matches are sorted alphabetically. Completing in source code. Source code files are well structured. This makes it possible to do completion in an intelligent way. In Vim, this is called omni-completion. In some other editors, it's called IntelliSense, but that is a trademark. The key to omni-completion is Ctrl-X, Ctrl-O. Obviously the O stands for omni here, so that you can remember it easier. Let's use an example for editing C source. Open curly bracket, struct foo *p, semicolon, p right arrow. The cursor is after p right arrow. Now type Ctrl-X, Ctrl-O. Vim will offer you a list of alternatives, which are the items that struct foo contains. That is quite different from using Ctrl-P, which would complete any word, while only members of struct foo are valid here. For omni-completion to work, you may need to do some setup. At least make sure file type plugins are enabled. Your vimrc file should contain a line like this: file type plugin on or file type plugin indent on. For C code, you need to create a tag file and set the tags option. That is explained ft-c.omni. For other file types, you may need to do something similar. Look below compl-omni-file types. It only works for specific file types. Check the value of the omnifunc option to find out if it would work. Chapter 24, Part 4, Repeating an insert. If you press Ctrl-A, the editor inserts the text you typed the last time you were in insert mode. Assume, for example, that you have a file that begins with the following: file.h in double quotes tilde / main program begins */ tilde. You edit this file by inserting #include at the beginning of the first line, so that it becomes #include file.h in double quotes tilde / main program begins */ tilde. You go down to the beginning of the next line using the commands j-caret. You now start to insert a new #include line, so you type I-Control-A. The result is as follows: #include file.h in double quotes tilde #include / main program begins */ tilde. The #include was inserted because Control-A inserts the text of the previous insert. Now you type main.h, enter to finish the line. #include file.h tilde #include main.h tilde / main program begins */ tilde. The Control-Add command does a Control-A and then exits insert mode. That's a quick way of doing exactly the same insertion again. Chapter 24, Part 5. Copying from another line. The Control-Y command inserts the character above the cursor. This is useful when you are duplicating a previous line. For example, you have this line of C code. Now you need to type the same line, but with s_prev instead of s_next. Start the new line and press Ctrl-Y 14 times until you are at the end of next. Now you type prev. Continue pressing Ctrl-Y until the following next. Now type prev to finish it off. The Ctrl-E command acts like Ctrl-Y, except it inserts the character below the cursor. Chapter 24, Part 6. Inserting a register. The command Ctrl-R register inserts the contents of the register. This is useful to avoid having to type a long word. For example, you need to type this: r equals very long function A plus very long function B plus very long function C. The function name is defined in a different file. Edit that file and move the cursor on top of the function name there, and yank it into register V. So you do double quote VYIW. Double quote V is the register specification. YIW is yank in a word. Now edit the file where the new line is to be inserted and type the first letters. R equals. Now use Ctrl-R-V to insert the function name. R equals very long function. You continue to type the characters in between the function name and use Ctrl-R-V 2 times more. You could have done the same with completion. Using a register is useful when there are many words that start with the same characters. If the register contains characters such as backspace or other special characters, they are interpreted as if they had been typed from the keyboard. If you do not want this to happen, you literally want the backspace to be inserted in the text, use the command Ctrl-R register. Chapter 24, Part 7. Abbreviations. An abbreviation is a short word that takes the place of a long one. For example, AD stands for advertisement. Vim enables you to type an abbreviation and then will automatically expand it for you. To tell Vim to expand add into advertisement every time you insert it, use the following command: :iabrev AD advertisement. Now, when you type AD, the whole word advertisement will be inserted into the text. This is triggered by typing a character that can't be part of a word, for example a space. So if you type I saw the ad and then you press space after ad, that will be converted to I saw the advertisement. The expansion doesn't happen when typing just add. That allows you to type a word like add, which will not get expanded. Only whole words are checked for abbreviations. Abbreviating several words. It is possible to define an abbreviation that results in multiple words. For example, to define JB as Jack Benny, use the following command: :iabrev JB Jack Benny. As a programmer, I used the rather unusual abbreviations :iabrev #B turns into / loads of asterisks, and :iabrev #E turns into space, a bunch of asterisks /. These are used for creating boxed comments. The comment starts with #B, which draws the top line. I then type the comment text and use #e to draw the bottom line. Notice that the #e abbreviation begins with a space. In other words, the first two characters are space *. Usually Vim ignores spaces between the abbreviation and the expansion. To avoid that problem, I spell space as 7 characters. Less than, SPACE greater than. Note, :I abbrev is a long word to type. :IAB works just as well. That's abbreviating the abbreviate command. Fixing typing mistakes. It's very common to make the same typing mistake every time. For example, typing TEH instead of the. You can fix this with an abbreviation. :abbreviate TEH to the. You can add a whole list of these. Add one each time you discover a common mistake. Listing abbreviations. The :abbreviate command lists the abbreviations. :abbreviate will do I, #e, bunch of asterisks, / I, #b, / a bunch of asterisks, I, JB, Jack Benny, I, AD, advertisement, bang, TEH, the. The I in the first column indicates insert mode. These abbreviations are only active in insert mode. Other possible characters are C for command line mode, :CABBRAV, bang, both insert and command line mode, :abbreviate. Since abbreviations are not often used in command line mode, you will mostly use the :I abbrev command. That avoids, for example, that add gets expanded when typing a command like :edit add. Deleting abbreviations. To get rid of abbreviations, use the :unabbreviate command. Suppose you have the following abbreviation, :abbreviate @fresh. You can remove it with this command, :unabbreviate @f. While you type this, you will notice that @f is expanded to fresh. Don't worry about this, Vim understands it anyway, except when you have an abbreviation for fresh, but that's very unlikely. To remove all the abbreviations, do :ab clear. :unabbreviate and :ab clear also come in the variants for insert mode, :I unabbreviate and :iab clear, and command line mode, :C unabbreviate and :cab clear. Remapping abbreviations. There is one thing to watch out for when defining an abbreviation. The resulting string should not be mapped. For example, :abbreviate @a adder, :imap dd disk-door. When you now type @a, you will get a disk door. That's not what you want. To avoid this, use the :no-re-abbrev command. It does the same as :abbreviate, but avoids that the resulting string is used for mappings. So you would do :no-rev-abbrev @a adder. Fortunately, it's unlikely that the result of an abbreviation is mapped. Chapter 24, Part 8. Entering special characters. The Ctrl-V command is used to insert the text characters literally. In other words, any special meaning the character has, it will be ignored. For example, Ctrl-V escape. Inserts an escape character. Thus you don't leave insert mode. Don't type the space after Ctrl-V, it's only to make this easier to read. Note: on Microsoft Windows, Ctrl-V is used to paste text. Use Ctrl-Q instead of Ctrl-V. On Unix, on the other hand, Ctrl-Q does not work on some terminals because it has a special meaning. You can also use the command Ctrl-V digits to insert a character with the decimal number digits. For example, the character number 127 is the del character, but not necessarily the del key. To insert del, type Ctrl-V 127. You can enter characters up to 255 this way. When you type fewer than 2 digits, a non-digit will terminate the command. To avoid the need of typing a non-digit, prepend 1 or 2 zeros to make 3 digits. All the next commands insert a tab and then a dot. Ctrl-V 9 period, Ctrl-V 09 period, Ctrl-V 009 period. To enter a character in hexadecimal, use an X after the Ctrl-V. Ctrl-V X7F. This also goes up to character 255, Control V XFF. You can use O to type a character as an octal number, and two more methods allow you to type up to a 16-bit and a 32-bit number. Example for a Unicode character. So you could do Control V O123, Control V U1234, Control V capital U 1 2 3 4 5 6 7 8. Chapter 24, Part 9, Digraphs. Some characters are not on the keyboard. For example, the copyright character. To type these characters in Vim, you use digraphs, where two characters represent one. To enter a copyright symbol, for example, you press three keys, Control K, capital C, lowercase o. To find out what digraphs are available, use the following command, :digraphs. Vim will display the digraph table. Here are 3 lines of it. This shows, for example, that the digraph you get by typing Control K, capital P, lowercase d, is the character pound. This is character number 163 in decimal. Capital P, lowercase d is short for pound. Most digraphs are selected to give you a hint about the character they will produce. If you look through the list, you will understand the logic. You can exchange the first and second character if there is no digraph for that combination. Thus, Control K, lowercase d, capital case P also works. Since there is no digraph for lowercase d, capital case P, Vim will also search for a capital case P, lowercase d digraph. Note, the digraphs depend on the character set that Vim assumes you are using. Always use :digraphs to find out which digraphs are currently available. You can define your own digraphs. Example, :digraph, A double quote, A with an umlaut. This defines that Control K, A double quote, inserts an A with an umlaut character. You can also specify the character with a decimal number. This defines the same digraph. :digraph, A double quote 228. More information about digraphs here. Digraphs. Another way to insert special characters is with a key map. More about that here. Chapter 45, Part 5. Chapter 24, Part 10. Normal mode commands. Insert mode offers a limited number of commands. In normal mode, you have many more. When you want to use one, you usually leave insert mode with escape, execute the normal mode command, and re-enter insert mode with I or A. There is a quicker way. With Control-O command, you can execute any normal mode command from insert mode. For example, to delete from the cursor to the end of the line, do Control-O capital D. You can execute only one normal mode command this way, but you can specify a register or a count. A more complicated example would be Control-O double quote G3DW. This deletes up to the third word into register G. Editing formatted text. Text hardly ever comes in one sentence per line. This chapter is about breaking sentences to make them fit on a page and other formatting. Vim also has useful features for editing single-line paragraphs and tables. Chapter 25, Part 1, Breaking Lines. Vim has a number of functions that make dealing with text easier. By default, the editor does not perform automatic line breaks. In other words, you have to press Enter yourself. This is useful when you are writing programs where you want to decide where the line ends. It is not so good when you are creating documentation and want the text to be at most 70 characters wide. If you set the text width option, Vim automatically inserts line breaks. Suppose, for example, that you want a very narrow column of only 30 characters. You need to execute the following command: :set text width equals 30. Now you start typing, ruler added. And so if you type I taught programming for a Y, if you type L next, this makes the line longer than the 30 character limit. When Vim sees this, it inserts a line break and you get the following: I taught programming for a while. Continuing on, you can type in the rest of the paragraph. I taught programming for a while. One time, I was stopped by the Fort Worth police because my homework was too hard. True story. You do not have to type new lines. Vim puts them in automatically. Note, the wrap option makes Vim display lines with a line break, but this doesn't insert a line break in the file. Reformatting. The Vim editor is not a word processor. In a word processor, if you delete something at the beginning of the paragraph, the line breaks are reworked. In Vim they are not, so if you delete the word programming from the first line, all you get is a short line. This does not look good. To get the paragraph into shape, you use the GQ operator. Let's first use this with a visual selection. Starting from the first line, type V for JGQ. V to start visual mode, 4J to move to the end of the paragraph, and then GQ operator. The result is that now there's more stuff added to the first line, so that it looks prettier. Note, there is a way to do automatic formatting for specific types of text layouts. See auto-format. Since GQ is an operator, you can use one of the three ways to select the text it works on: with visual mode, with a movement, and with a text object. The example above could also be done with GQ4J. That's less typing, but you have to know the line count. A more useful motion command is closed curly brace. This moves to the end of a paragraph. Thus, GQ closed curly brace formats from the cursor to the end of the current paragraph. A very useful text object to use with GQ is the paragraph. Try this. GQAP. AP stands for a paragraph. This formats the text of one paragraph separated by empty lines, also the part before the cursor. If you have your paragraph separated by empty lines, you can format the whole file by typing this: GGGQ capital G. GG to move to the first line, GQ capital G to format until the last line. Warning: if your paragraphs are not properly separated, they will be joined together. A common mistake is to have a line with a space or tab. That's a blank line, but not an empty line. Vim is able to format more than just plain text. See faux-table for how to change this. See the Join Spaces option to change the number of spaces used after a full stop. It is possible to use an external program for formatting. This is useful if your text can't be properly formatted with Vim's built-in command. See the Format PRG option. Chapter 25, Part 2. Aligning text. To center a range of lines, use the following command: :range center width. Range is the usual command line range. Width is an optional line width to use for centering. If width is not specified, it defaults to the value of text width. If text width is 0, the default is 80. For example, :1,5 center 40 results in the following: the text is centered. Right alignment. Similarly, the :right command right justifies the text. :1 right 37 gives the result where the text is aligned to the right. Left alignment. Finally, there is this command: :range left margin. Unlike :center and :right, however, the argument to :left is not the length of the line. Instead, it is the left margin. If it is omitted, the text will be put against the left side of the screen. Using a 0 margin would do the same. If it is 5, the text will be indented 5 spaces. For example, use these commands: :1 left 5, :2, 5 left. This results in the following. Justifying text. Vim has no built-in way of justifying text. However, there is a neat macro package that does the job. To use this package, execute the following command: :pack-add justify, or put this line in your vimrc: pack-add bang justify. This Vim script file defines a new visual command _j. To justify a block of text, highlight the text in visual mode and then execute _j. Look in the file for more explanations. To go there, do gf on this name: $vim runtime pack dist opt justify plugin justify.vim. An alternative is to filter the text through an external program. Example: %% bang fmt. Chapter 25, Part 3. Indents and tabs. indents can be used to make text stand out from the rest. The example texts in this manual, for example, are indented by 8 spaces or a tab. You would normally enter this by typing a tab at the start of each line. Take this text. The first line, the second line. This is entered by typing a tab, some text, enter, tab, and more text. The auto indent option inserts indents automatically. Set auto indent. When a new line is started, it gets the same indent as the previous line. In the above example, the tab after the enter is not needed anymore. Increasing indent. To increase the amount of indent in a line, use the greater than operator. Often this is used as greater than, which adds indent to the current line. The amount of indent added is specified with the shift width option. The default value is 8. To make greater than insert 4 spaces worth of indent, for example, type this, set shift width equals 4. When used on the second line of the example text, this is what you get. The first line, the second line. For greater than will increase the indent of 4 lines. Tab stop. If you want to make indents a multiple of 4, you set shift width to 4. But when pressing a tab, you still get 8 spaces worth of indent. To change this, set the soft tab stop option. Set soft tab stop equals 4. This will make the tab key insert 4 spaces worth of indent. If there are already 4 spaces, a tab character is used, saving 7 characters in the file. If you always want spaces and no tab characters, set the expand tab option. Note: you could set the tab stop option to 4, however, if you edit the file another time with tab stop, set to the default value of 8. It will look wrong. In other programs and when printing the indent will also look wrong. Therefore, it is recommended to keep tab stop at 8 all the time. That's the standard value everywhere. Changing tabs. You edit a file which was written with a tab stop of 3. In Vim, it looks ugly because it uses the normal tab stop value of 8. You can fix this by setting tab stop to 3. But you have to do this every time you edit this file. Vim can change the use of tab stops in your file. First, set tab stop to make the indents look good, then use the retab command. Set tab stop equals 3, retab equals 8. The retab command will change tab stop to 8, while changing the text such that it looks the same. It changes spans of white space into tabs and spaces for this. You can now write the file. Next time you edit it, the indents will be right without setting an option. Warning: when using retab on a program, it may change white space inside a string constant. Therefore, it's a good habit to use \t instead of a real tab. Chapter 25 Part 4, Dealing with Long Lines. Sometimes you will be editing a file that is wider than the number of columns in the window. When that occurs, Vim wraps the line so that everything fits on the screen. If you switch the wrap option off, each line in the file shows up as one line on the screen. Then the end of the long lines disappear off the screen to the right. When you move the cursor to a character that can't be seen, Vim will scroll the text to show it. This is like moving a viewport over the text in the horizontal direction. By default, Vim does not display a horizontal scroll bar in the GUI. If you want to enable one, use the following command: set GUI options += B. One horizontal scroll bar will appear at the bottom of the Vim window. If you don't have a scroll bar or don't want to use it, use these commands to scroll the text. The cursor will stay in the same place, but it's moved back into the visible text if necessary. So ZH will scroll right, 4ZH will scroll 4 characters right, Z_H scroll half a window width right, ZE scroll right to put the cursor at the end, ZL scroll left, 4ZL scroll 4 characters left, ZL scroll half a window width left, and ZS scroll left to put the cursor at the start. Let's attempt to show this with one line of text. The cursor is on the W of which. The cursor window above the line indicates the text that is currently visible. The windows below the text indicate the text that is visible after the command left of it. So if you have some long text, this is the part of the text which will be visible in the window. Moving with wrap off. When wrap is off and the text has scrolled horizontally, you can use the following commands to move the cursor to a character you can see. Thus, text left and right of the window is ignored. These never cause the text to scroll. G0 to first visible character in this line, G caret to first non-blank visible character in this line, GM to middle of screen line, G capital M to middle of the text in this line, G $ to last visible character in this line. So if we have some long text, this shows which portion will be visible. Breaking at words. When preparing text for use by another program, you might have to make paragraphs without a line break. A disadvantage of using no wrap is that you can't see the whole sentence you are working on. When wrap is on, words are broken halfway, which makes them hard to read. A good solution for editing this kind of paragraph is setting the line break option. Vim then breaks lines at an appropriate place when displaying the line. The text in the file remains unchanged. Without line break, text might look like this. So the words are broken, essentially. After, if you do set line break, it looks like this, where if the word doesn't have enough room to be displayed, it will simply be moved to the next line visually instead of breaking the word up. Related options. Break at specifies the characters where a break can be inserted. Show break specifies a string to show at the start of broken line. Set text width to 0 to avoid a paragraph to be split. Moving by visible lines. The J and K commands move to the next and previous lines. When used on a long line, this means moving a lot of screen lines at once. To move only one screen line, use the GJ or GK commands. When a line doesn't wrap, they do the same as J and K. When the line does wrap, they move to a character displayed one line below or above. You might like to use these mappings, which bind these movement commands to the cursor key. So :map up for GK and :map down for GJ. Turning a paragraph into one line. If you want to import text into a program like Microsoft Word, each paragraph should be a single line. If your paragraphs are currently separated with empty lines, this is how you turn each paragraph into a single line. :G /period :comma $:join. That looks complicated. Let's break it up in pieces. So the :G /period / is a global command that finds all lines that contain at least one character. The comma $$ is a range starting from the current line, the non-empty line, until an empty line. Join. The :join command joins the range of lines together into one line. Starting with this text containing 8 lines broken at column 30. You end up with 2 lines. So in here we have 2 paragraphs where the lines are actually broken, and by doing this we end up with continuous text. Note that this doesn't work when the separating line is blank but not empty. When it contains spaces and/or tabs, this command does work with blank lines. :G /S comma $S*$ join. This still requires a blank or empty line at the end of the file for the last paragraph to be joined. Chapter 25 Part 5 Editing Tables. Suppose you are editing a table with 4 columns. The columns are nice table, test 1, test 2, and test 3, and the rows are input A 0.534 and input B 0.913. Test 2 and test 3 are empty. You need to enter numbers in the 3rd column. You could move to the 2nd line, use capital A, enter a lot of spaces and type the text. For this kind of editing there is a special option. Set virtual edit equals all. Now you can move the cursor to position where there isn't any text. This is called virtual space. Editing a table is a lot easier this way. Move the cursor by searching for the header of the last column. So you do /test3. Now press J and you are right where you can enter the value for input A. Typing 0.693 results in you typing 0.693 underneath test 3. Vim has automatically filled the gap in front of the new text for you. Now to enter the next field in this column, use capital B lowercase j. Capital B moves back to the start of a white space separated word. Then lowercase j moves to the place where the next field can be entered. Note, you can move the cursor anywhere in the display, also beyond the end of a line, but Vim will not insert spaces there until you insert a character in that position. Copying a column. You want to add a column, which should be a copy of the third column and placed before the test1 column. Do this in 7 steps. 1. Move the cursor to the left upper corner of this column, example with /text3. 2. Press Ctrl V to start blockwise visual mode. 3. Move the cursor down 2 lines with 2J. You are now in virtual space, the input B line of the test3 column. 4. Move the cursor right to include the whole column in the selection, plus the space that you want between the columns. 9L should do it. 5. Yank the selected rectangle with Y. 6. Move the cursor to test1 where the new column must be placed. 7. Press capital P. The result will be this, where between the nice table and test1 column, you now have a copy of test3. Notice that the whole test1 column has shifted right, also the line where the test3 column didn't have text. Go back to non-virtual cursor movements with :set virtual edit equals. Virtual replace mode. The disadvantage of using virtual edit is that it feels different. You can't recognize tabs or spaces beyond the end of line when moving the cursor around. Another method can be used, virtual replace mode. Suppose you have a line in a table that contains both tabs and other characters. Use RX on the first tab. The layout is messed up. To avoid that, use the GR command. What happens is that the GR command makes sure the new character takes the right amount of screen space. Extra spaces or tabs are inserted to fill the gap. Thus what actually happens is that a tab is replaced by X and then blanks added to make the text after it keep its place. In this case, a tab is inserted. When you need to replace more than one character, you use the capital R command to go to replace mode. See Chapter 4, Part 9. This messes up the layout and replaces the wrong characters. The lowercase g uppercase R command uses virtual replace mode. This preserves the layout. Repeating. An editing task is hardly ever unstructured. A change often needs to be made several times. In this chapter, a number of useful ways to repeat a change will be explained. Chapter 26, Part 1. Repeating with visual mode. Visual mode is very handy for making a change in any sequence of lines. You can see the highlighted text, thus you can check if the correct lines are changed. But making the selection takes some typing. The gv command selects the same area again. This allows you to do another operation on the same text. Suppose you have some lines where you want to change 2001 to 2002 and 2000 to 2001. The financial results for 2001 are better than for 2000. The income increased by 50%, even though 2001 had more rain than 2000. And then you have income, and you have 2 columns, 2000 and 2001. And on the income row, you have 45,403. And then under 2001, you have 66,234. First, change 2001 to 2002. Select the lines in visual mode and do :s/2001/2002/G. Now use GV to reselect the same text. It doesn't matter where the cursor is. Then use :s/2000/2001/G to make the second change. Obviously, you can repeat these changes several times. Chapter 26, Part 2. Add and subtract. When repeating the change of one number into another, you often have a fixed offset. In the example above, one was added to each year. Instead of typing a substitute command for each year that appears, the Ctrl-A command can be used. Using the same text as above, search for a year. So you would do /19, then 0-9 in square brackets, another 0-9 in square brackets, \20, and then 2 more 0-9 in square brackets. Now press Ctrl-A. The year will be increased by 1. Use N to find the next year and press period to repeat the Ctrl-A. Period is a bit quicker to type. Repeat N and period for all years that appear. Adding more than one can be done by prepending the number to Ctrl-A. Suppose you have this list: 1 item 4, 2 item 5, 3 item 6. Move the cursor to 1 and type free Ctrl-A. The 1 period will change to 4 period. Again, you can use period to repeat this on the other numbers. The Ctrl-X command does subtraction in a similar way. The behavior of Ctrl-A and Ctrl-X depends on the value of NR formats. For example, if you use :set NR formats plus equals octal, pressing Ctrl-A over 007 will increment to 010, because 007 will be identified as an octal number. Chapter 26, Part 3. Making a change in many files. Suppose you have a variable called x_cnt, and you want to change it to x_counter. This variable is used in several of your C files. You want to change it in all files. This is how you do it. Put all the relevant files in the argument list by doing :args *.c. This finds all C files and edits the first one. Now you can perform a substitution command on all these files. So now you do :argdo %s / less than x_cnt \greater than /x_counter /ge pipe update. The :argdo command takes an argument that is another command. That command will be executed on all files in the argument list. The %s substitute command that follows works on all lines. It finds the word x_cnt with less than x_cnt greater than. The less than and greater than are used to match the whole word only and not px_cnt or x_cnt2. The flags for the substitute command include G to replace all occurrences of c_cnt in the same line. The E flag is used to avoid an error message when c_cnt does not appear in the file. Otherwise, :argdo would abort on the first line where x_cnt was not found. The pipe separates two commands. The following update command writes the file only if it was changed. If no x_cnt was changed to x_counter, nothing happens. There is also the :windo command, which executes its arguments in all windows, and :buffdo executes its argument on all buffers. Be careful with this, because you might have more files in the buffer list than you think. Check this with the :buffers command or do :ls. Chapter 26, Part 4. Using Vim from a shell script. Suppose you have a lot of files in which you need to change the string -person- to Jones, and then print it. How do you do that? One way is to do a lot of typing. The other is to write a shell script to do the work. The Vim editor does a superb job as a screen-oriented editor when using normal mode commands. For batch processing, however, normal mode commands do not result in clear, commented command files. So here you will use Xmode instead. This mode gives you a nice command line interface that makes it easy to put into a batch file. The EX command is just another name for a command line : command. The EXMode commands you need are as follows: %s /person- /Jones/G. Write temp file, quit. You put these commands in the file change.vim. Now to run the editor in batch mode, use this shell script. For file in *.txt do vim-e-s $file less than change.vim lpr-r temp file done. The for done loop is a shell construct to repeat the two lines in between, while the $file variable is set to a different file name each time. The second line runs the Vim editor in X mode, -e argument, on the file $file and reads commands from the file change.vim. The -s argument tells Vim to operate in silent mode. In other words, do not keep outputting the :prompt or any other prompt for that matter. The lpr-r temp file command prints the resulting temp file and deletes it. That's what the -r argument does. Reading from standard input. Vim can read text on standard input. Since the normal way is to read commands there, you must tell Vim to read text instead. This is done by passing the - argument in place of a file. Example, ls pipe vim dash. This allows you to edit the output of the ls command without first saving the text in a file. If you use the standard input to read text from, you can use the -s argument to read a script. Producer pipe vim -s change.vim dash. Normal mode scripts. If you really want to use normal mode commands in a script, you can use it like this: vim-s script file.txt and then 3 periods. Note: -s has a different meaning when it is used without -e. Here it means to source the script as normal mode commands. When used with -e, it means to be silent and doesn't use the next argument as a file name. The commands in script are executed like you typed them. Don't forget that a line break is interrupted by pressing enter. In normal mode, that moves the cursor to the next line. To create the script, you can edit the script file and type the commands. You need to imagine what the result would be, which can be a bit difficult. Another way is to record the commands while you perform them manually. This is how you do that. vim-w script file.txt ... All typed keys will be written to script. If you make a small mistake, you can just continue and remember to edit the script later. The -w argument appends to an existing script. That is good when you want to record the script bit by bit. If you want to start from scratch and start all over, use the -w argument. It overwrites any existing file. Search commands and patterns. In Chapter 3, a few simple search patterns were mentioned. Vim can do much more complex searches. This chapter explains the most often used ones. A detailed specification can be found here. Pattern. Chapter 27, Part 1. Ignoring case. By default, Vim searches are case sensitive. Therefore, lowercase include, uppercase include, and capitalized include are 3 different words, and a search will match only one of them. Now switch on the ignore case option, set ignore case. Search for lowercase include again, and now it will match capitalized include, uppercase include, and include with random capitalization. Set the HL search option to quickly see where a pattern matches. You can switch this off again with set no ignore case. But let's keep it set and let's search for all caps include. It will match exactly the same text as lowercase include did. Now set the smart case option, set ignore case smart case. If you have a pattern with at least one uppercase character, the search becomes case sensitive. The idea is that you didn't have to type that uppercase character, so you must have done it because you wanted case to match. That's smart. With these 2 options set, you find the following matches. Lowercase word will match with lowercase word, capitalized word, uppercase word, and word with random capitalization, etc. Capitalized word will only match with capitalized word, uppercase word will only match with uppercase word, and word with uppercase W and R will only match with word with uppercase W and R. Case in one pattern. If you want to ignore case for one specific pattern, you can do this by prepending the \C string. Using \C will make the pattern to match case. This overrules the ignore case and smart case options when backspace lowercase c or backspace uppercase c is used, their value doesn't matter. So if the pattern is backslash uppercase c word, it matches lowercase word. If backslash capital C and then capitalized word will only match capitalized word, backslash lowercase c with lowercase word will match lowercase word, capitalized word, uppercase word, and any other variation of word, and backslash lowercase c with capitalized word will again match any variation of word. A big advantage of using backslash lowercase c and backslash capital C is that it sticks with the pattern. Thus, if you repeat a pattern from the search history, the same will happen, no matter if ignore case or smart case was changed. Note, the use of backslash items in search patterns depends on the magic option. In this chapter, we will assume magic is on because that is the standard and recommended setting. If you would change magic, many search patterns would suddenly become invalid. Note, if your search takes much longer than you expected, you can interrupt it with Ctrl+C on Unix and Control-Break on Microsoft Windows. Chapter 27, Part 2, Wrapping Around the File End. By default, a forward search starts searching for the given string at the current cursor location. It then proceeds to the end of the file. If it has not found a string by that time, it starts from the beginning and searches from the start of the file to the cursor location. Keep in mind that when repeating the end command to search for the next match, you eventually get back to the first match. If you don't notice this, you keep searching forever. To give you a hint, Vim displays this message: search hit bottom, continuing at top. If you use the question mark command to search in the other direction, you get this message: search hit top, continuing at bottom. Still, you don't know when you are back at the first match. One way to see this is by switching on the ruler option, :set ruler. Vim will display the cursor position in the lower right-hand corner of the window, in the status line if there is one. It looks like this: 101,29, 84%. The first number is the line number of the cursor. Remember the line number where you started so that you can check if you pass this position again. Not wrapping. To turn off search wrapping, use the following command: :set no wrap scan. Now, when the search hits the end of the file, an error message displays: E385, search hit bottom without match forever. Thus you can find all matches by going to the start of the file with GG and keep searching until you see this message. If you search in the other direction using question mark, you get E384, search hit top without match forever. Chapter 27, Part 3, Offsets. By default, the search command leaves the cursor positioned on the beginning of the pattern. You can tell Vim to leave it some other place by specifying an offset. For the forward search command, / the offset is specified by appending a slash and the offset. So you would do /default /2. This command searches for the pattern default and then moves to the beginning of the second line past the pattern. Using this command on the paragraph above, Vim finds the word default in the first line. Then the cursor is moved 2 lines down and lands on an offset. If the offset is a simple number, the cursor will be placed at the beginning of the line, then many lines from the match. The offset number can be positive or negative. If it is positive, the cursor moves down then many lines. If negative, it moves up. Character offset. The E offset indicates an offset from the end of the match. It moves the cursor onto the last character of the match. The command /const/E puts the cursor on the T of const. From that position, adding a number moves forward that many characters. This command moves to the character just after the match, /const/E+1. A positive number moves the cursor to the right. A negative number moves it to the left. For example, /const/E-1 moves the cursor to the S of const. If the offset begins with B, the cursor moves to the beginning of the pattern. That's not very useful since leaving out the b does the same thing. It does get useful when a number is added or subtracted. The cursor then goes forward or backwards that many characters. For example, /const/b+2 moves the cursor to the beginning of the match and then 2 characters to the right, thus it lands on the n. Repeating. To repeat searching for the previously used search pattern but with a different offset, leave out the pattern /that//e is equal to /that//e. To repeat with the same offset, do /. N does the same thing. To repeat while removing a previously used offset, do //. Searching backwards. The question mark command uses offsets in the same way, but you must use question mark to separate the offset from the pattern instead of /. So you would do question mark const question mark e-2. The b and e keep their meaning, they don't change direction with the use of question mark. Start position. When starting a search, it normally starts at the cursor position. When you specify a line offset, this can cause trouble. For example, /const/-2. This finds the next word const and then moves 2 lines up. If you use n to search again, Vim could start at the current position and find the same const match. Then, using the offset again, you would be back where you started. You would be stuck. It could be worse. Suppose there is another match with const in the next line. Then repeating the forward search would find this match and move the lines up. Thus you would actually move the cursor back. When you specify a character offset, Vim will compensate for this. Thus the search starts a few characters forward or backward, so that the same match isn't found again. Chapter 27 Part 4. Matching multiple times. The asterisk item specifies that the item before it can match any number of times. Thus, /a* matches A, AA, AAA, etc. But also double quote the empty string because 0 times is included. The asterisk only applies to the item directly before it. Thus AB* matches A, AB, ABB, ABBB, etc. To match a whole string multiple times, it must be grouped into one item. This is done by putting \open parentheses before it and \close parentheses after it. Thus this command /open parentheses AB \close parentheses asterisk matches AB, ABAB, ABABAB, etc. and also empty string. To avoid matching the empty string, use \+. This makes the previous item match one or more items. /AB \+ matches AB, ABB, ABBB, etc. It does not match A when no B follows. To match an optional item, use \=. For example, /folders \= matches folder and folders. Specific counts. To match a specific number of items, use the form \open curly brace n, m close curly brace. N and m are numbers. The number before it will be matched n to m times inclusive. Example, /AB open curly brace 3, 5 close curly brace matches ABBB, ABBBB, ABBBB. When n is omitted, it defaults to 0. When m is omitted, it defaults to infinity. When m is omitted, it matches exactly n times. Example, if the pattern is 4, it matches 0, 1, 2, 3, or 4. If the pattern is 3, it matches 3, 4, 5, etc. If the pattern is 0, 1, it matches 0 or 1, same as \=. If it's 0, it does 0 or more, same as asterisk. If it's 1, it does 1 or more, same as \+, and if it's 3, it matches 3. Matching as little as possible. The item so far match as many characters as they can find. To match as few as possible, use \curly brace -n, m close curly brace. It works the same as \open curly brace n, m close curly brace. except that the minimal amount possible is used. For example, use /AB open curly brace -1, comma, free close curly brace. This will match AB in ABBB. Actually, it will never match more than one B, because there is no reason to match more. It requires something else to force it to match more than the lower limit. The same rules apply to removing N and M. It is even possible to remove both of the numbers, resulting in open curly brace close curly brace. This matches the item before it 0 or more times, as few as possible. The item by itself always matches 0 times. It is useful when combined with something else. Example, /A period open curly brace close curly brace B. This matches AXB in AXBXB. If this pattern would be used, /A period *B, it would try to match as many characters as possible with period asterisk, thus it matches AXBXB as a whole. Chapter 27, Part 5. Alternatives. The OR operator in a pattern is \pipe. Example, /foo \pipe bar. This matches foo or bar. More alternatives can be concatenated. /1 \pipe 2 \pipe 3 matches 1, 2, and 3. To match multiple times, the whole thing must be placed in open parentheses and close parentheses. So you would have / open parentheses foo \pipe bar close parentheses \plus. This matches foo, foo bar, foo bar, etc. Another example, /and open parentheses if \pipe while \pipe for close parentheses. This matches end if, end while, and end for. A related item is \ampersand. This requires that both alternatives match in the same place. The resulting match uses the last alternative. Example, /forever ampersand ... This matches for in forever. It will not match for to in, for example. Chapter 27, Part 6. Character ranges. To match A, B, or C, you could use /A \pipe B \pipe C. When you want to match all letters from A to Z, this gets very long. There is a shorter method, /A-Z in square brackets. The square brackets construct matches a single character. Inside you specify which characters to match. You can include a list of characters like this, /0 1 2 3 4 5 6 7 8 9 A B C D E F, all in square brackets. This will match any of the characters included. For consecutive characters, you can specify the range. 0 to 3 stands for 0 1 2 3. W to Z stands for W X Y Z. Thus the same command as above can be shortened to /0-9 A-F, all in square brackets. To match the dash character itself, make it the first or last one in the range. These special characters are accepted to make it easier to use them inside a square brackets range. They can actually be used anywhere in the search pattern. So \E is escape, \T is tab, \R is carriage return or enter, and \B is backspace. There are a few more special cases for square brackets range. See / square brackets for the whole story. Completed range. To avoid matching a specific character, use caret at the start of the range. The square bracket item then matches everything but the characters included. Example, / open square bracket, caret, close square bracket, asterisk, . So the double quote is a double quote. The caret and double quote in square brackets means any character that is not a double quote. Asterisk means as many as possible. And then the last double quote is a double quote again. This matches foo in double quotes and free bang x in double quotes, including the double quotes. Predefined ranges. A number of ranges are used very often. Vim provides a shortcut for these. For example, /\A. This finds alphabetic characters. This is equal to using / lowercase a to lowercase z, uppercase A to uppercase Z in square brackets. Here are a few more of these. \lowercase d matches digits. It's the equivalent of 0 to 9. \D matches non-digits. It's the equivalent of 0 to 9. \x matches hex digit. It's the equivalent of 0-9, A-F lowercase, and A-F uppercase. \uppercase x matches non-hex digits, which is the equivalent of 0 to 9, lowercase a to f, and uppercase A to f. \s matches white space, which is tab in space. \S matches non-white characters, which is the equivalent of doing tab in space. \L matches lowercase alpha, which is A to Z. Capital case L matches non-lowercase alpha, which is A to Z. \U matches uppercase alpha, which is capital A to capital Z. And \uppercase U matches non-uppercase alpha, which is the equivalent of capital A to capital Z. Note: using these predefined ranges works a lot faster than the character range stands for. These items cannot be used inside square brackets. Thus, \D\L in square brackets does not work to match a digit or lowercase alpha. Use \, open parentheses, \D, \pipe, \L, close parentheses instead. See / \S for the whole list of these ranges. Chapter 27 Part 7 Character Classes. The character ranges matches a fixed set of characters. A character class is similar, but with an essential difference. The set of characters can be redefined without changing the search pattern. For example, search for this pattern / \f+. The \f item stands for file name characters. Thus, this matches a sequence of characters that can be a file name. Which characters can be part of a file name depends on the system you are using. On Microsoft Windows, the / is included. On Unix, it is not. This is specified with the isFname option. The default value for Unix is :set isFname. isFname equals @48-57, /, dash, underscore, plus, hash, $sign, percentage, tilde, equals. For other systems, the default value is different. Thus, you can make a search pattern with \f to match a file name, and it will automatically adjust to the system you are using it on. Note: actually, Unix allows using just about any character in a file name. Including these characters in isFname would be theoretically correct, but it would make it impossible to find the end of a file name in text. Thus, the default value of isFname is a compromise. The character classes are, and these are in the order of item, matches, and option. These would be \I, identifier characters, isIdent. \I, like \lowercase I, excluding digits. \K, keyword characters, isKeyword. \K, like \lowercase k, excluding digits. \P, printable characters, isPrint. \P, like \lowercase p, excluding digits. \F, file name characters, isFname. \uppercase F, like \lowercase f, excluding digits. Chapter 27 Part 8 Matching a line break. Vim can find the pattern that includes a line break. You need to specify where the line break happens because all items mentioned so far don't match a line break. To check for a line break in a specific place, use the \n item. So you would do /1 \n2. This will match at a line that ends in 1 and the next line starts with 2. To match 1, 2 as well, you need to match a space or a line break. The item to use for it is \_s. So you would do /1 \_s2. To allow any amount of white space, you would do /1 \s+2. This also matches when 1 space is at the end of a line and /2 at the start of the next one. \s matches white space, \_s matches white space on a line break. Similarly, \a matches an alphabetic character, and \_a matches an alphabetic character or a line break. The other character classes and ranges can be modified in the same way by inserting a underscore. Many other items can be made to match a line break by prepending \_. For example, \_period matches any character or a line break. Note, \_period asterisk matches everything until the end of the file. Be careful with this, it can make a search command very slow. Another example is \_square brackets, a character range that includes a line break. You would do /, \_, open square bracket, caret double quote, close square bracket, asterisk double quote. This finds a text in double quotes that may be split up in several lines. Chapter 27, Part 9. Examples. Here are a few search patterns you might find useful. This shows how the items mentioned above can be combined. Finding a California license plate. A sample license plate number is 1MGU103. It has 1 digit, 3 uppercase letters, and 3 digits. Directly putting this into a search pattern, you would do /, \d, \u, \u, /u, /d, /d. Another way is to specify that there are 3 digits and letters with a count. So you would do /, \d, /u, /3 in curly braces, then /d, and then 3 in curly braces again. Using square brackets ranges instead, you would do /0 to 9 in square brackets, capital A to capital Z in square brackets, \3 in curly brackets, 0 to 9 in square brackets, \3 in curly brackets. Which one of these you should use? Whichever one you can remember. The simple way you can remember is much faster than the fancy way that you can't. If you can remember them all, then avoid the last one because it's both more typing and slower to execute. Finding an identifier. In C programs and many other computer languages, an identifier starts with a letter and further consists of letters and digits. Underscores can be used too. This can be found with /, less than, \h, \w, asterisk, greater than. The less than and greater than are used to find only whole words. \h stands for capital A to capital Z, lowercase a to lowercase z, and underscore, all in square brackets. And \w for 0 to 9, uppercase A to uppercase Z, lowercase a to lowercase z, and underscore, all in square brackets. Note, \less than and \greater than depend on the is keyword option. If it includes dash, for example, then ident dash is not matched. In this situation, use /, \w, @, less than bang, \h, \w, asterisk, \w, @, bang. This checks if \w does not match before or after the identifier. See /, @, less than bang, and /, @, bang. Folding. Structured text can be separated in sections, and sections in subsections. Folding allows you to display a section as one line, providing an overview. This chapter explains the different ways this can be done. Chapter 28, Part 1. What is folding? Folding is used to show a range of lines in the buffer as a single line on the screen, like a piece of paper which is folded to make it shorter. The text is still in the buffer unchanged, only the way lines are displayed is affected by folding. The advantage of folding is that you can get a better overview of the structure of text by folding lines of a section and replacing it with a line that indicates that there is a section. Chapter 28, Part 2. manual folding. Try it out. Position the cursor in a paragraph and type ZFAP. You will see that the paragraph is replaced by a highlighted line. You have created a fold. ZF is an operator and AP a text object selection. You can use the ZF operator with any movement command to create a fold for the text that it moved over. ZF also works in visual mode. So we can do ZFAP, so that folds it, and then ZO to unfold it. To view the text again, open the fold by typing ZO, and you can close the fold again with ZC. All the following commands start with Z. With some fantasy, this looks like a folded piece of paper, seen from the side. The letter after the Z has a mnemonic meaning to make it easier to remember the commands. ZF, fold creation, ZO, open a fold, ZC, close a fold. Folds can be nested. A region of text that contains folds can be folded again. For example, you can fold each paragraph in this section and then fold all the sections in this chapter. Try it out. You will notice that opening the fold for the whole chapter will restore the nested folds as they were. Some may be open and some may be closed. Suppose you have created several folds and now want to view all the text. You could go to each fold and type ZO. To do this faster, use this command, ZR. This will reduce the folding. The opposite is ZM. This folds more. You can repeat ZR and ZM to open and close nested folds of several levels. If you have nested several levels deep, you can open all of them with ZR. This reduces folds until there are none left, and you can close all folds with ZM. This folds more and more. You can quickly disable the folding with the ZN command. The ZN brings back the folding as it was. ZI toggles between the two. This is a useful way of working. Create folds to get overview on your file, move around to where you want to do your work, do ZI to look at the text and edit it, do ZI again to go back to moving around. More about manual folding in the reference manual, Fold-Manual. Chapter 28, Part 3. Working with folds. When some folds are closed, movement commands like J and K move over a fold like it was a single empty line. This allows you to quickly move around over folded text. You can yank, delete, and put folds as if it was a single line. This is very useful if you want to reorder functions in a program. First, make sure that each fold contains a whole function or a bit less by selecting the right fold method. Then delete the function with DD. Move the cursor and put it with P. If some lines of the function are above or below the fold, you can use visual selection. Put the cursor on the first line to be moved, hit capital V to start visual mode, put the cursor on the last line to be moved, hit D to delete the selected lines, and then move the cursor to the new position and put the lines there. It is sometimes difficult to see or remember where a fold is located, thus where a ZO command would actually work. To see the defined folds, do :set fold column equals 4. This will show a small column on the left of the window to indicate folds. A plus is shown for a closed fold. A dash is shown at the start of each open fold, and bar at following lines of the fold. You can use the mouse to open a fold by clicking on the plus in the fold column. Clicking on the minus or a bar below it will close an open fold. To open all folds at the cursor line, use ZO. To close all folds at the cursor line, use ZC. To delete a fold at the cursor line, use ZD. To delete all folds at the cursor line, use ZD. When in insert mode, the fold at the cursor line is never closed. That allows you to see what you type. Folds are opened automatically when jumping around or moving the cursor left or right. For example, the 0 command opens the fold under the cursor if fold open contains HOR, which is the default. The fold open option can be changed to open folds for specific commands. If you want the line under the cursor always to be open, do this: :set fold open equals all. Warning: you won't be able to move onto a closed fold then. You might want to use this only temporarily and then set it back to the default by doing :set fold open ampersand. You can make folds close automatically when you move out of it by doing :set fold close equals all. This will reapply fold level to all folds that don't contain the cursor. You have to try it out if you like how this feels. Use ZM to fold more and ZR to fold less or reduce folds. The folding is local to the window. This allows you to open two windows on the same buffer, one with folds and one without folds, or one with all folds closed and one with all folds open. Chapter 28 Part 4: Saving and Restoring Folds. When you abandon a file, starting to edit another file, the state of the folds is lost. If you come back to the same file later, all manually opened and closed folds are back to their default. When folds have been created manually, all folds are gone. To save the folds, use the :mkview command. This will store the settings and other things that influence the view on the file. You can change what is stored with the View Options option. When you come back to the same file later, you can load the view again by doing :load view. You can store up to 10 views on a file. For example, to save the current setup as the third view and load the second view, you would do :mkview3 :load view 2. Note that when you insert or delete lines, the views might become invalid. Also, check out the View dir option, which specifies where the views are stored. You might want to delete old views now and then. Chapter 28 Part 5: Folding by indent. Defining folds with ZF is a lot of work. If your text is structured by giving lower level items a larger indent, you can use the indent folding method. This will create folds for every sequence of lines with the same indent. Lines with a larger indent become nested folds. This works well with many programming languages. Try this by setting the fold method option by doing :set fold method equals indent. Then you can use the ZM and ZR commands to fold more and reduce folding. It's easy to see on this example text. This line is not indented. This line is indented once. This line is indented twice. This line is indented twice. This line is indented once. This line is not indented. This line is indented once. This line is indented once. Note that the relation between the amount of indent and the fold depth depends on the shift width option. Each shift width worth of indent adds 1 to the depth of the fold. This is called a fold level. When you use the ZR and ZM commands, you actually increase or decrease the fold level option. You could also set it directly by doing :set fold level equals 3. This means that all folds with 3 times a shift width indent or more will be closed. The lower the fold level, the more folds will be closed. When fold level is 0, all folds are closed. ZM does set fold level to 0. The opposite command, ZR, sets fold level to the deepest fold level that is present in the file. Thus, there are 2 ways to open and close the folds. A. By setting the fold level. This gives a very quick way of zooming out to view the structure of the text, move the cursor, and zoom in on the text again. B. By using ZO and ZC commands to open or close specific folds. This allows opening only those folds that you want to be open, while other folds remain closed. This can be combined. You can first close most folds by using ZM a few times, and then open a specific fold with ZO, or open all folds with ZR, and then close specific folds with ZC. But you cannot manually define folds with fold method is indent, as that would conflict with the relation between the indent and the fold level. More about folding by indent in the reference manual, fold-indent. Chapter 28 Part 6: Folding with markers. Markers in the text are used to specify the start and end of a fold region. This gives precise control over which lines are included in a fold. The disadvantage is that the text needs to be modified. Try it. Do :set fold method equals marker. Example text as it could appear in a C program. Notice that the folded line will display the text before the marker. This is very useful to tell what the fold contains. It's quite annoying when the marker doesn't pair up correctly after moving some lines around. This can be avoided by using numbered markers. Example: at every numbered marker, a fold at the specified level begins. This will make any fold at a higher level stop here. You can just use numbered start markers to define all folds. Only when you want to explicitly stop a fold before another starts, you need to add an end marker. More about folding with markers in the reference manual fold-marker. Chapter 28, Part 7. Folding by syntax. For each language, Vim uses a different syntax file. This defines the colors for various items in the file. If you are reading this in Vim in a terminal that supports colors, the colors you see are made with the help syntax file. In the syntax files, it is possible to add syntax items that have the fold argument. These define a fold region. This requires writing a syntax file and adding these items in it. That's not so easy to do, but once it's done, all folding happens automatically. Here we'll assume you are using an existing syntax file. Then there is nothing more to explain. You can open and close folds as explained above. The folds will be created and deleted automatically when you edit the file. More about folding by syntax in the reference manual, fold-syntax. Chapter 28, Part 8. Folding by expression. This is similar to folding by indent, but instead of using the indent of a line, a user function is called to compute the fold level of a line. You can use this for text where something in the text indicates which lines belong together. An example is an email message where the quoted text is indicated by a greater than before the line. To fold these quotes, use this: :set fold method equals expr, :set fold expr equals strlen, open parentheses substitute, open parentheses substitute, open parentheses get line, open parentheses v::l num, close parentheses, comma, single quote, \s, single quote, comma, single quote, comma, double quote g, double quote, close parentheses, comma, single quote, open square bracket, caret, greater than, close square bracket, period asterisk, single quote, comma, single quote, comma, single quote, close parentheses, close parentheses. You can try it out on this text. Quoted text he wrote, quoted text he wrote, double quoted text I wrote, double quoted text I wrote. Explanation for the fold expr used in the example inside out. Get line open parentheses v::l num close parentheses gets the current line. Substitute open parentheses ... comma, single quote, double backspace, s, single quote, comma, single quote, comma, single quote g, single quote, close parentheses, removes all white space from the line. Substitute open parentheses, 3 dots, comma, single quote, open square bracket, caret, greater than, close square bracket, period asterisk, single quote, comma, single quote, comma, single quote, parentheses. Removes everything after leading greater thans. strlen, open parentheses, ... close parentheses, counts the length of the string, which is the number of greater thans found. Note that a backslash must be inserted before every space, double quote, and backslash for the :set command. If this confuses you, do :set fold expr to check the actual resulting value. To correct a complicated expression, use the command line completion. :set fold expr equals tab, where tab is a real tab. Vim will fill in the previous value, which you can then edit. When the expression gets more complicated, you should put it in a function and set fold expr to call that function. More about folding by expression in the reference manual, fold-expr. Chapter 28, Part 9. Folding unchanged lines. This is useful when you set the diff option in the same window. The -d option does this for you. Example: set local diff fold method equals diff scroll bind no wrap fold level equals 1. Do this in every window that shows a different version of the same file. You will clearly see the differences between the files, while the text that didn't change is folded. For more details, see fold-diff. Chapter 28, Part 10, Which fold method to use. All these possibilities make you wonder which method you should choose. Unfortunately, there is no golden rule. Here are some hints. If there is a syntax file with folding for the language you are editing, that is probably the best choice. If there isn't one, you might try to write it. This requires a good knowledge of search patterns. It's not easy, but when it's working, you will not have to define folds manually. Typing commands to manually fold regions can be used for unstructured text. Then use the :mkview command to save and restore your folds. The marker method requires you to change the file. If you are sharing the files with other people or you have to meet company standards, you might not be allowed to add them. The main advantage of markers is that you can put them exactly where you want them. That avoids that a few lines are missed when you cut and paste folds. And you can add a comment about what is contained in the fold. Folding by indent is something that works in many files, but not always very well. Use it when you can't use one of the other methods. However, it is very useful for outlining. Then you specifically use the shift width for each nesting level. Folding with expressions can make folds in almost any structured text. It is quite simple to specify, especially if the start and end of a fold can easily be recognized. If you use the expr method to define folds, but they are not exactly how you want them, you could switch to the manual method. This will not remove the defined folds. Then you can delete or add folds manually. Moving through programs. The creator of Vim is a computer programmer. It's no surprise that Vim contains many features to aid in writing programs. Jump around to find where identifiers are defined and used. Preview declarations in a separate window. There is more in the next chapter. Chapter 29, Part 1, Using Tags. What is a tag? It is a location where an identifier is defined. An example is a function definition in a C or C++ program. A list of tags is kept in a tags file. This can be used by Vim to directly jump from any place to the tag, the place where an identifier is defined. To generate the tags file for all C files in the current directory, use the following command: ctags *.c. ctags is a separate program. Most Unix systems already have it installed. If you do not have it yet, you can find universal ctags at ctags.io. Universal ctags is preferred. Exuberant ctags is no longer being developed. Now when you are in Vim and you want to go to a function definition, you can jump to it by using the following command: :tag start list. This command will find the function start list even if it is in another file. The control close right bracket command jumps to the tag of the word that is under the cursor. This makes it easy to explore a tangle of C code. Suppose, for example, that you are in the function write_block. You can see that it calls write_line. But what does write_line do? By placing the cursor on the call to write_line and pressing Ctrl close square bracket, you jump to the definition of this function. The write_line function calls write_char. You need to figure out what it does, so you position the cursor over the call to write_char and press Ctrl close square bracket. Now you are at the definition of write_char. So if you do Ctrl close square bracket there, it will take you here, and that will take you here. The :tags command shows the list of tags that you traversed through. So if you do :tags, there are 5 columns. There's hash, to, tag, from line, and in file/text. So you'd have 1, 1, write_line, 8, write_block.c, and 2, 1, write_char, 7, write_line, tag.c. Now to go back, the Ctrl-T command goes to the preceding tag. In the example above, you get back to the write_line function in the call to write_char. This command takes a count argument that indicates how many tags to jump back. You have gone forward and then back. Let's go forward again. The following command goes to the tag on top of the list, :tag. You can prefix it with a count and jump forward that many tags. For example, :free tag. Ctrl-T also can be preceded with a count. These commands thus allow you to go down a call tree with Ctrl close square bracket and back up again with Ctrl-T. Use :tags to find out where you are. Split windows. The :tag command replaces the file in the current window with the one containing the new function. But suppose you want to see not only the old function but also the new one. You can split the window using the :split command followed by the :tag command. Vim has a shorthand command that does both, :stag tag name. To split the current window and jump to the tag under the cursor, use this command, Ctrl-W close square bracket. If a count is specified, the new window will be that many lines high. More tag files. When you have files in many directories, you can create a tags file in each of them. Vim will then only be able to jump to tags within that directory. To find more tags files, set the tags option to include all the relevant tags files. Example, :set tags equals :tags, :tags, :tags. This finds a tags file in the same directory as the current file, one directory level higher, and in all subdirectories. This is quite a number of tags files, but it may still not be enough. For example, when editing a file in ~proj/source, you will not find the tags file ~proj/sub/tags. For this situation, Vim offers to search a whole directory tree for tags files. Example, :set tags equals :proj/***tags. One tags file. When Vim has to search many places for tags files, you can hear the disk rattling. It may get a bit slow. In this case, it's better to spend this time while generating one big tags file. You might do this overnight. This requires the universal or exuberant ctags program mentioned above. It offers an argument to search a whole directory tree. So you would do cd ~proj ctags-R. The nice thing about this is that universal/exuberant ctags recognize various file types. Thus, this doesn't work just for C and C++ programs, also for Eiffel and even Vim scripts. See the ctags documentation to tune this. Now you only need to tell Vim where your big tags file is. So you would do :set tags equals ~proj/tags. Multiple matches. When a function is defined multiple times or a method in several classes, the :tag command will jump to the first one. If there is a match in the current file, that one is used first. You can now jump to other matches for the same tag with :t next. Repeat this to find further matches. If there are many, you can select which one to jump to. So you would do :t select tag name. Vim will present you with a list of choices. You can now enter the number in the first column of the match that you would like to jump to. The information in the other columns give you a good idea of where the match is defined. To move between the matching tags, these commands can be used. :t first to go to first match, :count t previous, go to count previous match, :count t next, go to count next match, and :t last to go to last match. If count is omitted, then 1 is used. Guessing tag names. Command line completion is a good way to avoid typing a long tag name. Just type the first bit and press tab, :tag right_tab. You will get the first match. If it's not the one you want, press Tab until you find the right one. Sometimes you only know part of the name of a function, or you have many tags that start with the same string but end differently. Then you can tell Vim to use a pattern to find the tag. Suppose you want to jump to a tag that contains block. First type this, :tag/block. Now use command line completion, press Tab. Vim will find all tags that contain block and use the first match. The / before a tag name tells Vim that what follows is not a literal tag name, but a pattern. You can use all the items for search patterns here. For example, suppose you want to select a tag that starts with right_. You would do :t select /caret right_. The caret specifies that the tag starts with right_. Otherwise, it would also be found halfway in a tag name. Similarly, $ at the end makes sure the pattern matches until the end of a tag. A tags browser. Since control closed right bracket takes you to the definition of the identifier under the cursor, you can use a list of identifier names as a table of contents. Here is an example. First, create a list of identifiers. This requires universal or exuberant C tags. C tags -c -types equals f -f functions *.c. Now start Vim without a file and edit this file in Vim in a vertically split window. Vim and then :v split functions. The window contains a list of all the functions. There is some more stuff, but you can ignore that. Do :set local ts equals 99 to clean it up a bit. In this window, define a mapping. :n no remap, buffers, carriage return, 0ye, Control W, W::tag, Control R, double quotes, carriage return. Move the cursor to the line that contains the function you want to go to. Now press Enter. Vim will go to the other window and jump to the selected function. Related items. To make case and tag names be ignored, you can set ignore case while leaving tag case as follow IC, or set tag case to ignore. The tag bsearch option tells if the tags file is sorted or not. The default is to assume a sorted tags file, which makes a tag search a lot faster, but doesn't work if the tags file isn't sorted. The tag length option can be used to tell Vim the number of significant characters in a tag. Chapter 29 Part 2, the previous window. When you edit code that contains a function call, you need to use the correct arguments. To know what values to pass, you can look at how the function is defined. The tags mechanism works very well for this. Preferably, the definition is displayed in another window. For this, the preview window can be used. To open a preview window to display the function right_char, do :p tag right_char. Vim will open a window and jump to the tag right_char. Then it takes you back to the original position. Thus, you can continue typing without the need to use a Ctrl+W command. If the name of a function appears in the text, you can get its definition in the previous window with Ctrl+W closed curly brackets. There is a script that automatically displays the text where the word under the cursor was defined. See cursor hold -example. To close the previous window, use this command, :p close. To edit a specific file in the preview window, use :p edit. This can be useful to edit a header file, for example. :p edit defs.h. Finally, :p search can be used to find the word in the current file and any included files and display the match in the preview window. This is especially useful when using library functions, for which you do not have a tags file. Example, :p search popen. This will show the stdio.h file in the preview window with the function prototype for popen, open parentheses, close parentheses. You can specify the height of the preview window when it is opened with the preview height option. Chapter 29 Part 3, moving through a program. Since a program is structured, Vim can recognize items in it. Specific commands can be used to move around. C programs often contain constructs like this. Hash ifdef use _popen, if d equals popen open parentheses, ls in double quotes, comma, r in double quotes, close parentheses, hash else, fd equals f open parentheses, tmp in double quotes, comma, w in double quotes, close parentheses, hash endif, but then much longer and possibly nested. Position the cursor on the hash ifdef and press %. Vim will jump to the hash else. Pressing % again takes you to the hash endif. Another % takes you to the hash ifdef again. When the construct is nested, Vim will find the matching items. This is a good way to check if you didn't forget an hash endif. When you are somewhere inside a hash if dash hash endif, you can jump to the start of it with left square bracket hash. If you are not after a hash if or hash ifdef, Vim will beep. To jump forward to the next hash else or hash endif, use close square bracket hash. Those two commands skip any hash if dash hash endif blocks that they encounter. Example: hash if defined open parentheses has _ inc _ h close parentheses, a equals a plus inc open and close parentheses, semicolon, hash ifdef use _ theme, a plus equals free semicolon, hash endif set _ with open parentheses a close parentheses. With the cursor in the last line, open square bracket hash moves to the first line. The hash ifdef dash hash endif block in the middle is skipped. Moving in code blocks. In C, code blocks are enclosed in curly brackets. These can get pretty long. To move to the start of the outer blocks, use the open square bracket command. Use close square bracket open square bracket to find the end. This assumes that the open curly brace and close curly brace are in the first column. The open square bracket open curly brace command moves to the start of the current block. It skips over pairs of curly braces at the same level. Close square bracket and close curly brace jumps to the end. And here you have a visual overview of that. When writing C++ or Java, the outer curly brace blocks is for the class. The next level of curly braces is for a method. When somewhere inside a class, use open square bracket m to find the previous start of a method. Close square bracket m finds the next start of a method. Additionally, open square bracket close square bracket moves backward to the end of a function, and close square bracket moves forward to the start of the next function. The end of a function is defined by a closed curly brace in the first column. And here you have a visual representation. Don't forget you can also use percentage to move between matching parentheses, curly braces, and square brackets. That also works when they are many lines apart. Moving in braces. The open square bracket open parentheses and close square bracket close parentheses commands work similar to open square bracket open curly brace and close square bracket close curly brace, except that they work on parentheses pairs instead of curly brace pairs. And here you have a visual representation. Moving in comments. To move back to the start of a comment, use open square bracket /. Move forward to the end of a comment with close square bracket /. This only works for /* to */ comments. Chapter 29, Part 4, Finding Global Identifiers. You are editing a C program and wonder if a variable is declared as int or unsigned. A quick way to find this is with the open square bracket I command. Suppose the cursor is on the word column, type open square bracket I. Vim will list the matching lines it can find, not only in the current file, but also in all included files and files included in them, etc. The result looks like this: structs.h 1:29 unsigned column semicolon / column number */. The advantage over using tags or the preview window is that included files are searched. In most cases, this results in the right declaration to be found. Also when the tags file is out of date. Also when you don't have tags for the included files. However, a few things must be right for open square bracket capital I to do its work. First of all, the include option must specify how a file is included. The default value works for C and C++. For other languages, you will have to change it. Locating included files. Vim will find included files in the places specified with the path option. If a directory is missing, some included files will not be found. You can discover this with this command, :check path. It will list the include files that could not be found. Also files included by the files that could be found. An example of the output. -- included files not found in path -- io.h, vim.h, functions.h, clib /exec_protos.h. The io.h file is included by the current file and can't be found. Vim.h can be found, thus :check path goes into this file and checks what it includes. The functions.h and clib /exec_protos.h files included by vim.h are not found. Note: Vim is not a compiler. It does not recognize #if_def statements. This means every #include statement is used, also when it comes after #if_never. To fix the files that could not be found, add a directory to the path option. A good place to find out about this is in makefile. Look out for lines that contain -I items, like -I/user/local/x11. To add this directory, use :set path +=user/local/x11. When there are many subdirectories, you can use the * wildcard. Example: :set path +=user/*include. This would find files in /user local include as well as user x11 include. When working on a project with a whole nested tree of included files, the ** items is useful. This will search down in all subdirectories. Example: :set path +=projects invent ** include. This will find files in the directories projects invent include, projects invent main include, projects invent main OS include, etc. There are even more possibilities. Check out the path option for info. If you want to see which included files are actually found, use this command, :check path bang. You will get a very long list of included files, the files they include, and so on. To shorten the list a bit, Vim shows already listed for files that were found before and doesn't list the included files in there again. Jump to a match. Open square bracket I produces a list with only one line of text. When you want to have a closer look at the first item, you can jump to that line with the command open square bracket tab. You can also use open square bracket Control-I, since Control-I is the same as pressing tab. The list that open square bracket I produces has a number at the start of each line. When you want to jump to another item than the first one, type the number first. Free open square bracket tab. We'll jump to the third item in the list. Remember that you can use Ctrl-O to jump back to where you started from. Related commands. Open square bracket I only lists the first match. Close square bracket I only lists the items below the cursor. And close square bracket I only lists the first item below the cursor. Finding the find identifiers. The open square bracket I command finds any identifier. To find only macros defined with #define, use open square bracket D. Again, this searches in included files. The define option specifies what a line looks like that defines the item for open square bracket D. You could change it to make it work with other languages than C or C++. The commands related to open square bracket D are open square bracket d, only lists the first match, close square bracket uppercase D only lists item below the cursor, and close square bracket lowercase d only lists the first item below the cursor. Chapter 29, Part 5, Finding Local Identifiers. The open square bracket capital I command searches included files. To search in the current file only and jump to the first place where the word under the cursor is used, do G uppercase D. Hint, go to definition. This command is very useful to find a variable or function that was declared locally. Static in C terms. Example, cursor on counter. So if we had static int counter equals 0, int get underscore counter, so if we had static int counter equals 0, semicolon, int get underscore counter and then void in parentheses, open curly brace, plus plus counter, semicolon, return counter, semicolon, close curly brace. So if we had the cursor on counter and we did G capital D, it would take us here. To restrict the search even further and look only in the current function, use this command, GD. This will go back to the start of the current function and find the first occurrence of the word under the cursor. Actually searches backwards to an empty line above a open curly brace in the first column. From there it searches forward for the identifier. Example where the cursor is on IDX. So you have int find underscore entry, open parentheses, char, asterisk name close parentheses, open curly brace, int idx semicolon, for open parentheses idx equals 0 semicolon, idx is less than table underscore len, semicolon, plus plus idx, close parentheses, if open parentheses strcmp, open parentheses table, open square bracket idx, close square bracket dot name, colon, name open, close parentheses equals 0, close parentheses, then return idx semicolon, and then close curly bracket. So if we were on idx right here, and we did GD, it would take us here to where it was initialized. Editing programs. Vim has various commands that aid in writing computer programs. Compile a program and directly jump to reported errors. Automatically set the indent for many languages and format comments. Chapter 30, Part 1, Compiling. Vim has a set of so-called quick fix commands. They enable you to compile a program from within Vim and then go through the errors generated and fix them, hopefully. You can then recompile and fix any new errors that are found until finally your program compiles without any error. The following command runs the program make, supplying it with any argument you give, and captures the results. Make arguments. If errors were generated, they are captured and the editor positions you where the first error occurred. Take a look at an example, make session. Typical make sessions generate far more errors and fewer stupid ones. After typing make, the screen looks like this. From this you can see that you have errors in the file main.c. When you press enter, Vim displays the file main.c with the cursor positioned on line 6. The first line with an error. You did not need to specify the file or the line number. Vim knew where to go by looking in the error message. The following command goes to where the next error occurs, C next. Vim jumps to line 10, the last line in the file, where there is an extra close curly bracket. When there is not enough room, Vim will shorten the error message. To see the whole message, use :cc. You can get an overview of all the error messages with the :clist command. The output looks like this. :c list, free main.c, 6, too many arguments to function do _sub, 5 main.c, 10, pass error before close curly bracket. Only the lines where Vim recognized the file name and line number are listed here. It assumes those are the interesting lines and the rest is just boring messages. However, sometimes unrecognized lines do contain something you want to see. Output from the linker, for example, about an undefined function. To see all the messages, add a bang to the command. So if you do :c list bang, you get 1 gcc-g-wall-o prog main.c sub.c, 2 main.c in function main, 3 main.c 6 too many arguments to function do_sub, 4 main.c at top level, 5 main.c 10 pass error before close curly bracket, 6 make 3 asterisks prog error 1. Vim will highlight the current error. To go back to the previous error, use C previous. Other commands to move around in the error list are C first to first error, C last to last error, and CC3 to error number 3. Using another compiler. The name of the program to run when the :make command is executed is defined by the make PRG option. Usually this is set to make, but Visual C++ users should set this to nmake by executing the following command: :set make PRG equals nmake. You can also include arguments in this option. Special characters need to be escaped with a backslash. Example: :set make PRG equal nmake \f project.mak. You can include special Vim keywords in the command specification. The %sign character expands to the name of the current file, so if you execute the command :set make PRG equal make \$S, when you are editing main.c, then :make executes the following command: make main.c. This is not too useful, so you will refine the command a little and use the :r for root modifier. So you do :set make PRG equal make \%r $S.o. Now the command executed is as follows: make main.o. More about these modifiers here. File name -modifiers. Old error lists. Suppose you make a program. There is a warning message in one file and an error message in another. You fix the error and use :make again to check if it was really fixed. Now you want to look at the warning message. It doesn't show up in the last error list since the file with the warning wasn't compiled again. You can go back to the previous error list with :c older. Then use :c list and :cc number to jump to the place with the warning. To go forward to the next error list, do :c newer. Vim remembers 10 error lists. Switching compilers. You have to tell Vim what format the error messages are that your compiler produces. This is done with the error format option. The syntax of this option is quite complicated and it can be made to fit almost any compiler. You can find the explanation here: error format. You might be using various different compilers. Setting the make PRG option and especially the error format each time is not easy. Vim offers a simple method for this. For example, to switch to using the Microsoft Visual C++ compiler, do :compiler msvc. This will find the Vim script for the msvc compiler and set the appropriate options. You can write your own compiler files. See write-compiler-plugin. Output redirection. The :make command redirects the output of the executed program to an error file. How this works depends on various things, such as the shell. If your :make command doesn't capture the output, check the make EF and shell pipe options. The shell quote and shell xquote options might also matter. In case you can't get :make to redirect the file for you, an alternative is to compile the program in another window and redirect the output into a file. Then have Vim read this file with :c file name. Jumping to errors will work like with the :make command. Chapter 30 Part 2 Indenting C-style text. A program is much easier to understand when the lines have been properly indented. Vim offers various ways to make this less work. For C and C-style programs like Java or C++, set the C indent option. Vim knows a lot about C programs and will try very hard to automatically set the indent for you. Set the shift width option to the amount of spaces you want for a deeper level. 4 spaces will work fine. $1:set command will do it. $set C indent shift width equals 4. With this option enabled, when you type something such as if x, the next line will automatically be indented an additional level. And here we see how the lines will be indented and unindented accordingly. When you type something in curly braces, the text will be indented at the start and unindented at the end. The unindenting will happen after typing the closed curly brace, since Vim can't guess what you are going to type. One side effect of automatic indentation is that it helps you catch errors in your code early. When you type a close curly brace to finish a function, only to find that the automatic indentation gives a more indent than what you expected, there is probably a close curly brace missing. Use the %sign command to find out which open curly brace matches the close curly brace you typed. A missing close parentheses and semicolon also cause extra indent. Thus, if you get more white space than you would expect, check the preceding lines. When you have code that is badly formatted, or you inserted and deleted lines, you need to re-indent the lines. The equals operator does this. The simplest form is equals equals. This indents the current line. Like with all operators, there are 3 ways to use it. In visual mode, equals indents the selected lines. A useful text object is a open curly brace. This selects the current curly brace block. Thus, to re-indent the code block the cursor is in, do equals a open curly brace. If you have really badly indented code, you can re-indent the whole file with gg equals capital G. However, don't do this in files that you have carefully indented manually. The automatic indenting does a good job, but in some situations you might want to overrule it. Setting indent style. Different people have different styles of indentation. By default, Vim does a pretty good job of indenting in a way that 90% of programmers do. There are different styles, however, so if you want to, you can customize the indentation style with the See in Options option. By default, See in Options is empty and Vim uses the default style. You can add various items where you want something different. For example, to make curly braces be placed like this, so the curly brace is placed after the line and not at the end of the line, use this command, :set See in Options plus equals open curly brace 2. There are many of these items. See in Options dash values. Chapter 30, Part 3, Automatic Indenting. You don't want to switch on the C indent option manually every time you edit a C file. This is how you make it work automatically. File type indent on. Actually, this does a lot more than switching on C indent for C files. First of all, it enables detecting the type of a file. That's the same as what is used for syntax highlighting. When the file type is known, Vim will search for an indent file for this type of file. The Vim distribution includes a number of these for various programming languages. This indent file will then prepare for automatic indenting specifically for this file. If you don't like the automatic indenting, you can switch it off again by doing file type indent off. If you don't like the indenting for one specific type of file, this is how you avoid it. Create a file with just this one line. let b:did_indent equals 1. Now you need to write this in a file with a specific name. So you do directory /indent/filetype.vim. The file type is the name of the file type such as CPP or Java. You can see the exact name that Vim detected with this command, :set file type. In this file, the output is file type equals help. Thus, you would use help for file type. For the directory part, you need to use your runtime directory. Look at the output of this command, :set runtime path. Now use the first item, the name before the first comma. Thus, if the output looks like this, runtime path equals /docconfig/nvim, /usr/local/share/vim/vim60/runtime, ~docconfig/nvim/after. You use tilde/doc_config/nvim for directory. Then the resulting file name is tilde/doc_config/nvim/indent/help.vim. Instead of switching the indenting off, you could write your own indent file. How to do that is explained here, :indent-expression. Chapter 30, Part 4, Other Indenting. The simplest form of automatic indenting is with the auto-indent option. It uses the indent from the previous line. A bit smarter is the smart indent option. This is useful for languages where no indent file is available. Smart indent is not as smart as C indent, but smarter than auto indent. With smart indent set, an extra level of indentation is added for each open curly bracket and removed for each closed curly bracket. An extra level of indentation will also be added for any of the words in the C in words option. Lines that begin with hash are treated specially. All indentation is removed. This is done so that preprocessor directives will all start in column 1. The indentation is restored for the next line. Correcting indents. When you are using auto indent or smart indent to get the indent of the previous line, there will be many times when you need to add or remove one shift width worth of indent. A quick way to do this is using the Ctrl-D and Ctrl-T commands in insert mode. For example, you are typing a shell script that is supposed to look like this. If test-n a semicolon, then echo a, echo double quote a bunch of hyphens, double quote, fi. Start off by setting these options. :set auto indent shift width equals 3. You start by typing the first line, enter, in the start of the second line, if test-n a semicolon, then echo. Now you see that you need an extra indent. Type Ctrl-T. The result, if test-n a semicolon, then echo, but echo is indented. The Ctrl-T command in insert mode adds one shift width to the indent no matter where in the line you are. You continue typing the second line, enter, and the third line. This time, the indent is okay. Then enter and the last line. Now you have this. If test-n a semicolon, then echo a, echo double quote a bunch of hyphens double quote, and then fi. But the fi is indented where it shouldn't be. To remove the superfluous indent in the last line, press Ctrl-D. This deletes the shift width worth of indent, no matter where you are in the line. When you are in normal mode, you can use the greater than and lesser than commands to shift lines. Greater than and less than are operators, thus you have the usual free ways to specify the lines you want to indent. A useful combination is greater than I open curly brace. This adds one line to the current block of lines inside curly braces. The open curly brace and close curly brace lines themselves are left unmodified. Greater than a open curly brace includes them. In this example, the cursor is on printf. So you have if flag in parentheses, new line open curly brace, new line printf open parentheses double quote yes double quote close parentheses semicolon new line flag equals 0 semicolon new line close curly brace. After you do greater than I open curly brace, the contents of the braces get indented, and if you do greater than a open curly brace, the curly braces themselves get indented. Chapter 30, Part 5, Tabs and Spaces. Tab stop is set to 8 by default. Although you can change it, you quickly run into trouble later. Other programs won't know what tab stop value you used. They probably use the default value of 8 and your text suddenly looks very different. Also, most printers use a fixed tab stop value of 8. Thus, it's best to keep tab stop alone. If you edit a file, which was written with a different tab stop setting, see Chapter 25 Part 3 for how to fix that. For indenting lines in a program, using a multiple of 8 spaces makes you quickly run into the right border of the window. Using a single space doesn't provide enough visual difference. Many people prefer to use 4 spaces, a good compromise. Since a tab is 8 spaces and you want to use an indent of 4 spaces, you can't use a tab character to make your indent. There are 2 ways to handle this. 1. Using mix of tab and space characters. Since a tab takes the place of 8 spaces, you have fewer characters in your file. Inserting a tab is quicker than 8 spaces. Backspacing works faster as well. 2. Use spaces only. This avoids the trouble with programs that use a different tab stop value. Fortunately, Vim supports both methods quite well. Spaces and tabs. If you are using a combination of tabs and spaces, you just edit normally. The Vim defaults do a fine job of handling things. You can make life a little easier by setting the soft tab stop option. This option tells Vim to make the tab key look and feel as if tabs were set at the value of soft tab stop, but actually use a combination of tabs and spaces. After you execute the following command, every time you press the tab key, the cursor moves to the next 4-column boundary. :set soft tab stop equals 4. When you start in the first column and press tab, you get 4 spaces inserted in your text. The second time, Vim takes out the 4 spaces and puts in a tab, thus taking you to column 8. Thus Vim uses as many tabs as possible, and then fills up with spaces. When backspacing, it works the other way around. A backspace will always delete the amount specified with soft tab stop. Then tabs are used, as many as possible, and spaces to fill the gap. The following shows what happens pressing tab a few times, and then using backspace. A period stands for a space, and 7 hyphens and greater than for a tab. So if you do tab, you get 4 spaces. If you do tab tab, you get a tab. If you do tab tab tab, you get a tab and 4 spaces. If you do tab 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 backspace, you get a tab. And if you do tab 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 backspace backspace, you get 4 spaces. An alternative is to use the Smart Tab option. When it's set, Vim uses shift width for a tab typed in the indent of a line, and a real tab when typed after the first non-blank character. However, backspace doesn't work like with soft tab stop. Just spaces. If you want absolutely no tabs in your file, you can set the expand tab option, :set expand tab. When this option is set, the tab key inserts a series of spaces. Thus you get the same amount of white space as if a tab character was inserted, but there isn't a real tab character in your file. The backspace key will delete each space by itself. Thus after typing one tab, you have to press the backspace key up to 8 times to undo it. If you are in the indent, pressing Ctrl-D will be a lot quicker. Changing tabs and spaces, and back. Setting expand tab does not affect any existing tabs. In other words, any tabs in the document remain tabs. If you want to convert tabs to spaces, use the :retab command. Use these commands: :set expand tab, %retab. Now Vim will have changed all indents to use spaces instead of tabs. However, all tabs that come after a non-blank character are kept. If you want these to be converted as well, add a bang. So you do $retab bang. This is a little bit dangerous because it can also change tabs inside a string. To check if these exist, you could use this: / left bracket, caret /t right bracket, asterisk /t left bracket, caret right bracket, asterisk . It's recommended not to use hard tabs inside a string. Replace them with /t to avoid trouble. The other way around works just as well: :set no expand tab, %retab bang. Chapter 30 Part 6 Formatting Comments. One of the great things about Vim is that it understands comments. You can ask Vim to format a comment and it will do the right thing. Suppose, for example, that you have the following comment. This is a test of the text formatting, and it's on 2 different lines. You then ask Vim to format it by positioning the cursor at the start of the comment and type GQ right bracket /. GQ is the operator to format text. Right bracket / is the motion that takes you to the end of a comment. The result is this is a test of the text formatting and it's on one line. Notice that Vim properly handled the beginning of each line. An alternative is to select the text that is to be formatted in visual mode and type GQ. To add a new line to the comment, position the cursor on the middle line and press O. The result looks like this. This is a test of the text formatting. Vim has automatically inserted a star and a space for you. Now you can type the comment text. When it gets longer than text width, Vim will break the line. Again, the star is inserted automatically. This is a test of the text formatting, new line. Typing a lot of text here will make Vim, new line, break. For this to work, some flags must be present in format options. R. Insert the star when typing enter in insert mode. O. Insert the star when using O or capital case O in normal mode. C. Break comment text according to text width. See FO-table for more flags. Defining a comment. The comments option defines what a comment looks like. Vim distinguishes between a single line comment and a comment that has a different start, end, and middle part. Many single line comments start with a specific character. In C++, double / is used. In makefiles, hash, in Vim scripts, double quote. For example, to make Vim understand C++ comments, do :set comments equals : double /. The colon separates the flags of an item from the text by which the comment is recognized. The general form of an item in comments is flags : text. The flags part can be empty, as in this case. Several of these items can be concatenated, separated by commas. This allows recognizing different types of comments at the same time. For example, let's edit an email message. When retyping, the text that others wrote is processed with greater than and bang characters. This command would work. :set comments equals n, greater than, n, bang. There are two items, one for comments starting with greater than and one for comments that start with bang. Both use the flag n. This means that these comments nest. Thus a line starting with greater than may have another comment after the greater than. This allows formatting a message like this. Greater than bang, did you see that sight? New line. Greater than bang, it looks really great. New line. Greater than, I don't like it. The, new line. Greater than, colors are terrible. New line. What is the URL of that? New line. Site. Try setting text width to a different value, example 80, and format the text by visually selecting it and typing GQ. The result is that the lines above have been formatted into 3 different lines. So on the first line we have greater than bang. Did you see that site? It looks really great. The second line is greater than I don't like it, the colors are terrible. And the third line is what is the URL of that site. You will notice that Vim did not move text from one type of comment to another. The capital I in the second line would have fit at the end of the first line. But since that line starts with greater than bang, and the second line starts with greater than, Vim knows that this is a different kind of comment. A 3-part comment. A C comment starts with /*, has asterisk in the middle, and asterisk / at the end. The entry in comments for this looks like this. :set comments equals S1 : MB : EX : *. The start is defined with the S1 : *. The S indicates the start of a 3-piece comment. The colon separates the flags from the text by which the comment is recognized. /*. There is one flag, 1. This tells Vim that the middle part has an offset of 1 space. The middle part, MB : *, starts with M, which indicates it is a middle part. The B flag means that a blank must follow the text. Otherwise, Vim would consider text like asterisk pointer also to be the middle of a comment. The end part, ex:** has the E for identification. The X flag has a special meaning. It means that after Vim automatically inserted a star, typing / will remove the extra space. For more details, see Format-Comments. Exploiting the GUI. Vim works well in a terminal, but the GUI has a few extra items. A file browser can be used for commands that use a file, a dialog to make a choice between alternatives. Use keyboard shortcuts to access menu items quickly. Chapter 31, Part 1, the file browser. When using the File, Open menu, you get a file browser. This makes it easier to find the file you want to edit. But what if you want to split a window to edit another file? There is no menu entry for this. You could first use Window Split and then File Open, but that's more work. Since you are typing most commands in Vim, opening the file browser with a typed command is possible as well. To make the split command use the file browser, prepend browse. So do :browse split. Select a file and then the :split command will execute with it. If you cancel the file dialog, nothing happens, the window isn't split. You can also specify a file name argument. This is used to tell the file browser where to start. Example, :browse split /etc. The file browser will pop up starting in the directory /etc. The :browse command can be prepended to just about any command that opens a file. If no directory is specified, Vim will decide where to start the file browser. By default, it uses the same directory as the last time. Thus, when you used :browse split and selected a file in user local share, the next time you use a :browse, it will start in user local share again. This can be changed with the browse dir option. It can have one of three values. Last, use the last directory browsed, default. Buffer, use the same directory as the current buffer. Or current, use the current directory. For example, when you are in the directory /usr, editing the file user local share readme, then the command :set browse dir = buffer :browse edit will start the browser in user local share. Alternatively, :set browse dir = current :browse edit will start the browser in user. Note: to avoid using the mouse, most file browsers offer using key presses to navigate. Since this is different for every system, it is not explained here. Vim uses a standard browser when possible. Your system documentation should contain an explanation on the keyboard shortcuts somewhere. When you are not using the GUI version, you could use the File Explorer window to select files like in a file browser. However, this doesn't work for the :browse command. See netrw-browse. Chapter 31, Part 2, Confirmation. Vim protects you from accidentally overwriting a file and other ways to lose changes. If you do something that might be a bad thing to do, Vim produces an error message and suggests a pending bang if you really want to do it. To avoid retyping the command with the bang, you can make Vim give you a dialog. You can then press OK or cancel to tell Vim what you want. For example, you are editing a file and made changes to it. You start editing another file with :confirm edit foo.txt. Vim will pop up a dialog that looks something like this. Save changes to bar.txt. Yes, no, cancel. Now make your choice. If you do want to save the changes, select yes. If you want to lose the changes forever, no. If you forgot what you were doing and want to check what really changed, use cancel. You will be back in the same file with the changes still there. Just like :browse, the :config command can be prepended to most commands that edit another file. They can also be combined by doing :confirm browse edit. This will produce a dialog when the current buffer was changed. Then it will pop up a file browser to select the file to edit. Note: in the dialog, you can use the keyboard to select the choice. Typically, the Tab key and the cursor keys change the choice. Pressing Enter selects the choice. This depends on the system though. When you are not using the GUI, the :confirm command works as well. Instead of popping up a dialog, Vim will print the message at the bottom of the Vim window and ask you to press a key to make a choice. :confirm edit main.c. Save changes to untitled. Yes, no, cancel. You can now press the single key for the choice. You don't have to press Enter, unlike other typing on the command line. Chapter 31, Part 3. Menu shortcuts. The keyboard is used for all Vim commands. The menus provide a simple way to select commands without knowing what they are called, but you have to move your hands from the keyboard and grab the mouse. Menus can often be selected with keys as well. This depends on your system, but most often it works this way. Use the Alt key in combination with the underlined letter of a menu. For example, Alt-W pops up the window menu. In the window menu, the split item has the P underlined. To select it, let go of the Alt key and press P. After the first selection of a menu with the Alt key, you can use the cursor keys to move through the menus. Right selects a submenu and left closes it. Escape also closes a menu. Enter selects a menu item. There is a conflict between using the Alt key to select menu items and using Alt key combinations for mappings. The Win Alt Keys option tells Vim what it should do with the Alt key. The default value menu is the smart choice. If the key combination is a menu shortcut, it can't be mapped. All other keys are available for mapping. The value No doesn't use any Alt keys for the menus. Thus you must use the mouse for the menus, and all Alt keys can be mapped. The value Yes means that Vim will use any Alt keys for the menus. Some Alt key combinations may also do other things than selecting a menu. Chapter 31, Part 4. Vim window position and size. To see the current Vim window position on the screen, use :win POS. This will only work in the GUI. The output may look like this: window position :x272, y103. The position is given in screen pixels. Now you can use the numbers to move Vim somewhere else. For example, to move it to the left 100 pixels, do :win POS 172103. Note: there may be a small offset between the reported position and where the window moves. This is because of the border around the window. This is added by the window manager. You can use this command in your startup script to position the window at a specific position. The size of the Vim window is computed in characters. Thus this depends on the size of the font being used. You can see the current size with this command: :set lines columns. To change the size, set the lines and/or columns options to a new value: :set lines equals 50, :set columns equals 80. Obtaining the size works in a terminal just like in the GUI. Setting the size is not possible in most terminals. You can start the X Windows version of gvim with an argument to specify the size and position of the window. Do gvim-geometry with X height plus X offset plus Y offset. Width and height are in characters, X offset and Y offset are in pixels. Example: gvim-geometry 80 by 25 plus 100 plus 300. Chapter 31, Part 5. Various. You can use gvim to edit an email message. In your email program, you must select gvim to be the editor for messages. When you try that, you will see that it doesn't work. The mail program thinks that editing is finished while gvim is still running. What happens is that gvim disconnects from the shell it was started in. That is fine when you start gvim in a terminal so that you can do other work in the terminal. But when you really want to wait for gvim to finish, you must prevent it from disconnecting. The -f argument does this. So gvim-f file.txt. The -f stands for foreground. Now Vim will block the shell it was started in until you finish editing and exit. Delayed start of the GUI. On Unix, it's possible to first start Vim in a terminal. That's useful if you do various tasks in the same shell. If you are editing a file and decide you want to use the GUI after all, you can start it with :GUI. Vim will open the GUI window and no longer use the terminal. You can continue using the terminal for something else. The -f argument is used here to run the GUI in the foreground. You can also use :GUI-f. The undo tree. Editor's note. It started raining, hopefully you can't hear that. Vim provides multi-level undo. If you undo a few changes and then make a new change, you create a branch in the undo tree. This text is about moving through the branches. Chapter 32, Part 1. Undo up to a file write. Sometimes you make several changes and then discover you want to go back to when you have last written the file. You can do that with this command, :earlier 1f. The F stands for file here. You can repeat this command to go further back in the past, or use a count different from 1 to go back faster. If you go back too far, go forward again with :later 1f. Note that these commands really work in time sequence. This matters if you made changes after undoing some changes. It's explained in the next section. Also note that we are talking about text writes here. For writing the undo information in a file, see undo-persistence. Chapter 32, Part 2. Numbering changes. In section 2.5, we only discussed one line of undo/redo. But it is also possible to branch off. This happens when you undo a few changes and then make a new change. The new changes become a branch in the undo tree. Let's start with the text 1. The first change to make is to append space 2, and then move to the first O and change it into W. We then have two changes, number 1 and 2, and 3 states of the text. So we start with 1, we add a 2, and then we change the second O to a W. If we now undo one change back to 1-2 and change 1 to me, we create a branch in the undo tree. So we have 1, which was change 1, and then it branches off from 1-2. Change 2 is that we change it to 2, as in the number 2, and if we go back, we go to change 3, that we can then go to me 2. You can now use the U command to undo. If you do this twice, you go to 1. Use Ctrl-R to redo, and you will go to 1-2. One more Ctrl-R takes you to the me 2. Thus undo and redo go up and down in the tree using the branch that was last used. What matters here is the order in which the changes are made. Undo and redo are not considered changes in this context. After each change, you have a new state of the text. Note that only the changes are numbered. The text shown in the tree above has no identifier. They are mostly referred to by the number of the change above it, but sometimes by the number of one of the changes below it, especially when moving up in the tree, so that you know which change was just undone. Chapter 32, Part 3. Jumping around the tree. So how do you get to 1-2 now? You can use this command, :undo 2. The text is now 1-2. You are below change 2. You can use the undo command to jump to below any change in the tree. Now make another change, change 1 to not. So we end up here. Now you change your mind and want to go back to me 2. Use the G- command. This moves back in time. Thus it doesn't walk the tree upwards or downwards, but goes to the change made before. You can repeat G- and you will see the text change from me 2 to 1-2 to 1-2 to 1. Use G+ to move forward in time. 1, 1-2, 1-2, me 2, not 2. Using :undo is useful if you know what change you want to jump to. G- and G+ are useful if you don't know exactly what the change number is. You can type a count before G- and G+ to repeat them. Chapter 32, Part 4, Time Traveling. When you have been working on text for a while, the tree grows to become big. Then you may want to go to the text of some minute ago. To see what branches there are in the undo tree, use this command, :undo list. So we have number, changes in time. So we have 3, 2, 16 seconds ago, 4, 3, 5 seconds ago. Here you can see the number of the leaves in each branch and when the change was made. Assuming we are below change 4 at 02, you can go back 10 seconds with this command, :earlier 10s. Depending on how much time you took for the changes, you end up at a certain position in the tree. The :earlier command argument can be M for minutes, H for hours, and D for days. So you go all the way back, use a big number. So for example, :earlier 100D. To travel forward in time again, use the :later command, :later 1M. The arguments are S, M, and H, just like with earlier. If you want even more details or want to manipulate the information, you can use the undo tree function. To set what it returns, do :echo undo tree, open parentheses, close parentheses. Make new commands. Vim is an extensible editor. You can take a sequence of commands you use often and turn it into a new command, or redefine an existing command. Auto commands make it possible to execute commands automatically. Chapter 40, Part 1, Key Mapping. A simple mapping was explained in section 5.3. The principle is that one sequence of keystrokes is translated into another sequence of keystrokes. This is a simple yet powerful mechanism. The simplest form is that one key is mapped to a sequence of keys. Since the function keys, except F1, have no predefined meaning in Vim, these are good choices to map. Example: :map F2 go date, :escape, :read, bang, date, carriage return, K capital J. This shows how 3 modes are used. After going to the last line with capital G, the O command opens a new line and starts insert mode. The text date is inserted and escape takes you out of insert mode. Notice the use of special keys inside less than and greater than. This is called angle bracket notation. You type these as separate characters, not by pressing the key itself. This makes the mapping better readable and you can copy and paste the text without problems. The : character takes Vim to the command line. The : read bang date command reads the output from the date command and appends it below the current line. The carriage return is required to execute the : read command. At this point of execution, the text looks like this: date : new line, Friday, June 15th, 12:54:34 CEST 2001. Now K capital J moves the cursor up and joins the lines together. To decide which key or keys you use for mapping, see map-which-keys. Mapping and modes. The :map command defines remapping for keys in normal mode. You can also define mappings for other modes. For example, :imap applies to insert mode. You can use it to insert a date below the cursor. :imap F2 carriage return date: escape: read bang date: return K capital J. It looks a lot like the mapping for F2 in normal mode, only the start is different. The F2 mapping for normal mode is still there, thus you can map the same key differently for each mode. Notice that although this mapping starts in insert mode, it ends in normal mode. If you wanted to continue in insert mode, append an A to the mapping. Here is an overview of map commands and in which mode they work. :map, normal, visual, and operator pending. :vmap, visual. :nmap, normal. :omap, operator pending. :map, bang, insert and command line. $imap insert $cmap command line. Operator pending mode is when you typed an operator character such as D or Y and you are expected to type the motion command or a text object. Thus, when you type DW, DW is entered in operator pending mode. Suppose that you want to define F7 so that the command df7 deletes a C program block, text enclosed in curly braces. Similarly, yf7 would yank the program block into the unnamed register. Therefore, what you need to do is to define F7 to select the current program block. You can do this with the following command: :omap F7 A open curly brace. This causes F7 to perform a select block A open curly brace in operator pending mode, just like you typed it. This mapping is useful if typing A open curly brace on your keyboard is a bit difficult. Listing mappings. To see the currently defined mappings, use :map without arguments, or one of the variants that include the mode in which they work. The output could look like this: _G :call mygrep1 carriage return vf2 :s/* greater than / carriage return :noh carriage return backtick nf2 :period comma $s/ / greater than / carriage return :noh carriage return backtick x home does home, x end does end. The first column of the list shows in which mode the mapping is effective. This is N for normal mode, Y for insert mode, etc. A blank is used for a mapping defined with :map, thus effective in both normal and visual mode. One useful purpose of listing the mapping is to check if special keys in angle brackets form have been recognized. This only works when color is supported. For example, when escape is displayed in color, it stands for the escape character. When it has the same color as the other text, it is 5 characters. Remapping. The result of a mapping is inspected for other mappings in it. For example, the mappings for F2 above could be shortened to :map F2 G F3, :imap F2 escape F3, :map F3 O D ATE escape read bang date carriage return J. For normal mode, F2 is mapped to go to the last line and then behave like F3 was pressed. In insert mode, F2 stops insert mode with escape and then also uses F3. And then F3 is mapped to do the actual work. Suppose you hardly ever use EX mode and want to use the Q command to format text. This was so in old versions of Vim. This mapping will do it: :map Q GQ. But in rare cases you need to use X mode anyway. Let's map G Q to Q so that you can still go to EX mode. :map G Q Q. What happens now is that when you type G Q, it is mapped to Q. So far so good. But the Q is mapped to GQ, thus typing G Q results in GQ, and you don't get to X mode at all. To avoid keys to be mapped again, use the :no remap command. :no remap G Q Q. Now Vim knows that the Q is not to be inspected for mappings that apply to it. There is a similar command for every mode. :no remap normal, visual, and operator pending. :v no remap for visual. :n no remap for normal. :o no remap for operator pending. :no remap bang insert in command line. :I no remap insert. :c no remap command line. Recursive mapping. When a mapping triggers itself, it will run forever. This can be used to repeat an action an unlimited number of times. For example, you have a list of files that contain a version number in the first line. You edit these files with vim*.txt. You are now editing the first file. Define this mapping. :map, $s/5.1/5.2/carriage return : W next, carriage return, Now you type This triggers the mapping. It replaces 5.1 with 5.2 in the first line. Then it does a $W next to write the file and edit the next one. The mapping ends in comma. This triggers the same mapping again, thus doing the substitution, etc. This continues until there is an error. In this case, it could be a file where the substitute command doesn't find a match for 5.1. You can then make a change to insert 5.1 and continue by typing comma again. Or the W next fails because you are in the last file in the list. When a mapping runs into an error halfway, the rest of the mapping is discarded. Control-C interrupts the mapping. Control-Break on MS Windows. Delete a mapping. To remove a mapping, use the :unmap command. Again, the mode the unmapping applies to depends on the command used. :unmap, normal, visual, and operator pending, :v unmap, visual, :n unmap, normal, :o unmap, operator pending, :u unmap, bang, insert in command line, :I unmap, insert, :c unmap, command line. There is a trick to define a mapping that works in normal and operator pending mode, but not in visual mode. First, define it for all three modes, then delete it for visual mode. :map, Control-A, / greater than, carriage return. :v unmap, Control-A. Notice that the 5 characters less than C-A greater than stand for the single key Control-A. To remove all mappings, use the :map clear command. You can guess the variations for different modes by now. Be careful with this command, it can't be undone. Special characters. The :map command can be followed by another command. A pipe character separates the two commands. This also means that a pipe character can't be used inside a map command. To include one, use less than bar greater than 5 characters. Example: :map F8 :right bar bang check-in %, S carriage return. The same problem applies to the :unmap command, with the addition that you have to watch out for trailing white space. These two commands are different. :unmap A pipe unmap B, :unmap A pipe unmap B. Where in the second one, there is no space between A and pipe. The first command tries to unmap A space with a trailing space. When using a space inside a mapping, use less than space greater than, or 7 characters. :map space W. This makes the spacebar move a blank, separated word forward. It is not possible to put a comment directly after a mapping, because the double quote character is considered to be part of the mapping. You can use pipe double quote. This starts a new empty command with a comment. Editor's note: because of the coloring, I assume there should be a backtick before the pipe. Maybe not. I'm not quite sure actually. Example: :map space uppercase W bar. Double quote, use spacebar to move forward a word. Mapping and abbreviations. Abbreviations are a lot like insert mode mappings. The arguments are handled in the same way. The main difference is the way they are triggered. An abbreviation is triggered by typing a non-word character after the word. A mapping is triggered when typing the last character. Another difference is that the characters you type for an abbreviation are inserted in the text while you type them. When the abbreviation is triggered, these characters are deleted and replaced by what the abbreviation produces. When typing the characters for a mapping, nothing is inserted until you type the last character that triggers it. If the Show CMD option is set, the typed characters are displayed in the last line of the Vim window. An exception is when a mapping is ambiguous. Suppose you have done 2 mappings: :imap AA foo, :imap AAA bar. Now when you type AA, Vim doesn't know if it should apply the first or the second mapping. It waits for another character to be typed. If it is an A, the second mapping is applied and results in bar. If it is a space, for example, The first mapping is applied, resulting in foo, and then the space is inserted. Additionally, the script keyword can be used to make a mapping local to a script. See :map -script. The buffer keyword can be used to make a mapping local to a specific buffer. See :map -buffer. The unique keyword can be used to make defining a new mapping fail when it already exists. Otherwise, a new mapping simply overwrites the old one. See :map -unique. To make a key do nothing, map it to <NOP greater than 5 characters. This will make the F7 key do nothing at all. :map F7 <NOP greater than bar map bang F7 <NOP greater than. There must be no space after <NOP greater than. Chapter 40 Part 2 Defining Command Line Commands. The Vim editor enables you to define your own commands. You execute these commands just like any other command line commands. To define a command, use the command as follows. command delete first, 1 delete. Now when you execute the command delete first, Vim executes :1 delete, which deletes the first line. Note, user-defined commands must start with a capital letter. You cannot use :next. The underscore cannot be used. You can use digits, but this is discouraged. To list the user-defined commands, execute the following command: command. Just like with the built-in commands, the user-defined commands can be abbreviated. You need to type just enough to distinguish the command from another. Command line completion can be used to get the full name. Number of arguments. User-defined commands can take a series of arguments. The number of arguments must be specified by the -n-args option. For instance, the example :delete first command takes no arguments, so you could have defined it as follows: command -n-args equals 0, delete first, 1 delete. However, because 0 arguments is the default, you do not need to add :n-args equals 0. The other values of :n-args are as follows: :n-args equals 0, no arguments, :n-args equals 1, 1 argument, :n-args equals asterisk, any number of arguments, :n-args equals question mark, 0 or 1 argument, -n-args equals plus 1 or more arguments. Using the arguments. Inside the command definition, the arguments are represented by the args keyword. For example, command -n-args equals plus say :echo double quote less than args greater than double quotes. Now when you type say hello world, Vim echoes hello world. However, if you add a double quote, it won't work. For example, say he said double quote hello double quote. To get special characters turned into a string, properly escaped to use an expression, use $q-args greater than double quote. So do command -n-args equals plus say :echo less than g-args greater than. Now the above say command will result in this to be executed. Echo double quote he said / double quote hello / double quote. The f-args keyword contains the same information as the args keyword, except in a format suitable for use as function call arguments. For example, command -n-args equals asterisk, do it call a function open parentheses less than f-args greater than close parentheses, and then do it a, b, c. Executes the following command: call a function open parentheses a in double quotes, comma b in double quotes, comma c in double quotes, close parentheses. Line range. Some commands take a range as their argument. To tell Vim that you are defining such a command, you need to specify a -range option. The values for this option are as follows: -range, range is allowed, default is the current line, -range equals %, range is allowed, default is the whole file, -range equals count, range is allowed, the last number in it is used as a single number whose default is count. When a range is specified, the keywords line 1 and line 2 get the values of the first and last line in the range. For example, the following command defines the saveat command, which writes out the specified range to the file save_file. Command -range equals %saveat less than line 1 greater than less than line 2 greater than write bang save_file. Other options. Some of the other options in keywords are as follows. -count equals number. The command can take a count whose default is number. The resulting count can be used through the count keyword. :bang, you can use a bang. If present, using bang will result in a bang. -register, you can specify a register. The default is the unnamed register. The register specification is available as less than reg greater than, aka less than register greater than. -complete equals type of command line completion used. See command -completion for the list of possible values. -bar, the command can be followed by pipe and another command or double quote and a comment. -buffer, the command is only available for the current buffer. Finally, you have the LT keyword. It stands for the character less than. Use this to escape the special meaning of angle bracket items mentioned. Redefining and deleting. To redefine the same command, use the bang argument. Command -n-args equals plus say echo double quote less than args greater than double quote. Command bang -n-args equals plus say echo less than q-args greater than. To delete a user command, use -del command. It takes a single argument, which is the name of the command. Example: :del command, save it. To delete all the user commands, do :com clear. Careful, this can't be undone. More details above this in the reference manual, user-commands. Chapter 40, Part 3, Auto Commands. An auto command is a command that is executed automatically in response to some event, such as a file being read or written or a buffer change. Through the use of auto commands, you can train Vim to edit compressed files. For example, that is used in the gzip plugin. Auto commands are very useful. Use them with care and they will help you avoid typing many commands. Use them carelessly and they will cause a lot of trouble. Suppose you want to replace a data stamp on the end of a file every time it is written. First, you define a function. So function date insert, $delete, read bang date, and function. You want this function to be called each time, just before a buffer is written to a file. This will make that happen. :autocmd buff write pre asterisk call date insert open parentheses close parentheses. Buff write pre is the event for which this auto command is triggered, just before pre writing a buffer to a file. The asterisk is a pattern to match with the file name. In this case, it matches all files. With this command enabled, when you do a :write, Vim checks for any matching buff write pre auto commands and executes them, and then it performs the :write. The general form of the :autocmd command is as follows: :autocmd group events file pattern ++ nested command. The group name is optional. It is used in managing and calling the commands, more on this later. The events parameter is a list of events, comma-separated, that trigger the command. File pattern is a file name, usually with wildcards. For example, using *.txt makes the auto command be used for all files whose name end in .txt. The optional ++ nested flag allows for nesting of auto commands, see below. And finally, command is the command to be executed. When adding an auto command, the already existing ones remain. To avoid adding the auto command several times, you should use this form: au group update time autocmd bang autocmd buff write pre asterisk call date insert open parentheses close parentheses au group end. This will delete any previously defined auto command with autocmd bang before defining the new one. Groups are explained later. Events. One of the most useful events is buff read post. It is triggered after a new file is being edited. It is commonly used to set option values. For example, you know that *.gsm files are a GNU assembly language. To set the syntax file right, define this auto command: :autocmd buff read post *.gsm set file type equal ASM. If Vim is able to detect the type of file, it will set the file type option for you. This triggers the file type event. Use this to do something when a certain type of file is edited. For example, to load a list of abbreviations for text files, do :autocmd file type text source ~.config /nvim/abrevs.vim. When starting to edit a new file, you could make Vim insert a skeleton: :autocmd buff new file *.ch in square brackets 0 read ~/skeletons/skel.c. See autocmd-events for a complete list of events. Patterns. The file pattern argument can actually be a comma-separated list of file patterns. For example, *.c, *.h matches files ending in .c and .h. The usual file wildcards can be used. Here is a summary of the most used ones. Asterisks match any character any number of times. Question mark match any character once. ABC in square brackets match the character A, B, or C. Period matches a dot. A and then open curly brace B, C close curly brace matches AB and AC. When the pattern indicates a /, Vim will compare directory names. Without the slash, only the last part of a file name is used. For example, *.txt matches /home /buyap /readme.txt. The pattern /home /buyap / would also match it, but home /foo /*.txt wouldn't. When including a slash, Vim matches the pattern against both the full path of the file /home /buyap /readme.txt and the relative path, example buyap /readme.txt. Note: when working on a system that uses a backslash as file separator, such as Microsoft Windows, you still use /s in auto commands. This makes it easier to write the pattern since a backslash has a special meaning. It also makes the auto commands portable. Deleting. To delete an auto command, use the same command as what it was defined with, but leave out the command at the end and use a bang. Example: :autocmd bang file write pre asterisk. This will delete all auto commands for the file write pre event that use the asterisk pattern. Listing. To list all the currently defined auto commands, use this: :autocmd. The list can be very long, especially when file type detection is used. To list only part of the commands, specify the group, event, and/or pattern. For example, to list all buff new file auto commands, do autocmd buff new file. To list all auto commands for the pattern, *.c. So do :autocmd***.c. Using asterisks for the event will list all the events. To list all auto commands for the C programs group, do :autocmd C programs. Groups. The group item used when defining an auto command groups related auto commands together. This can be used to delete all the auto commands in a certain group. For example, when defining several auto commands for a certain group, use the :au group command. For example, let's define auto commands for C programs. au group C programs autocmd buff read post *.c, *.h set sw equals 4 sts equals 4 auto command buff read post *.cpp set sw equals 3 sts equals 3 au group end. This will do the same as :autocmd C programs buff read post *.c *.h set sw equals 4 sts equals 4 auto command C programs buff read post *.cpp set sw equals 3 sts equals 3. To delete all auto commands in the C programs group, do :autocmd bang C programs. Nesting. Generally, commands executed as the result of an auto command event will not trigger any new events. If you read a file in response to a file changed shell event, it will not trigger the auto commands that would set the syntax, for example. To make the events triggered, use the ++ nested flag. :autocmd file changed shell *++ nested edit. Executing auto commands. It is possible to trigger an auto command by pretending an event has occurred. This is useful to have one auto command trigger another one. Example: :autocmd buffread post *new execute do autocmd buffread post period expand open parentheses less than a file greater than $r close parentheses. This defines an auto command that is triggered when a new file has been edited. The file name must end in .new. The :execute command uses expression evaluation to form a new command and execute it. When editing the file tryout.c.new, the executed command will be :do autocmd buffread post tryout.c. The expand function takes the less than a file greater than argument, which stands for the file name the auto command was executed for, and takes the root of the file name with :r. :do autocmd executes on the current buffer. The :do auto all command works like autocmd, except it executes on all the buffers. Using normal mode commands. The commands executed by an auto command are command line commands. If you want to use a normal mode command, the :normal command can be used. Example: :autocmd buffread post *log normal G. This will make the cursor jump to the last line of *log files when you start to edit it. Using the :normal command is a bit tricky. First of all, make sure its argument is a complete command, including all the arguments. When you use I to go to insert mode, there must also be a escape to leave insert mode again. If you use a / to start a search pattern, there must be a carriage return to execute it. The :normal command uses all the text after it as commands. Thus there can be no pipe and another command following. To work around this, put the :normal command inside a :execute command. This also makes it possible to pass unprintable characters in a convenient way. Example: :autocmd buffread post *.chg execute normal ONEW entry :\escape pipe \1 read bang date. This also shows the use of a / to break a long command into more lines. This can be used in Vim scripts, not at the command line. When you want the auto command to do something complicated, which involves jumping around in the file and then returning to the original position, you may want to restore the view of the file. See restore-position for an example. Ignoring events. At times you will not want to trigger an auto command. The event ignore option contains a list of events that will be totally ignored. For example, the following causes events for entering and leaving a window to be ignored. :set event ignore equals win enter win leave. To ignore all events, use the following command: :set event ignore equals all. To set it back to the normal behavior, make event ignore empty: :set event ignore equals. Write a Vim script. The Vim script language is used for the startup vimrc file, syntax files, and many other things. This chapter explains the items that can be used in a Vim script. There are a lot of them, thus this is a long chapter. Chapter 41 Part 1 Introduction. Your first experience with Vim scripts is in the vimrc file. Vim reads it when it starts up and executes the commands. You can set options to values you prefer, and you can use any command in it, commands that start with a colon. These are sometimes referred to as EX commands or command line commands. Syntax files are also Vim scripts, as are files that set options for a specific file type. A complicated macro can be defined by a separate Vim script file. You can think of other uses yourself. If you are familiar with Python, you can find a comparison between Python and Vim script here, with pointers to other documents. And if you are familiar with JavaScript, then have a look at this link. Let's start with a simple example. Let I equals 1, while I is less than 5, echo count is I, let I plus equals 1, and while. Note, the colon characters are not really needed here. You only need to use them when you type a command. In a Vim script file, they can be left out. We will use them here anyway to make clear these are colon commands and make them stand out from normal mode commands. Note, you can try out the examples by yanking the lines from the text here and executing them with colon at double quote. The output of the example code is count is 1, count is 2, count is 3, count is 4. In the first line, the let command assigns a value to a variable. The generic form is let variable equals expression. In this case, the variable name is I, and the expression is a simple value, the number 1. The while command starts a loop. The generic form is while condition, statements, and while. The statements until the matching and while are executed for as long as the condition is true. The condition used here is the expression I is less than 5. This is true when the variable I is smaller than 5. Note, if you happen to write a while loop that keeps on running, you can interrupt it by pressing Ctrl-C or Ctrl-Break on Microsoft Windows. The echo command prints its arguments. In this case, the string count is and the value of the variable I. Since I is 1, this will print count is 1. Then there is the let I plus equals 1 command. This does the same thing as let I equals I plus 1. This adds 1 to the variable I and assigns the new value to the same variable. The example was given to explain the commands, but would you really want to make such a loop, it can be written much more compact. For I in range of 1 to 4, echo count is 1 and 4. We won't explain how 4 in range work until later. Follow the links if you are impatient. 4 kinds of numbers. Numbers can be decimal, hexadecimal, octal, or binary. A hexadecimal number starts with 0 lowercase x or 0 capital X. For example, 0 lowercase x1f is decimal 31. An octal number starts with 0O or 0 capital O or a 0 and another digit. 0 lowercase o 17 is decimal 15. A binary number starts with 0b or 0 capital B. For example, 0b101 is decimal 5. A decimal number is just digits. Careful, don't put a 0 before a decimal number, it will be interpreted as an octal number. The echo command always prints decimal numbers. Example, echo 0x7f 0036, the output is 127 and 30. The number is made negative with a minus sign. This also works for hexadecimal, octal, and binary numbers. A minus sign is also used for subtraction. Compare this with the previous example. Echo 0x7f minus 0036 is 97. White space in an expression is ignored. However, it's recommended to use it for separating items to make the expression easier to read. For example, to avoid the confusion with a negative number above, put a space between the minus sign and the following number. Echo 0x7f space minus space 0036. Chapter 41, Part 2. Variables. A variable name consists of ASCII letters, digits, and the underscore. It cannot start with a digit. Valid variable names are counter underscore AAP3, very underscore long underscore variable underscore name underscore with underscore underscores, func length, and length. Invalid names are foo.bar and 6var. These variables are global. To see a list of currently defined variables, use this command, let. You can use global variables everywhere. This also means that when the variable count is used in one script file, it might also be used in another file. This leads to confusion at least and real problems at worst. To avoid this, you can use a variable local to a script file by prepending s:. For example, one script contains this code. Let s:count equal 1, while s:count is less than 5, source other.vim, let s:count plus equals 1, and while. Since s:count is local to the script, you can be sure that sourcing the other.vim script will not change this variable. If other.vim also uses an s:count variable, it will be a different copy local to the script. More about script-local variables here. Script-variable. There are more kinds of variables. See internal-variables. The most often used ones are b:\name, variable local to a buffer, w:\name, variable local to a window, g:\name, global variable, also in a function, and v:\name, variable predefined in Vim. Deleting variables. Variables take up memory and show up in the output of the :let command. To delete a variable, use the :unlet command. Example, :unlet s:count. This deletes the script local variable s:count to free up the memory it uses. If you are not sure if the variable exists and don't want an error message when it doesn't, append bang. So you do :unlet bang s:count. When a script has been processed to the end, the local variables declared there will not be deleted. Functions defined in the script can use them. Example, if bang exists s::call_count, let s::call_count equal 0, and if let s::call_count equal s::call_count plus 1, echo called s::call_count times. The exists function checks if a variable has already been defined. Its argument is the name of the variable you want to check, not the variable itself. If you would do this, if bang exists s::call_count. Then the value of s::call_count will be used as the name of the variable that exists checks. That's not what you want. The exclamation mark bang negates a value. When the value was true, it becomes false. When it was false, it becomes true. You can read it as not, thus if bang exists can be read as if not exists. What Vim calls true is anything that is not 0. 0 is false. Note, Vim automatically converts a string to a number when it is looking for a number. When using a string that doesn't start with a digit, the resulting number is 0. Thus look out for this, :if true. The true will be interpreted as a 0, thus a false. String variables and constants. So far, only numbers were used for the variable value. Strings can be used as well. Numbers and strings are the basic types of variables that Vim supports. The type is dynamic. It is set each time when assigning a value to the variable with :let. More about types in Chapter 41, Part 8. To assign a string value to a variable, you need to use a string constant. There are two types of these. First, the string in double quotes, let name equal Peter, echo name Peter. If you want to include a double quote inside the string, put a backslash in front of it. Let name equals double quote backslash double quote Peter backslash double quote echo name double quote Peter. To avoid the need for a backslash, you can use a string in single quotes. Let name equal single quote double quote Peter double quote single quote echo name double quote Peter double quote. Inside a single quote string, all the characters are as they are. Only the single quote itself is special. You need to use 2 to get 1. A backslash is taken literally, thus you can't use it to change the meaning of the character after it. In double quote strings, it is possible to use a special character. Here are a few ones. \t does tab, \n does new line or line break, \r does carriage return or enter, \e does escape, \b does backspace, double quote does double quote, 2 backslashes does backslash, \escape does escape, \c-w greater than does control-w. The last two are just examples. The \name form can be used to include the special key name. See expr-quote for the full list of special items in a string. Chapter 41, Part 3, Expressions. Vim has a rich yet simple way to handle expressions. You can read the definitions here. Expression-syntax. Here we will show the most common items. The numbers, strings, and variables mentioned above are expressions by themselves. Thus, everywhere an expression is expected, you can use a number, string, or variable. Other basic items in an expression are $name, environment variable, ampersand name, option, @r, register. Example, echo the value of tab stop is $ts. Echo your home directory is $home if @a greater than 5. The ampersand name form can be used to save an option value, set it to a new value, do something and restore the old value. Example, let save _IC equals $IC, set no IC, /the start $, $delete, let $IC equals save _IC. This makes sure the start pattern is used with the ignore case option off. Still, it keeps the value that the user had set. Another way to do this would be to add \C to the pattern. See /C. Mathematics. It becomes more interesting if we combine these basic items. Let's start with mathematics on numbers. A plus b is add, a minus b is subtract, a times b is multiply, a /b is divide, a %b is modulo. The usual precedence is used. Example, echo 10 plus 5 times 2 is 20. Grouping is done with parentheses. No surprises here. Example, echo open parentheses 10 plus 5 close parentheses asterisk 2 equals 30. Strings can be concatenated with period. See exp/6. Example, echo foo period bar results in foo bar. When the echo command gets multiple arguments, it separates them with a space. In the example, the argument is a single expression, thus no space is inserted. Borrowed from the C language is the conditional expression A?B: C. If A evaluates the true, B is used. Otherwise, C is used. Example, let I equals 4, echo I greater than 5, I is big, I is small, output I is small. The free parts of the constructs are always evaluated first. Thus you could see it work as A in parentheses, B in parentheses, C in parentheses. Chapter 1, Part 4, Conditionals. The "if" commands executes the following statements until the matching "end if" only when a condition is met. The generic form is if condition statements :end if. Only when the expression condition evaluates the true, non-zero, will these statements be executed. These must still be valid commands. If they contain garbage, Vim won't be able to find the :end if. You can also use :else. The generic form for this is if condition statement else statement end if. The second statement is only executed if the first one isn't. Finally, there is :else if condition statements, else if condition statements, end if. This works just like using :else and then if, but without the need for an extra :end if. A useful example for your vimrc file is checking the term option and doing something depending upon its value. If $term == x term, do stuff for x term. Else if $term == VT100, do stuff for a VT100 terminal. Else do something for other terminals, and if. Logic operations. We already used some of them in the examples. These are the most often used ones. A == B equal to, A =/ B not equal to, A greater than B greater than, A greater than or equal to B greater than or equal to B, A less than B less than, A less than or equal to B less than or equal to. The result is 1 if the condition is met and 0 otherwise. An example, if v: version greater than or equal to 700, echo congratulations. else echo you are using an old version, upgrade, and if. Here v-version is a variable defined by Vim, which has the value of the Vim version. 600 is for version 6.0. Version 6.1 has the value 601. This is very useful to write a script that works with multiple versions of Vim. v:\version. The logic operators work both for numbers and strings. When comparing two strings, the mathematical difference is used. This compares byte values, which may not be right for some languages. When comparing a string with a number, the string is first converted to a number. This is a bit tricky because when a string doesn't look like a number, the number 0 is used. Example, if 0 equals 1, echo yes and if. This will echo yes because 1 doesn't look like a number, thus it is converted to the number 0. For strings, there are two more items. A equals tilde b matches with, a bang tilde b does not match with. The left item A is used as a string, the right item B is used as a pattern, like what's used for searching. Example, if string equals tilde, double quote space double quote, echo string contains a space. And if string bang tilde, single quote backslash period $, single quote, echo string does not end in a full stop. End if. Notice the use of a single quote string for the pattern. This is useful because backslashes would need to be doubled in a double quote string, and patterns tend to contain many backslashes. The ignore case option is used when comparing strings. When you don't want that, append hash to match case and question mark to ignore case. Thus equals question mark compares two strings to be equal while ignoring case. And bang tilde hash checks if a pattern doesn't match, also checking the case of letters. For the full table, see expr-==. More looping. The :while command was already mentioned. Two more statements can be used in between the :while and the :end while. :continue. Jump back to the start of the while loop, the loop continues. :break, jump forward to the :end while, the loop is discontinued. Example, while counter is less than 40, call do something, if skip flag, continue, and if finish flag, break, and if sleep 50m, end while. The :sleep command makes Vim take a nap. The 50m specifies 50 milliseconds. Another example is :sleep 4, which sleeps for 4 seconds. Even more looping can be done with the :4 command. See below in Chapter 41, Part 8. Chapter 41, Part 5, Executing an Expression. So far the commands in the script were executed by Vim directly. The :execute command allows executing the result of an expression. This is a very powerful way to build commands and execute them. An example is to jump to a tag which is contained in a variable. :execute double quote tag space double quote concatenate tag underscore name. The double period is used to concatenate the string tag space with the value of variable tag name. Suppose tag name has the value getCMD. Then the command that will be executed is :tag getCMD. The :execute command can only execute commands. The :normal command executes normal mode commands. However, its argument is not an expression but the literal command characters. Example, :normal GG equals capital G. This jumps to the first line and formats all the lines with the equal operator. To make :normal work with an expression, combine :execute with it. Example, :execute normal space concatenate normal underscore commands. The variable normal commands must contain the normal mode commands. Make sure that the argument for :normal is a complete command. Otherwise, Vim will run into the end of the argument and abort the command. For example, if you start insert mode, you must leave insert mode as well. This works. :execute double quote normal capital I new text \escape double quote. This inserts new text space in the current line. Notice the use of the special key \escape. This avoids having to enter a real escape character in your script. If you don't want to execute a string but evaluate it to get its expression value, you can use the eval function. :let opt name equal path. let opt val equals val, open parentheses, single quote, ampersand, single quote, concatenate opt name, close parentheses. A ampersand character is prepended to path, thus the argument to eval is ampersand path. The result will be the value of the path option. The same thing can be done with :exe, single quote, let opt val equals ampersand, single quote, concatenate opt name. Chapter 41, Part 6, Using Functions. Vim defines many functions and provides a large amount of functionality that way. A few examples will be given in this section. You can find the whole list below, function-list. A function is called with the :call command. The parameters are passed in between parentheses, separated by commas. Example: :call search, open parentheses, double quote, date, :space, double quote, period, double quote, capital W, double quote, close parentheses. This calls the search function with arguments date and W. The search function uses its first argument as a search pattern and the second one is flags. The W flag means the search doesn't wrap around the end of the line. A function can be called in an expression. Example: let line equal get line, period. Let REPL equal substitute line, \a, asterisk g, call set line, period, REPL. The getLine function obtains a line from the current buffer. Its argument is a specification of the line number. In this case, period is used, which means the line where the cursor is. The substitute function does something similar to the :substitute command. The first argument is the string on which to perform the substitution. The second argument is the pattern. The third, the replacement string. Finally, the last arguments are the flags. The setLine function sets the line, specified by the first argument, to a new string, the second argument. In this example, the line under the cursor is replaced with the result of the substitute. Thus, the effect of the three statements is equal to :substitute /\a /*g. Using the functions becomes interesting when you do more work before and after the substitute call. Functions. There are many functions. We will mention them here, grouped by what they are used for. You can find an alphabetical list here, built-in -function -details. Use control right bracket on the function name to jump to detail help on it. nr to char, get a character by its number value. List to string, get a character string from a list of numbers. Char to nr, get number value of a character. String to list, get list of numbers from a string. String to nr, convert a string to a number. String to float, convert a string to a float. Printf, format a string according to percentage items. Escape, escape characters in a string with a \. Shell escape, escape a string for use with a shell command. If name escape, escape a file name for use with a vim command. Tr, translate characters from one set to another. String trans, translate a string to make it printable. Key trans, translate internal key codes to a form that can be used by :map. To lower, turn a string to lowercase. To upper, turn a string to uppercase. Char class, class of a character. Match, position where a pattern matches in a string. Match buffline, all the matches of a pattern in a buffer. Match end, position where a pattern match ends in a string. Match fuzzy, fuzzy matches a string in a list of strings. Match fuzzy POS, fuzzy matches a string in a list of strings. Match string, match of a pattern in a string. Match string list, all the matches of a pattern in a list of strings. Match string pos, match impositions of a pattern in a string. Match list, like match string and also return submatches. String idx, first index of a short string in a long string. String ridx, last index of a short string in a long string. String len, length of a string in bytes. String char len, length of a string in characters. String chars, number of characters in a string. String UTF-16 len, number of UTF-16 code units in a string. string width, size of string when displayed, string display width, size of string when displayed deals with tabs, set cell widths, set character cell width overrides, get cell widths, get character cell width overrides, reverse the order of characters in a string, substitute a pattern match with a string, submatch, get a specific match in :s in substitute, string part, get part of a string using byte index, string car part, get part of a string using car index, slice, take a slice of a string using car index in Vim 9 script, string get car, get character from a string using car index, expand special keywords, expand a command like done for :edit, icon v, convert text from one encoding to another, byte idx, byte index of a character in a string, byte idx comp, like byte idx but count composing characters, car idx, character index of a byte in a string, utf-16 idx, utf-16 index of a byte in a string, repeat a string multiple times, evaluate a string expression, execute an x command and get the output, win_execute, like execute but in a specific window, trim characters from a string, get text lookup message translation, list manipulation, get an item without error for wrong index, len, number of items in a list, empty, check if list is empty, insert an item somewhere in a list, add, append an item to a list, extend, append a list to a list, extend new, make a new list and append items, remove one or more items from a list, copy, make a shallow copy of a list, deep copy, make a full copy of a list, filter, remove selected items from a list, map, change each list window, map new, make a new list with changed items, for each, apply function to list items, reduce a list to a value, slice, take a slice of a list, sort a list, reverse the order of items in a list, unique, remove copies of repeated adjacent items, split a string into a list, join list items into a string, range, return a list with a sequence of numbers, string representation of a list, call a function with list as arguments, index of a value in a list or blob, index in a list or blob where the expression evaluates to true, maximum value in a list, minimum value in a list, count number of times a value appears in a list, repeat a list multiple times, flatten a list, flatten new, flatten a copy of a list. Dictionary manipulation. Get an entry without an error for a wrong key. Len, number of entries in a dictionary. Has_key, check whether a key appears in a dictionary. Empty, check if dictionary is empty. Remove an entry from a dictionary. Extend, add entries from one dictionary to another. Extend new, make a new dictionary and append items. Filter, remove selected entries from a dictionary. Map, change each dictionary entry. Map new, make a new dictionary with changed items. For each, apply function to dictionary items. Keys, get list of dictionary keys. Values, get list of dictionary values. Items, get list of dictionary key value pairs. Copy, make a shallow copy of a dictionary. Deep copy, make a full copy of a dictionary. String representation of a dictionary. Maximum value in a dictionary. Minimum value in a dictionary. Count number of times a value appears. Floating point computation. Float to NR, convert float to number. ABS, absolute value, also works for number. Round off. Seal, round up. Floor, round down. Trunk, remove value after decimal point. Fmod, remainder of division. Exp, exponential. Log, natural logarithm, logarithm to base e. Log 10, logarithm to base 10. Pow, value of x to the exponent y. Sqrt, square root. Sin, sine. Cos, cosine. Tan, tangent. Asyn, arcsine. a cos, arc cosine, a tan, arc tangent, a tan 2, arc tangent, sin h, hyperbolic sine, cos h, hyperbolic cosine, tan h, hyperbolic tangent, is inf, check for infinity, is nan, check for not a number. Blob manipulation. Blob to list, get a list of numbers from a blob. List to blob, get a blob from a list of numbers. Reverse, reverse the order of numbers in a blob. Other computation. And, bitwise and, invert, bitwise invert, or, bitwise or, XOR, bitwise XOR, SHA-256, SHA-256 hash, rand, get a pseudo-random number, srand, initialize seed used by rand. Variables. Type. Type of a variable. Is locked, check if a variable is locked. Funcref, get a funcref for a function reference. Function, get a funcref for a function name. Get buffvar, get a variable value from a specific buffer. Set buffvar, set a variable in a specific buffer. Get winvar, get a variable from a specific window. Get tabvar, get a variable from a specific tab page. Get tab winvar, get a variable from specific window and tab page. Set winvar, set a variable in a specific window. Set tabvar, set a variable in a specific tab page. Set tab winvar, set a variable in a specific window and tab page. Garbage collect, possibly free memory. Cursor and mark position. Call, column number of the cursor or a mark. Vert call, screen column of the cursor or a mark. Line, line number of the cursor or mark. Win call, window column number of the cursor. Win line, window line number of the cursor. Cursor, position the cursor at a line/column. Screen call, get screen column of the cursor. Screen row, get screen row of the cursor. Screen POS, screen row and column of a text character. Vert call to call, byte index of a text character on screen. Get cur pos, get position of the cursor. Get pos, get position of the cursor, mark, etc. Set pos, set position of cursor, mark, etc. Get mark list, list of global/local marks. Byte to line, get line number at a specific byte count. Line to byte, byte count at a specific line. Diff_filler, get the number of filler lines above a line. Screen atter, get attribute at a screen line/row. Screen car, get character code at a screen line row. Screen cars, get character codes at a screen line row. Screen string, get string of characters at a screen line row. Charcoal, character number of the cursor or a mark. Get car pos, get character position of cursor, mark, etc. Set car pos, set character position of cursor, mark, etc. Get cursor car pos, get character position of the cursor. Set cursor car pos, set character position of the cursor. Working with text in the current buffer. Get line, get a line or list of lines from the buffer. Get region, get a region of text from the buffer. Get a region pos, get a list of positions for a region. Set line, replace a line in the buffer. Append, append line or list of lines in the buffer. Indent, indent of a specific line. C indent, indent according to C indenting. Lisp indent, indent according to Lisp indenting. Next non-blank, find next non-blank line. Prev non-blank, find previous non-blank line. Search, find a match for a pattern. Search pos, find the match for a pattern. Search count, get number of matches before/after the cursor. Search pair, find the other end of a start, skip, end. Search pair pos, find the other end of a start, skip, end. Search DECL, search for the declaration of a name. Get car search, return character search information. Set car search, set character search information. Working with text in another buffer. Get buff line, get a list of lines from the specific buffer. Get buff one line, get a one line from the specific buffer. Set buff line, replace a line in the specified buffer. Append buff line, append a list of lines in the specified buffer. Delete buff line, delete lines from a specific buffer. System functions in manipulation of files. Glob, expand wildcards. Glob path, expand wildcards in a number of directories. Glob to reg path, convert a glob pattern into a search pattern. Find file, find a file in a list of directories. Find dir, find a directory in a list of directories. Resolve, find out where a shortcut points to. Fname modify, modify a file name. Path shorten, shorten directory names in a path. Simplify, simplify a path without changing its meaning. Executable, check if an executable program exists. Exe path, full path of an executable program. File readable, check if a file can be read. File writable, check if a file can be written too. Get fperm, get the permissions of a file. Set fperm, set the permissions of a file. Get ftype, get the kind of a file. Is absolute path, check if a path is absolute. Is directory, check if a directory exists. Get fsize, get the size of a file. Get cwd, get the current working directory. Has local dir, check if current window used :lcd or :tcd. Temp name, get the name of a temporary file. Make dir, create a new directory. Chdir, change current working directory. Delete, delete a file. Rename, rename a file. System, get the result of a shell command as a string. System list, get the result of a shell command as a list. Environ, get all environment variables. Get env, get one environment variable. Set env, set an environment variable. Host name, name of the system. Read file, read a file into a list of files. Read blob, read a file into a blob. Read dir, get a list of file names in the directory. Write file, write a list of lines or blob into a file. File copy, copy a file from to. Date and time. Get ftime, get last modification time of a file. Local time, get current time in seconds. String ftime, convert time to a string. String ptime, convert a date time string to time. Rel time, get the current or elapsed time accurately. Rel time string, convert rel time result to a string. Rel time float, convert rel time result to a float. Buffers windows in the argument list. argc, number of entries in the argument list. argidx, current position in the argument list. arglist id, get id of the argument list. argv, get one entry from the argument list. Buff add, add a file to the list of buffers. Buff exists, check if a buffer exists. Buff listed, check if a buffer exists and is listed. Buff load, ensure a buffer is loaded. Buff loaded, check if a buffer exists and is loaded. Buff name, get the name of a specific buffer. Buff nr, get the buffer number of a specific buffer. Tab page buff list, return list of buffers in a tab page. Tab page nr, get the number of a tab page. Tab page win nr, like win nr for a specified tab page. Win nr, get the window number for the current window. Buff win id, get the window id of a specific buffer. Buff win nr, get the window number of a specific buffer. Win buff nr, get the buffer number of a specific window. Win underscore find buff, find window containing a buffer. Win underscore get id, get window id of a window. Win underscore get type of a window. Win underscore go to id, go to window with id. Win underscore id to tab win, get tab and window number from window id. Win underscore id to win, get window number from window id. Win underscore move underscore separator, move window vertical separator. Win underscore move underscore status line, move window status line. Win underscore split move, move window to a split of another window. Get buff info, get a list with buffer information. Get tab info, get a list with tab page information. Get win info, get a list with window information. Get change list, get a list of change list entries. Get jump list, get a list of jump list entries. Swap file list, list of existing swap files in directory. Swap info, information about a swap file. Swap name, get the swap file path of a buffer. Command line. get cmd compl pat, get completion pattern of the current command line, get cmd compl type, get the type of the current command line completion, get cmd line, get the current command line input, get cmd prompt, get the current command line prompt, get cmd pos, get position of the cursor in the command line, get cmd screen pos, get screen position of the cursor in the command line, set cmd line, set the current command line, set cmd pos, set position of the cursor in the command line, set cmd type, return the current command line type, get cmd win type, return the current command line window type, get completion, list of current line completion matches, full command, get full command name. Quick fix and location lists. Get qflist, list of quick fix errors. Set qflist, modify a quick fix list. Get locklist, list of location list items. Set locklist, modify a location list. Insert mode completion. Complete, set found matches. Complete underscore add to found matches. Complete underscore check if completion should be aborted. Complete underscore info, get current completion information. Pum visible, check if the pop-up menu is displayed. Pum underscore get pos, position and size of pop-up menu if visible. Folding. Fold closed, check for a closed fold at a specific line. Fold closed end, like fold closed but return the last line. Fold level, check for the fold level at a specific line. Fold text, generate the line displayed for a closed fold. Fold text result, get the text displayed for a closed fold. Syntax and highlighting. Clear matches. Clear all matches defined by match add and the :match commands. Get matches. Get all matches defined by match add and the :match commands. HL exists. Check if a highlight group exists. HLID. Get ID of a highlight group. Syn ID. Get syntax ID at a specific position. Syn ID atta. Get a specific attribute of a syntax ID. Syn ID trans. Get translated syntax ID. Syn stack. Get a list of syntax IDs at a specific position. Syn concealed. Get info about syntax concealing. Diff underscore HLID. Get highlight ID for diff mode at a position. Match add, define a pattern to highlight a match. Match add POS, define a list of positions to highlight. Match arg, get info about :match arguments. Match delete, delete a match defined by match adder or a :match command. Set matches, restore a list of matches saved by get matches. Spelling. Spell bad word, locate badly spelled word at or after cursor. Spell suggest, return suggested spelling corrections. Soundfold, return the sound-alike equivalent of a word. History. Hist add, add an item to a history. Hist del, delete an item from a history. Hist get, get an item from a history. Hist number, get highest index of a history list. Interactive. Browse, put up a file requester. Browse put up a file directory requester. Confirm, let the user make a choice. Get car, get a character from the user. Get car mod, get modifiers for the last typed character. Get mouse pos, get last known mouse position. Feed keys, put characters in the type ahead queue. Input, get a line from the user. Input list, let the user pick an entry from a list. Input secret, get a line from the user without showing it. Input dialog, get a line from the user in a dialog. Input save, save and clear type ahead. Input restore, restore type ahead. GUI, get font name. Get name of current font being used. Get win pos, position of the Vim window. Get win pos x, x position of the Vim window. Get win pos y, y position of the Vim window. Balloon underscore show, set the balloon content. Balloon underscore split, split a message for a balloon. Balloon underscore get text, get the text in the balloon. Vim server, server list, return the list of server names. remote underscore start server, run a server, remote underscore send command characters to a Vim server, remote underscore expr, evaluate an expression in a Vim server, server to client, send a reply to a client of a Vim server, remote underscore peek, check if there is a reply from a Vim server, remote underscore read a reply from a Vim server, foreground, meet the Vim window to the foreground, remote foreground, move the Vim server window to the foreground. Window size and position. Win height, get height of a specific window. Win width, get width of a specific window. Win screen pos, get screen position of a window. Win layout, get layout of windows in a tab page. Win rest cmd, return command to restore window sizes. Win save view, get view of current window. Win rest view, restore saved window of current window. Mappings and menus. Digraph underscore get list, get all digraphs. Digraph underscore set, register digraph. Digraph underscore set list, register multiple digraphs. Has map to, check if a mapping exists. Map check, check if a matching mapping exists. Map arg, get RHS of a mapping. Map list, get list of all mappings. Map set, restore a mapping. Menu underscore info, get information about a new item. Weld menu mode, check if the weld mode is active. Signs. Sign underscore define or update a sign. Sign underscore get defined, get a list of defined signs. Sign underscore get placed, get a list of placed signs. Sign underscore jump to a sign. Sign underscore place a sign. Sign underscore place a list of signs. Sign underscore undefine a sign. Sign underscore unplace a sign. Sign underscore unplace a list of signs. Testing. Assert underscore equal, assert that two expressions values are equal. Assert underscore equal file, assert that two file contents are equal. Assert underscore not equal, assert that two expressions values are not equal. Assert underscore in range, assert that an expression is inside a range. Assert underscore match, assert that a pattern matches the value. Assert underscore not match, assert that a pattern does not match the value. Assert underscore false, assert that an expression is false. Assert underscore true, assert that an expression is true. Assert underscore exception, assert that a command throws an exception. Assert underscore beeps, assert that a command beeps. Assert underscore no beep, assert that a command does not cause a beep. Assert underscore fails, assert that a command fails. Assert underscore report, report a test failure. Timer. Timer underscore start, create a timer. Timer underscore pause, pause or unpause a timer. Timer underscore stop, stop a timer. Timer underscore stop all timers. Timer underscore info, get information about timers. Wait for a condition. Tags. Tag list, get list of matching tags. Tag files, get a list of matching files. Get tag stack, get the tag stack of a window. Set tag stack, modify the tag stack of a window. Prompt buffer. Prompt underscore get prompt, get the effective prompt text for a buffer. Prompt underscore set callback, set prompt callback for a buffer. Prompt underscore set interrupt callback for a buffer. Prompt underscore set the prompt text for a buffer. Get reg, get contents of a register. Get reg info, get information about a register. Get reg type, get type of a register. Set reg, set contents and type of a register. Reg underscore executing, return the name of the register being executed. Reg underscore recording, return the name of the register being recorded. Context stack. CTX gen, return context at given index from top. CTX pop and restore top context. CTX push given context. CTX set context at given index from top. CTX size, return context stack size. Various. Mode, get current editing mode. Visual mode, last visual mode used. Exists, check if a variable, function, etc. exists. Has, check if a feature is supported in Vim. Change NR, return number of most recent change. Did underscore file type, check if a file type auto command was used. Event handler, check if invoked by an event handler. Get PID, get process ID of Vim. Get script info, get list of sourced Vim scripts. Get stack trace, get current stack trace of Vim scripts. Libcall, get a function in an external library. Libcall number, edem, returning a number. Undo file, get the name of the undo file. Undo tree, return the state of the undo tree for a buffer. Shift width, effective value of shift width. Word count, get byte word car count of buffer. Lua eval, evaluate Lua expression. Py-free eval, evaluate Python expression. Py-eval, evaluate Python expression. Py-x-eval, evaluate Python underscore x expression. Ruby eval, evaluate Ruby expression. Debug break, interrupt a program being debugged. Chapter 41, Part 7, Defining a function. Vim enables you to define your own functions. The basic function declaration begins as follows. Function, name, var1, var2, etc., body, and function. Note, function names must begin with a capital letter. Let's define a short function to return the smaller of two numbers. It starts with this line. Function min, and then num1, num2 in parentheses. This tells Vim that the function is named min, and it takes two arguments, num1 and num2. The first thing you need to do is to check to see which number is smaller. If a colon num1 less than a colon num2, the special prefix a colon tells Vim that the variable is a function argument. Let's assign the variable smaller the value of the smallest number. If a colon num1 is less than a colon num2, let smaller equal a colon num1, else let smaller equal a colon num2, and if. The variable smaller is a local variable. Variables used inside a function are local unless prefixed by something like g colon, a colon, or s colon. Note, to access a global variable from inside a function, you must prepend g colon to it. Thus, g colon today inside a function is used for the global variable today, and today is another variable local to the function. You now use the colon return statement to return the smallest number to the user. Finally, you end the function, return smaller, and function. The complete function definition is as follows. Function min num1 num2. If a colon num1 is less than a colon num2, let smaller equal a colon num1, else let smaller equal a colon num2, and if, return smaller, and function. For people who like short functions, this does the same thing. Function min num1 num2. If a colon num1 is less than a colon num2, return a colon num1, and if, return a colon num2, and function. A user-defined function is called in exactly the same way as a built-in function, only the name is different. The min function can be used like this: colon echo min, open parentheses, 5 colon 8, close parentheses. Only now will the function be executed and the lines be interpreted by Vim. If there are any mistakes, like using an undefined variable or function, you will now get an error message. When defining the function, these errors are not detected. When a function reaches colon end function or colon return is used without an argument, the function returns 0. To redefine a function that already exists, use the bang for the colon function command. Colon function bang min, open parentheses, num1, num2, num3, close parentheses. Using a range. The colon call command can be given a line range. This can have one or two meanings. When a function has been defined with the range keyword, it will take care of the line range itself. The function will be passed the variables a colon first line and a colon last line. These will have the line numbers from the range the function was called with. Example: function count underscore words range, let lnum equal a colon first line, let n equal 0, while lnum is less than or equal to a colon last line, let n equal n plus len, split, get line lnum, let lnum equal lnum plus 1, and while echo found, concatenate n, concatenate words, and function. You can call this function with :10, 30, call, count underscore words. It will be executed once and echo the number of words. The other way to use a line range is by defining a function without the range keyword. The function will be called once for every line in the range, with the cursor in that line. Example: function number, echo line concatenate line period, concatenate contains, concatenate get line period, end function. If you call this function with 10, 15 call number, the function will be called 6 times. Variable number of arguments. Vim enables you to define functions that have a variable number of arguments. The following command, for instance, defines a function that must have one argument, start, and can have up to 2 additional arguments. Function show start, dot. The variable a:1 contains the first optional argument, a:2 the second, and so on. The variable a:0 contains a number of extra arguments. For example, function show start, dot, echo hl title, echo start is, concatenate a:start, echo hl none. Let index equal 1, while index is less than or equal to a:0, echo arg, concatenate index, concatenate is, concatenate a:index, let index equal index plus 1, and while echo empty string, end function. This uses the :echo hl command to specify the highlighting used for the following :echo command. :echo hl none stops it again. The :echo n command works like :echo, but doesn't output a line break. You can also use the a:000 variable. It is a list of all the ... arguments. See a:000. Listing functions. The :function command lists the names and arguments of all user_defined functions. :function, function show start, etc., function get vim indent, function set sin name. To see what a function does, use its name as an argument for :function. Function set sin if ampersand syntax equals empty string, let ampersand syntax equal a:name, and if end function. Debugging. The line number is useful for when you get an error message or when debugging. See debug scripts about debugging mode. You can also set the verbose option to 12 or higher to see all function calls. Set it to 15 or higher to see every executed line. Deleting a function. To delete the show function, do :del function show. You get an error when the function doesn't exist. Function references. Sometimes it can be useful to have a variable point to one function or another. You can do it with the function. It returns the name of a function into a reference. So let result equal 0 or 1, function bang right, return right, end func, function bang wrong, return wrong, end func. If result equals 1, let a func equal function right, else let a func equal function wrong, and if echo core a func, square brackets, wrong. Note that the name of a variable that holds a function reference must start with a capital. Otherwise, it could be confused with the name of a built-in function. The way to invoke a function that a variable refers to is with the call function. Its first argument is the function reference, the second argument is a list with arguments. Function references are most useful in combination with a dictionary, as is explained in the next section. More information about defining your own functions here. User-function. Chapter 41, Part 8. Lists and dictionaries. So far we have used the basic types string and number. Vim also supports 2 composite types, list and dictionary. A list is an ordered sequence of things. The things can be any kind of value, thus you can make a list of numbers, a list of lists, and even a list of mixed items. To create a list with 3 strings, do let a list equal aap, mise, and newt in square brackets. The list items are enclosed in square brackets and separated by commas. To create an empty list, do let a list equal square brackets. You can add items to a list with the add function. Let a list equal square brackets, call add a list foo, call add a list bar, echo a list, and the result is a list containing foo and bar. List concatenation is done with plus. Echo a list plus, open square bracket, foo, comma, bar, close square bracket. And the result is that we've concatenated foo bar to the previous list, so now we have foo, and bar. Or if you want to extend a list directly, you can do let a list equal 1 in square brackets, call extend a list to 3, echo a list, and now have a list that contains 1, 2, and 3. Notice that using add will have a different effect. Let a list equal 1, call add a list to 3, echo a list, so now we have a main list that contains 1 and also a sublist that contains 2 and 3. The second argument of add is added as a single item. For loop. One of the nice things you can do with a list is iterate over it. Let a list equal 1, 2, 3 for n in a list, echo n, and 4. So now you have the items in the list all on a line each. This will loop over each element in list a list, assigning the value to variable n. The generic form of a for loop is for var name in list expression, commands, and for. To loop a certain number of times, you need a list of a specific length. The range function creates one for you. For a in range 3, echo a and 4, so then the output is 0, 1, and 2. Editor's note: in most languages we start counting from 0, which is why it's 0, 1, 2 and not 1, 2, 3. Notice that the first item of the list that range produces is 0, thus the last item is 1 less than the length of the list. You can also specify the maximum value, the stride, and even go backwards. For a in range, 8, 4, and minus 2, echo a, and 4. So now it outputs 8, 6, and 4. A more useful example, looping over lines in the buffer. For line in get line 1, 20, if line equal tilde date, colon space, echo match string line date \zs period asterisk, and if, and 4. This looks into lines 1 to 20 inclusive and echoes any date found in there. Editor's note: what this means is that it looks from 1 to 20 and that includes those numbers as well. For example, if you noticed earlier, when we had a range to 3, it stopped at 2 because that's not inclusive. It just means up to 3, but the 3 itself is not included. Dictionaries. A dictionary stores key-value pairs. You can quickly look up a value if you know the key. A dictionary is created with curly braces. So you have let uk2nl equals 1 EEN 2 2WEE 3 DRIE. You can now look up words by putting the key in square brackets. So you can do echo uk2nl 2 and you get twee. The generic form for defining a dictionary is key value. An empty dictionary is one without any keys. The possibilities with dictionaries are numerous. There are various functions for them as well. For example, you can obtain a list of the keys and loop over them. For key in keys uk2nl, do echo key, and for 3, 1, 2. You will notice the keys are not ordered. You can sort the list to get a specific order. For key and sort keys uk2nl, echo key, and 4, you get 1, 3, 2. But you can never get back the order in which items are defined. For that you need to use a list. It stores items in an ordered sequence. Dictionary function. The items in a dictionary can normally be obtained with an index in square brackets. So echo uk2nl1 will produce een. A method that does the same, but without so many punctuation characters, would be echo uk2nl.1, and that produces een. This only works for a key that is made of ASCII characters, digits, and the underscore. You can also assign a new value this way. Let uk2nl.4 equal vir. Echo uk2nl, and the output is 3 dri, 4 vir, 1 een, 2 twee. And now for something special. You can directly define a function and store a reference to it in the dictionary. Function uk2nl.translate line dict. Return join map split a line get self v colon val 3 question marks and function. Let's first try it out. Echo uk2nl.translate 3251 will produce dri twi question mark in. The first special thing you notice is the dict at the end of the colon function line. This marks the function is being used from a dictionary. The self-local variable will then refer to that dictionary. Now let's break up the complicated return command. Colon split a colon line. The split function takes a string, chops it into whitespace separated words, and returns a list with these words. Thus in the example it returns colon echo split 3251. The output is 3251. This list is the first argument of the map function. This will go through the list, evaluating its second argument with v colon val, set the value of each item. This is a shortcut to using a for loop. This command is colon let a list equal map split a colon line get self v colon val 3 question marks is equivalent to let a list equal split a colon line for idx in range len a list. Let a list idx equal get self a list idx question mark and 4. The get function checks if a key is present in a dictionary. If it is, then the value is retrieved. If it isn't, then the default value is returned. In the example, it's question mark, question mark, question mark. This is a convenient way to handle situations where a key may not be present and you don't want an error message. The join function does the opposite of split. It joins together a list of words, putting a space in between. This combination of split, map, and join is a nice way to filter a line of words in a very compact way. Object-oriented programming. Now that you can put both values and functions in a dictionary, you can actually use a dictionary like an object. Above, we used a dictionary for translating Dutch to English. We might want to do the same for other languages. Let's first make an object, aka dictionary, that has the translate function but no words to translate. Let transdict equals curly braces. Function transdict.translate line dict. Return join map split a colon line get self.words v colon val 3 question marks and function. It's slightly different from the function above, using self.words to look up word translations, but we don't have a self.words, thus you could call this an abstract class. Now we can instantiate a Dutch translation object. Let uk2nl equal copy transdict. Let uk2nl.words equals 1 colon in 2 colon twi 3 colon dri. Echo uk2nl.translate 31 dri in. And the German translator, let uk2de equal copy transdict. Let uk2de.words equal 1 colon 1 2 colon 2 3 colon dry. Echo uk2d.translate 31 dry 1. You can see that the copy function is used to make a copy of the transdict dictionary, and then the copy is changed to add the words. The original remains the same, of course. Now you can go one step further and use your preferred translator. If $lang equals tilde de, let trans equal uk2de, else let trans equal uk2nl, and if echo trans.translate 123 in twi dri. Here trans refers to one of the two objects, dictionaries. No copy is made. More about list and dictionary identity can be found at list-identity and dict-identity. Now you might use a language that isn't supported. You can overrule the translate function to do nothing. Let uk2uk equal copy transdict. Function bang uk2uk.translate line, return a colon line, and function. Echo uk2uk.translate 3-1 Vladivostok outputs 3-1 Vladivostok. Notice that a bang was used to override the existing function reference. Now use uk2uk when no recognized language is found. If $lang equal tilde d, let trans equal uk2d. Else if $lang equals tilde nl, let trans equal uk2nl. Else let trans equal uk2uk. And if echo trans.translate 123.123. For further reading, see lists and dictionaries. Chapter 41, Part 9. Exceptions. Let's start with an example. Try read tilde templates pascal.tmpl. Catch E484, echo sorry, the Pascal template file cannot be found, and try. The :read command will fail if the file does not exist. Instead of generating an error message, this code catches the error and gives the user a nice message. For the commands in between :try and :ntry, errors are turned into exceptions. An exception is a string. In the case of an error, the string contains the error message, and every error message has a number. In this case, the error we catch contains E484. This number is guaranteed to stay the same. The text may change. Example, it may be translated. When the :read command causes another error, the pattern E484 will not match in it. Thus, this exception will not be caught and result in the usual error message, and execution is aborted. You might be tempted to do this. Try read templates pascal.tmpl, catch echo sorry, the Pascal template file cannot be found, and try. This means all errors are caught, but then you will not see errors that are useful, such as E21 cannot make changes, modifiable is off. Another useful mechanism is the :finally command. This filters the lines from the cursor until the end of the file during the filter command, which takes a file name argument. No matter if the filtering works, something goes wrong in between :try and :finally, or the user cancels the filtering by pressing Ctrl+C, the delete tmp is always executed. This makes sure you don't leave the temporary file behind. More information about exception handling can be found in the reference manual Exception-Handling. Chapter 41, Part 10. Various remarks. Here is a summary of items that apply to Vim script. They are also mentioned elsewhere, but form a nice checklist. The end-of-line character depends on the system. For Vim script, it is recommended to always use the Unix file format. Lines are then separated with the new line character. This also works on any other system. That way, you can copy your Vim scripts from Microsoft Windows to Unix and they still work. See source_crnl. To be sure it is set right, do this before writing the file. :set local file format equals Unix. When using DOS file format, lines are separated with !return new line 2 characters. The !return character causes various problems. Better avoid this. White space. Blank lines are allowed in a script and ignored. Leading white space characters, blanks, and tabs are ignored except when using :let-here doc without trim. Trailing white space is often ignored, but not always. One command that includes it is map. You have to watch out for that. It can cause hard to understand mistakes. A generic solution is to never use trailing white space unless you really need it. To include a white space character in the value of an option, it must be escaped by a backslash, as in the following example. :set tags equals my_nice_file. The same example written as :set tags equals my nice file will issue an error because it is interpreted as :set tags equals my set nice set file. Comments. The character double quote starts a comment. Everything after and including this character until the end of the line is considered a comment and is ignored, except for commands that don't consider comments, as shown in examples below. A comment can start on any character position on the line. Here is a little catch with commands for some commands. Examples: abrev dev development, double quote shorthand, map f3 o#include, insert include, execute cmd, double quote do it, bang ls *.c, double quote list c files. The abbreviation dev will be expanded to development space double quote space shorthand. The mapping of f3 will actually be the whole line after the o#, including the double quote insert include. The execute command will give an error. The bang command will send everything after it to the shell, causing an error for an unmatched double quote character. There can be no comment after :map, :abbreviate, :execute, and bang commands. There are a few more commands with this restriction. For the :map, :abbreviate, and :execute commands, there is a trick. With the pipe character, the command is separated from the next one, and that next command is only a comment. For the last command, you need to do two things: :execute and use pipe. Notice that there is no white space before the pipe in the abbreviation and mapping. For these commands, any character until the end of the line or pipe is included. As a consequence of this behavior, you don't always see that trailing white space is included. :map f4 o#include. To spot these problems, you can set the list option when editing vimrc files. For Unix, there is one special way to comment a line that allows making a Vim script executable. #bang/user/bin/env vim-S echo, this is a Vim script, quit. The # command by itself lists a line with the line number. Adding an exclamation mark changes it into doing nothing, so that you can add the shell command to execute the rest of the file: :bang and -s. Pitfalls. Even bigger problem arises in the following example: :map, :ab o#include, :unmap, :ab. Here the unmap command will not work because it tries to unmap :ab. This does not exist as a mapped sequence. An error will be issued, which is very hard to identify because the ending whitespace character in :unmap, :ab is not visible. And this is the same as what happens when one uses a command after an unmap command: :unmap, :ab, a bunch of whitespace, double quote, comment. Here the comment part will be ignored. However, Vim will try to unmap :ab, bunch of whitespace, which does not exist. Rewrite it as :unmap, :ab pipe, bunch of whitespace, double quote, comment. Restoring the view. Sometimes you want to make a change and go back to where the cursor was. Restoring the relative position would also be nice, so that the same line appears at the top of the window. This example yanks the current line, puts it above the first line in the file, and then restores the view. Map, :p, ma double quote, a capital Y capital H, mbgg double quote, a capital P backtick bzt backtick a. What this does: ma sets mark A at current position, double quote A capital Y, yank current line into register A, capital H, MB, go to top line in window and set mark B there, GG, go to first line in file, double quote A capital P, put the yanked line above it, B, go back to top line in display, ZT, position the text in the window as before, A, go back to saved cursor position. Packaging. To avoid your function names to interfere with functions that you get from others, use this scheme. Prepend a unique string before each function name. I often use an abbreviation. For example, O W underscore is used for the option window functions. Put the definition of your functions together in a file. Set a global variable to indicate that the functions have been loaded. When sourcing the file again, first unload the functions. Example: this is the xxx package. If exists xxx underscore loaded, del fun xxx underscore 1, del fun xxx underscore 2, and if function xxx underscore 1a, body of function, and fun function xxx underscore 2b, body of function, and fun. Let xxx underscore loaded equal 1. Chapter 41, Part 11, Writing a Plugin. You can write a Vim script in such a way that many people can use it. This is called a plugin. Vim users can drop your script in their plugin directory and use its features right away. Add -plugin. There are actually two types of plugins: global plugins for all types of files, and file type plugins only for files of a specific type. In this section, the first type is explained. Most items are also relevant for writing file type plugins. The specifics for file type plugins are in the next section, write-file type-plugin. Name. First of all, you must choose a name for your plugin. The features provided by the plugin should be clear from its name, and it should be unlikely that someone else writes a plugin with the same name but which does something different. And please limit the name to 8 characters to avoid problems on old Microsoft Windows systems. A script that corrects typing mistakes could be called typecore.vim. We will use it here as an example. For the plugin to work for everybody, it should follow a few guidelines. This will be explained step by step. The complete example plugin is at the end. Body. Let's start with the body of the plugin, the lines that do the actual work. I abbrev th the, I abbrev otehr to other, I abbrev wnat to want, I abbrev synchronization with an S to synchronization with a Z. Let s:count equal 4. The actual list should be much longer, of course. The line numbers have only been added to explain a few things. Don't put them in your plugin file. Header. You will probably add new corrections to the plugin and soon have several versions lying around. And when distributing this file, people will want to know who wrote this wonderful plugin and where they can send remarks. Therefore, put a header at the top of your plugin. Vim Global Plugin for correcting typing mistakes. Last change 2000 October 15th. Maintainer Bram Molinar, bram@vim.org. About copyright and licensing. Since plugins are very useful and it's hardly worth restricting their distribution, please consider making your plugin either public domain or use the Vim license. A short note about this near the top of the plugin should be sufficient. Example. License. This file is placed in the public domain. Line continuation, avoiding side effects. In line 18 above, the line continuation mechanism is used line-continuation. Users with compatible set will run into trouble here. They will get an error message. We can't just reset compatible because that has a lot of side effects. To avoid this, we will set the CP options option to its Vim default value and restore it later. That will allow the use of line continuation and make the script work for most people. It is done like this. Let s:save_cpo equal &cpo, set cpo &vim, let &cpo equal s:_save_cpo, unlet s::save_cpo. We first store the old value of CP options in the s::save_cpo variable. At the end of the plugin, this value is restored. Notice that a script-local variable is used s::var. A global variable could already be in use for something else. Always use script-local variables for things that are only used in the script. Not loading. It's possible that a user doesn't always want to load the plugin, or the system administrator has dropped it in the system-wide plugin directory, but the user has their own plugin they want to use. Then the user must have a chance to disable loading this specific plugin. This will make it possible. If exists g::loaded_typecore, finish, and if let g::loaded_typecore equal 1. This also avoids that when the script is loaded twice, it would cause error messages for redefining functions and cause trouble for auto commands that are added twice. The name is recommended to start with loaded_, and then the file name of the plugin literally. The g:: is prepended just to avoid mistakes when using the variable in a function. Without g:, it would be a variable local to the function. Using finish stops Vim from reading the rest of the file. It's much quicker than using if and if around the whole file. Mapping. Now let's make the plugin more interesting. We will add a mapping that adds a correction for the word under the cursor. We could just pick a key sequence for this mapping, but the user might already use it for something else. To allow the user to define which key a mapping in a plugin uses, the leader item can be used. Map unique leader A plug typecore add. The plug typecore add thing will do the work. More about that further on. The user can set the map leader variable to the key sequence that they want this mapping to start with. Thus, if the user has done let map leader equal double quote underscore double quote, the mapping will define underscore a. If the user didn't do this, the default value will be used, which is a backslash. Then a map for \a will be defined. Note that unique is used. This will cause an error message if the mapping already happened to exist. :map-unique. But what if the user wants to define their own key sequence? We can allow that with this mechanism. If bang has map2 plug typecore add map unique leader a plug typecore add and def. This checks if a mapping to plug typecore add already exists, and only defines the mapping from leader a if it doesn't. The user then has a chance of putting this in their vimrc file, map,c plug typecore add. Then the mapped key sequence will be "C" instead of _a or \a. Pieces. If a script gets longer, you often want to break up the work in pieces. You can use functions or mappings for this, but you don't want these functions and mappings to interfere with the ones from the other scripts. For example, you could define a function add, but another script could try to define the same function. To avoid this, we define the function local to the script by prepending it with s:. We will define a function that adds a new type in correction. Function s::add from correct. Let 2 equal input type the correction for concatenate a: from concatenate : space exe: iabrev concatenate a: from concatenate space concatenate to and function. Now we can call the function s::add from within the script. If another script also defines s::add, it will be local to that script and can only be called from the script it was defined in. There can also be a global add function without the s:, which is again another function. SID can be used with mappings. It generates a script ID which identifies the current script. In our typing correction plugin, we use it like this. No remap unique script plug typecore add SID add. No remap SID add call SID add expand cword 1 return. Thus, when a user types \a, this sequence is invoked. \a plug typecore add SID add call SID add. If another script also maps SID add, it will get another script ID and thus define another mapping. Note that instead of s::add, we use SID add here. That is because the mapping is typed by the user, thus outside of the script. The SID is translated to the script ID, so that Vim knows in which script to look for the add function. This is a bit complicated because it's required for the plugin to work together with other plugins. The basic rule is that you use SID add in mappings and s::add in other places, like the script itself, auto commands, or user commands. We can also add a menu entry to do the same as the mapping. No remenu script plugin.add \correction SID add. The plugin menu is recommended for adding menu items for plugins. In this case, only one item is used. When adding more items, creating a submenu is recommended. For example, plugin.cvs could be used for a plugin that offers CVS operations, plugin.cvs.checkin, plugin.cvs.checkout, etc. Note that in line 28, :no remap is used to avoid that any other mappings cause trouble. Someone may have remapped : for example. In line 24, we also use : no remap, but we do want SID add to be remapped. This is why script is used here. This only allows mappings which are local to the script. :map-script, the same is done in line 26 for : no remenu, :menu-script. SID and plug. Both SID and plug are used to avoid that mappings of typed keys interfere with mappings that are only to be used from other mappings. Note the difference between using SID and plug. Plug is visible outside of the script. It is used for mappings which the other user might want to map a key sequence to. Plug is a special code that a typed key will never produce. To make it very unlikely that other plugins use the same sequence of characters, use this structure: plug script name map name. In our example, the script name is typecore and the map name is add. We add a semicolon as the terminator. This results in plug typecore add. only the first character of script name and map name is uppercase, so that we can see where map name starts. SID is the script ID, a unique identifier for a script. Internally, Vim translates SID to SNR123_, where 123 can be any number. Thus, a function SID add will have a name SNR11_add in one script and SNR22_add in another. You can see this if you use the :function command to get a list of functions. The translation of SID in mappings is exactly the same. That's how you can call a script-local function from a mapping. User command. Now let's add a user command to add a correction. If bang exists, :correct, command -n_args equals 1, correct, :call, s:_add, q-args 0, and if. The user command is defined only if no command with the same name already exists. Otherwise, we would get an error here. Overriding the existing user command with :command bang is not a good idea. This would probably make the user wonder why the command they define themselves doesn't work, :command. Script variables. When a variable starts with s:, it is a script variable. It can only be used inside a script. Outside the script, it's not visible. This avoids trouble with keeping the same variable name in different scripts. The variables will be kept as long as Vim is running, and the same variables are used when sourcing the same script again, s:var. The fun is that these variables can also be used in functions, auto commands, and user commands that are defined in the script. In our example, we can add a few lines to count the number of corrections. Let s:count equal 4, function s::add from correct, let s::count equal s::count plus 1, echo s::count, concatenate, corrections now, and function. First, s::count is initialized to 4 in the script itself. When later the s::add function is called, it increments s::count. It doesn't matter from where the function was called, since it has been defined in the script, it will use the local variables from this script. The result. Here is the resulting complete example. And this is the script. Line 33 wasn't explained yet. It applies the new correction to the word under the cursor. The :normal command is used to use the new abbreviation. Note that mappings and abbreviations are expanded here, even though the function was called from a mapping defined with :no remap. Using Unix for the file format option is recommended. The Vim scripts will then work everywhere. Scripts with file format set to DOS do not work on Unix. Also see :source_crnl. To be sure it is set right, do this before writing the file. :set file format equals Unix. Documentation. It's a good idea to also write some documentation for your plugin, especially when its behavior can be changed by the user. See add-local-help for how they are installed. Here is a simple example for a plugin help file called typecore.txt. Typecore.txt, plugin for correcting typing mistakes. If you make typing mistakes, this plugin will have them corrected automatically. There are currently only a few corrections. Add your own if you like. Mappings, leader A or plug typecore add. Add a correction for the word under the cursor. Commands, correct word. Add a correction for word. This plugin doesn't have any settings. The first line is actually the only one for which the format matters. It will be extracted from the help file to be put in the local additions : section of the help.txt local-additions. The first asterisk must be in the first column of the first line. After adding your help file, do :help and check that the entries line up nicely. You can add more tags inside *** in your help file, but be careful not to use existing help tags. You would probably use the name of your plugin in most of them, like typecore-settings in the example. Using references to other parts of the help in pipe is recommended. This makes it easy for the user to find associated help. File type detection. If your file type is not already detected by Vim, you should create a file type detection snippet in a separate file. It is usually in the form of an auto command that sets the file type when the file name matches a pattern. Example: au buff new file, buff read *.foo. Write the single-line file as ftdetect foo.vim in the first directory that appears in runtime path. For Unix, that would be .config nvim ftdetect foo.vim. The convention is to use the name of the file type for the script name. You can make more complicated checks if you like, for example to inspect the contents of the file to recognize the language. Also see new-file type. Summary. Summary of special things to use in a plugin. s:\name, variables local to the script, sid, script id, used for mappings and functions local to the script, hasmap2, function to test if the user already defined a mapping for functionality the script offers, leader, value of map leader, which the user defines as the keys that plugin mappings start with, :map unique, give a warning if a mapping already exists, :no remap script, use only mappings local to the script, not global mappings, exists :cmd, check if a user command already exists. Chapter 41, Part 12. Writing a file type plugin. A file type plugin is like a global plugin, except that it sets options and defines mappings for the current buffer only. See add-filetype-plugin for how this type of plugin is used. First, read the section of global plugins above Chapter 41, Part 11. All that is said there also applies to file type plugins. There are a few extras which are explained here. The essential thing is that a file type plugin should only have an effect on the current buffer. Disabling. If you are writing a file type plugin to be used by many people, they need a chance to disable loading it. Put this at the top of the plugin. Only do this when not done yet for this buffer. If exists b:"did_ft plugin finish endif, let b:"did_ft plugin equal 1. This also needs to be used to avoid that the same plugin is executed twice for the same buffer. Happens when using a :edit command without arguments. New users can disable loading the default plugin completely by making a file type plugin with only this line. Let b:"did_ft plugin equal 1. This does require that the file type plugin directory comes before $vim runtime in runtime path. If you do want to use the default plugin, but overrule one of these settings, you can write the different settings in a script. Set local text width equals 70. Now write this in the after directory, so that it gets sourced after the distributed vim.vim.ft plugin after -directory. For Unix, this would be .config nvim after ft plugin vim.vim. Note that the default plugin will have set b:"did_ft plugin, but it is ignored here. Options. To make sure the file type plugin only affects the current buffer, use the :set local command to set options, and only set options which are local to a buffer. See the help for the option to check that. When using :set local for global options, or options local to a window, the value will change for many buffers, and that is not what a file type plugin should do. When an option has a value that is a list of flags or items, consider using += and -= to keep the existing value. Be aware that the user may have changed an option value already. First, resetting to the default value and then changing it is often a good idea. Example: :set local format options ampersand. Format options += RO. Mappings. To make sure mappings will only work in the current buffer, use the :map buffer command. This needs to be combined with the two-step mapping explained above. An example of how to define functionality in a file type plugin is if bang has map2 plug java import, map buffer unique local leader I plug java import endif, no remap buffer unique plug java import o import left escape. Hasmap2 is used to check if the user has already defined a map to plug java import. If not, the file type plugin defines the default mapping. This starts with local leader, which allows the user to select the keys they want file type plugin mappings to start with. The default is a \. Unique is used to give an error message if the mapping already exists or overlaps with an existing mapping. No remap is used to avoid that any other mappings that the user has defined interferes. You might want to use :no remap script to allow remapping mappings defined in this script that start with SID. The user must have a chance to disable the mappings in a file type plugin without disabling everything. Here is an example of how this is done for a plugin for the mail file type. Add mappings unless the user didn't want this. If bang exists, no plugin maps, && bang exists, no mail maps. Quote text by inserting. If bang has map to plug mail quote, vmap buffer local leader q plug mail quote, inmap buffer local leader q plug mail quote, ndef. vno remap buffer plug mail quote :s /caret greater than / return, and no remap buffer plugin mail quote :period, $s /caret greater than / return, ndef. Two global variables are used. No plugin maps disables mappings for all file type plugins. No mail maps disables mappings for the mail file type. User commands. To add a user command for a specific file type so that it can only be used in one buffer, use the -buffer argument to :command. Example: :command -buffer make %:r:(s). Variables. A file type plugin will be sourced for each buffer of the type it's for. Local script variables s::var will be shared between all invocations. Use local buffer variables b::var if you want a variable specifically for one buffer. Functions. When defining a function, this only needs to be done once, but the file type plugin will be sourced every time a file with this file type will be opened. This construct makes sure the function is only defined once. If bang exists, *s::func, function s::func arg, ... and function ndef. Undo. When the user does :set file type xyz, the effect of the previous file type should be undone. Set the b::undo_ft plugin variable to the commands that will undo the settings in your file type plugin. Example: let b::undo_ft plugin equal set local fo <com tw comment string / concatenate pipe unlet b::match ignore case b::match words b::match skip . Using :set local with < after the option name resets the option to its global value. That is mostly the best way to reset the option value. This does require removing the C flag from CP options to allow line continuation, as mentioned above. Use CPO save. For undoing the effect of an indent script, the b::undo indent variable should be set accordingly. File name. The file type must be included in the file name ftplugin -name. Use one of these three forms: ftplugin stuff.vim, ftplugin stuff_foo.vim, ftplugin stuff bar.vim. Stuff is the file type, foo and bar are arbitrary names. Summary. Summary of special things to use in a file type plugin. Local leader, value of map local leader, which the user defines as the key that file type plugin mappings start with. :map buffer, define a mapping local to the buffer. :no remap script, only remap mappings defined in this script that start with SID. :set local, set an option for the current buffer only. :command -buffer, define a user command local to the buffer. Exists *s::func, check if a function was already defined. Also see plugin -special, the special thing used for all plugins. Chapter 41, Part 13. Writing a compiler plugin. A compiler plugin sets option for use with a specific compiler. The user can load it with the :compiler command. The main use is to set the error format and make PRG options. Easiest is to have a look at examples. This command will edit all the default compiler plugins. :next $vim runtime /compiler /*vim. Use :next to go to the next plugin file. There are two special items about these files. First is a mechanism to allow a user to overrule or add to the default value. The default files start with if exists current compiler finish and if let current compiler equal mine. When you write a compiler file and put it in your personal runtime directory, example.config nvim compiler for Unix, you set the current compiler variable to make the default file skip these settings. The second mechanism is to use :set for :compiler bang and :set local for :compiler. Vim defines the compiler set user command for this. This is an example. Compiler set error format ampersand, use the default error format, compiler set make prg equal nmake. When you write a compiler plugin for the Vim distribution or for a system-wide runtime directory, use the mechanism mentioned above. When current_compiler was already set by a user plugin, nothing will be done. When you write a compiler plugin to overrule settings from a default plugin, don't check the current_compiler. This plugin is supposed to be loaded last, thus it should be in a directory at the end of runtime path. For Unix, that could be .config/nvim/after/compiler. Chapter 41, Part 14. Writing a plugin that loads quickly. A plugin may grow and become quite long. The startup delay may become noticeable while you hardly ever use the plugin. Then it's time for a quick load plugin. The basic idea is that the plugin is loaded twice. The first time user commands and mappings are defined that offer the functionality. The second time the functions that implement the functionality are defined. It may sound surprising that quick load means loading a script twice. What we mean is that it loads quickly the first time, postponing the bulk of the script to the second time, which only happens when you actually use it. When you always use the functionality, it actually gets slower. Note that since Vim 7, there is an alternative. Use the auto load functionality, Chapter 41, Part 15. The following example shows how it's done. When the script is first loaded, s::did_load is not set. The commands between the if and endif will be executed. This ends in a :finish command, thus the rest of the script is not executed. The second time the script is loaded, s::did_load exists and the commands after the endif are executed. This defines the possible long buffnet read and buffnet write functions. If you drop this script in your plugin directory, Vim will execute it on startup. This is the sequence of events that happens. 1. The bnread command is defined and the F19 key is mapped when the script is sourced at startup. A func_undefined auto command is defined. The :finish command causes the script to terminate early. The user types the bnread command or presses the F19 key. The buffnet read or buffnet write function will be called. Vim can't find the function and triggers the func_undefined auto command event. Since the pattern buffnet * matches the invoked functionality, the command source fname will be executed. Fname will be equal to the name of the script no matter where it is located because it comes from expanding s file, see expand. The script is sourced again, the s::did_load variable exists, and the functions are defined. Notice that the functions that are loaded afterwards match the pattern in the func_undefined auto command. You must make sure that no other plugin defines functions that match this pattern. Chapter 41, Part 15. Writing library scripts. Some functionality will be required in several places. When this becomes more than a few lines, you will want to put it in one script and use it from many scripts. We will call that one script a library script. Manually loading a library script is possible, so long as you avoid loading it when it's already done. You can do this with the exists function. Example: if bang exists, *mylib function, runtime library mylibscript.vim, and if call mylib function arg. Here you need to know that mylib function is defined in a script, library mylibscript.vim, in one of the directories in runtime path. To make this a bit simpler, Vim offers the auto-load mechanism. Then the example looks like this. Call mylib #myfunction arg. That's a lot simpler, isn't it? Vim will recognize the function name, and when it's not defined, search for the script autoload mylib.vim in runtime path. That script must define the mylib #myfunction function. You can put many other functions in the mylib.vim script. You are free to organize your functions in library scripts, but you must use function names where the part before the hash matches the script name. Otherwise, Vim would not know what script to load. If you get really enthusiastic and write lots of library scripts, you may want to use subdirectories. Example: call netlib #ftp #read some file. For Unix, the library script used for this could be .config nvim autoload netlib ftp.vim, where the function is defined like this: function netlib #ftp #read fname, read the file fname through ftp, and function. Notice that the name the function is defined with is exactly the same as the name used for calling the function, and the part before the last hash exactly matches the subdirectory and script name. You can use the same mechanism for variables. Let weekdays equal Dutch #weekdays. This will load the script autoload Dutch.vim, which should contain something like let Dutch #weekdays equal Zondag, Maandag, Dinsdag, Woensdag, Donderdag, Vrijdag, Zaterdag. Editor's note: I apologize for the pronunciation. Further reading autoload. Chapter 41, Part 16. Distributing Vim scripts. Vim users will look for scripts on the Vim website vim.org. If you made something that is useful for others, share it. Vim scripts can be used on any system. There might not be a tar or gzip command. If you want to pack files together and or compress them, the zip utility is recommended. Add new menus. By now you know that Vim is very flexible. This includes the menus used in the GUI. You can define your own menu entries to make certain commands easily accessible. This is for mouse-happy users only. Chapter 42, Part 1. Introduction. The menus that Vim uses are defined in the file $vim runtime menu.vim. If you want to write your own menus, you might first want to look through that file. To define a menu item, use the :menu command. The basic form of this command is as follows: :menu, menu item, keys. The menu item describes where on the menu to put the item. A typical menu item is file.save, which represents the item save under the file menu. A dot is used to separate the names. Example: :menu file.save :update carriage return. The :update command writes the file when it's modified. You can add another level. edit.settings.shift-width defines a submenu settings under the edit menu with an item shift-width. You could use even deeper levels. Don't use this too much. You need to move the mouse quite a bit to use such an item. The :menu command is very similar to the :map command. The left side specifies how the item is triggered, and the right-hand side defines the characters that are executed. Keys are characters. They are used just like you would have typed them. Thus, in insert mode, when keys is plain text, that text is inserted. Accelerators. The ampersand character is used to indicate an accelerator. For instance, you can use Alt-F to select File and S to select Save. The Win Alt keys option may disable this though. Therefore, the menu item looks like &file.save. The accelerator changes will be underlined in the menu. You must take care that each key is used only once in each menu. Otherwise, you will not know which of the two will actually be used. Vim doesn't warn you for this. Priorities. The actual definition of the file.save menu item is as follows: :menu 10.340 &file.save tab :w confirm w carriage return. The number 10.340 is called the priority number. It is used by the editor to decide where it places the menu item. The first number, 10, indicates the position on the menu bar. Lower numbered menus are positioned to the left, higher numbers to the right. These are the priorities used for the standard menus. So it's 10 for file, 20 for edit, 40 for tools, 50 for syntax, 60 for buffers, 70 for window, and 9999 for help. Notice that the help menu is given a very high number to make it appear on the far right. The second number, 340, determines the location of the item within the pull-down menu. Lower numbers go on top, higher numbers on the bottom. These are the priorities in the file menu. And here they are right here. Notice that there is room in between the numbers. This is where you can insert your own items if you really want to. It's often better to leave the standard menus alone and add a new menu for your own items. When you create a submenu, you can add another .number to the priority. Thus, each name in menu item has its own priority. Special characters. The menu item in this example is &file.save tab:\w. This brings up an important point. Menu item must be one word. If you want to put a dot, space, or tabs in the name, you either use the angle bracket notation, space and tab for instance, or use the / escape. :menu 10.305 &file.do \space it \period :exit carriage return. In this example, the name of the menu item, do it, contains a space, and the command is exit carriage return. The tab character in a menu name is used to separate the part that defines the menu name from the part that gives a hint to the user. The part after the tab is displayed right aligned in the menu. In the file.save menu, the name used is &file.save tab:\w. Thus the menu name is file.save and the hint is :w. Separators. The separator lines, used to group related menu items together, can be defined by using a name that starts and ends in a dash. For example, -sep-. When using several separators, the names must be different. Otherwise, the names don't matter. The command from a separator will never be executed, but you have to define one anyway. A single colon will do. Example, :a menu 20.510 edit period -sep3 Chapter 42 Part 2 Menu Commands. You can define menu items that exist for only certain modes. This works just like the variations on the :map command. :menu, normal, visual, and operator pending mode. :n menu, normal mode. :v menu, visual mode. :o menu, operator pending mode. :menu bang, insert and command line mode. :I menu, insert mode. :c menu, command line mode. :tl menu, terminal mode. :a menu, all modes except for terminal mode. To avoid that the commands of a menu item are being mapped, use the command no-remenu, :n no-remenu, and :a no-remenu, etc. Using :a menu. The :a menu command is a bit different. It assumes that the keys you give are to be executed in normal mode. When Vim is in visual or insert mode when the menu is used, Vim first has to go back to normal mode. :a menu inserts a Control-C or Control-O for you. For example, if you use this command, :a menu 90.100 mine.find \word asterisk, then the resulting menu commands will be normal mode asterisk, visual mode Control-C asterisk, operator pending mode Control-C asterisk, insert mode Control-O asterisk, command line mode Control-C asterisk. When in command line mode, the Control-C will abandon the command typed so far. In visual mode and operator pending mode, Control-C will stop the mode. The Control-O in insert mode will execute the command and then return to insert mode. Control-O only works for one command. If you need to use two or more commands, put them in a function and call that function. Example, :a menu mine.next \file call sid next file carriage return. Function sid next file next 1 / code end function. This menu entry goes to the next file in the argument list with :next. Then it searches for the line that starts with code. The SID before the function name is the script ID. This makes the function local to the current Vim script file. This avoids problems when a function with the same name is defined in another script file. See SID. silent menus. The menu executes the keys as if you typed them. For a colon command, this means you will see the command being echoed on the command line. If it's a long command, the hit enter prompt will appear. That can be very annoying. To avoid this, make the menu silent. This is done with the silent argument. For example, take the call to next file in the previous example. When you use this menu, you will see this on the command line, call snr34 next file. To avoid this text on the command line, insert silent as the first argument. A menu silent mine.next \file call sid next file carriage return. Don't use silent too often. It is not needed for short commands. If you make a menu for someone else, being able to see the executed command will give them a hint about what they could have typed instead of using the mouse. Listing menus. When a menu command is used without a keys part, it lists the already defined menus. You can specify a menu item or part of it to list specific menus. Example, a menu. This lists all menus. That's a long list. Better specify the name of a menu to get a shorter list. A menu edit. This lists only the edit menu items for all modes. To list only one specific menu item for insert mode, do imenu edit.undo. Take care that you type exactly the right name. Case matters here. But the ampersand for accelerators can be omitted. The tab and what comes after it can be left out as well. Deleting menus. To delete a menu, the same command is used as for listing, but with menu changed to unmenu. Thus menu becomes unmenu, nmenu becomes nonemenu, etc. To delete the tools.make item for insert mode, do unmenu tools.make. You can delete a whole menu with all its items by using the menu name. Example, a unmenu syntax. This deletes the syntax menu and all the items in it. Chapter 42, Part 3, Various. You can change the appearance of the menus with flags in GUI options. In the default value, they are all included except capital M. You can remove a flag with a command like set GUI options -=m. M. When removed, the menu bar is not displayed. Capital M. When added, the default menus are not loaded. G. When removed, the inactive menu items are not made gray but are completely removed. Does not work on all systems. For translating menu items, see menu trans. Since the mouse has to be used to select a menu item, it is a good idea to use the browse command for selecting a file, and confirm to get a dialog instead of an error message. Example, when the current buffer contains changes, these two can be combined. A menu file.open browse confirm edit carriage return. The browse makes a file browser appear to select the file to edit. The confirm will pop up a dialog when the current buffer has changes. You can then select to save the changes, throw them away, or cancel the command. For more complicated items, the confirm and input dialog functions can be used. The default menus contain a few examples. Chapter 42, Part 4, Toolbar and Pop-up Menus. There are two special menus, Toolbar and Pop-up. Items that start with these names do not appear in the normal menu bar. Toolbar. The toolbar appears only when the T flag is included in the GUI options option. The toolbar uses icons rather than text to represent the command. For example, the menu item named toolbar.new causes the new icon to appear on the toolbar. The Vim editor has 28 built-in icons. You can find a table here, built-in -tools. Most of them are used in the default toolbar. You can redefine what these menus do after the default menus are set up. You can add another bitmap for a toolbar item, or define a new toolbar item with a bitmap. For example, define a new toolbar item with $t-menu toolbar.compile. Compile the current file. $a menu toolbar.compile, bang cc %, $S-o, $r, $S, carriage return. Now you need to create the icon. For Microsoft Windows, it must be in bitmap format, with the name compile.bmp. For Unix, XPM format is used. The file name is compile.xpm. The size must be 18 by 18 pixels. On Microsoft Windows, other sizes can be used as well, but it will look ugly. Put the bitmap in the directory bitmaps in one of the directories from runtime path. Example for Unix, .config nvim bitmaps compile.xpm. You can define tooltips for the items in the toolbar. A tooltip is a short text that explains what a toolbar item will do. For example, open file. It appears when the mouse pointer is on the item without moving for a moment. This is very useful if the meaning of the picture isn't that obvious. Example, :t menu toolbar.make run make in the current directory. Note: pay attention to the case used. Toolbar and toolbar are different from toolbar. To remove a tooltip, use the :tun menu command. The toolbar option can be used to display text instead of a bitmap, or both text and a bitmap. Most people use just the bitmap since the text takes quite a bit of space. Pop-up menu. The pop-up menu pops up where the mouse pointer is. On Microsoft Windows, you activate it by clicking the right mouse button. Then you can select an item with the left mouse button. On Unix, the pop-up menu is used by pressing and holding the right mouse button. The pop-up menu only appears when the mouse model has been set to pop-up, or pop-up_set pose. The difference between the two is that pop-up_set pos moves the cursor to the mouse pointer position. When clicking inside a selection, the selection will be used unmodified. When there is a selection but you click outside of it, the selection is removed. There is a separate pop-up menu for each mode, thus there are never gray items like in the normal menus. What is the meaning of life, the universe, and everything? 42. Douglas Adams, the only person who knew what this question really was about, is now dead, unfortunately. So now you might wonder what the meaning of death is. Using file types. When you are editing a file of a certain type, for example a C program or a shell script, you often use the same option settings and mappings. You quickly get tired of manually setting these each time. This chapter explains how to do it automatically. Chapter 43 Part 1 Plugins for a file type. How to start using file type plugins has already been discussed here. Add -file type -plugin. But you probably are not satisfied with the default settings because they have been kept minimal. Suppose that the C files you want to set the soft tab spot option to 4 and define a mapping to insert a 3-line comment. You do this with only 2 steps. 1. Create your own runtime directory. On Unix, this usually is .config nvim. In this directory, create the ft plugin directory. Make dir-p ~.config/nvim/ft plugin. When you are not on Unix, check the value of runtime path option to see where Vim will look for the ft plugin directory. Set runtime path equals. You would normally use the first directory name before the first comma. You might want to prepend a directory name to the runtime path option in your init.vim file if you don't like the default value. 2. Create the file ~.config/nvim/ft plugin /c.vim with the contents set local soft tab stop equals 4, no remap buffer local leader co / a bunch of asterisks, 2 carriage returns / escape. Let b:\undo ft plugin equal set l soft tab spot less than pipe unmap buffer local leader c. Try editing a C file. You should notice that the soft tab stop option is set to 4. But when you edit another file, it's reset to the default 0. That is because the :set local command was used. This sets the soft tab stop option only locally to the buffer. As soon as you edit another buffer, it will be set to the value set for that buffer. For a new buffer, it will get the default value or the value from the last :set command. Likewise, the mapping for \c will disappear when editing another buffer. The :map buffer command creates a mapping that is local to the current buffer. This works with any mapping command, :map bang, :vmap, etc. The local leader in the mapping is replaced with the value of the map local leader variable. The line to set b::undo ft plugin is for when the file type is set to another value. In that case, you will want to undo your preferences. The b::undo _ft plugin variable is executed as a command. Watch out for characters with a special meaning inside a string, such as a backslash. You can find examples for file type plugins in this directory. $Vim runtime ft plugin. More details about writing a file name plugin can be found here. Write-plugin. Chapter 43 Part 2. Adding a file type. If you are using a type of file that is not recognized by Vim, this is how to get it recognized. You need a runtime directory of your own. See your-runtime-dir above. Create a file, filetype.vim, which contains an auto command for your file type. Auto commands were explained in section 40, part 3. Example: au group file type detect, au buff new file, buff read *xyz set fxyz, au group end. This will recognize all files that end in .xyz as the xyz file type. The :au group commands put this auto command in the file type detect group. This allows removing all auto commands for file type detection when doing :file type off. The setf command will set the file type option to its argument, unless it was set already. This will make sure that file type isn't set twice. You can use many different patterns to match the name of your file. Directory names can also be included. See autocommand-pattern. For example, the files under user share scripts are all Ruby files, but don't have the expected file name extension. Adding this to the example above. au group file type detected, au buff new file, buff read *xyz set fxyz, au buff new file, buff read usr share scripts set f ruby, au group end. However, if you now edit a file, usr share scripts readme.txt, this is not a Ruby file. The danger of a pattern ending in asterisk is that it quickly matches too many files. To avoid trouble with this, put the filetype.vim file in another directory, one that is at the end of runtime path. For Unix, for example, you could use .config nvim after filetype.vim. You now put the detection of text files in .config nvim filetype.vim. au group file type detect, au buff new file, buff read *txt, set ftext, au group end. That file is found in runtime path first. Then use this in .config nvim after filetype.vim, which is found last. au group file type detected, au buff new file, buff read usr share scripts * set f ruby, au group end. What will happen now is that Vim searches for filetype.vim files in each directory in runtime path. First, .config nvim filetype.vim is found. The auto command to catch .txt files is defined there. Then Vim finds the filetype.vim file in $vim runtime, which is halfway runtime path. Finally, .config nvim after filetype.vim is found, and the auto command for detecting Ruby files in usr share scripts is added. When you now edit usr share scripts readme.txt, the auto commands are checked in the order in which they were defined. The .txt pattern matches, thus setftext is executed to set the file type to text. The pattern for Ruby matches too, and the setfruby is executed. But since file type was already set to text, nothing happens here. When you edit the file usr share scripts foobar, the same auto commands are checked. Only the one for Ruby matches, and setfruby sets file type to Ruby. Recognizing by contents. If your file cannot be recognized by its file name, you might be able to recognize it by its contents. For example, many script files start with a line like #bang bin xyz. To recognize this script, create a file scripts.vim in your runtime directory, same place where filetype.vim goes. It might look like this. If did _file type finish, and if get line 1 equals, tilde, single quote, caret, hash, bang, period, asterisk, open square bracket, // backslash, close square bracket, xyz backslash greater than single quote, set f xyz, end if. The first check with did underscore file type is to avoid that you will check the contents of files for which the file type was already detected by the file name. That avoids wasting time on checking the file when the setf command won't do anything. The scripts.vim file is sourced by an auto command in the default filetype.vim file. Therefore, the order of checks is 1. filetype.vim, files before $vim runtime in runtime path. 2. First part of $vim runtime / filetype.vim. 3. All scripts.vim files in runtime path. 4. Remainder of $vim runtime / filetype.vim. 5. Filetype.vim files after $vim runtime in runtime path. If this is not sufficient for you, add an auto command that matches all files and sources a script or executes a function to check the contents of the file. Your own syntax highlighted. Vim comes with highlighting for a couple of hundred different file types. If the file you are editing isn't included, read this chapter to find out how to get this type of file highlighted. Also see :syn-define in the reference manual. Chapter 44, Part 1, Basic Syntax Commands. Using an existing syntax file to start with will save you a lot of time. Try finding a syntax file in $vim runtime syntax for a language that is similar. These files will also show you the normal layout of a syntax file. To understand it, you need to read the following. Let's start with the basic arguments. Before we start defining any new syntax, we need to clear out any old definitions. Syntax clear. This isn't required in the final syntax file, but very useful when experimenting. There are more simplifications in this chapter. If you are writing a syntax file to be used by others, read all the way through the end to find out the details. Listing defined items. To check which syntax items are currently defined, use this command, :syntax. You can use this to check which items have actually been defined. Quite useful when you are experimenting with a new syntax file. It also shows the colors used for each item, which helps to find out what is what. To list the items in a specific syntax group, use :syntax list group name. This also can be used to list clusters, explained in Chapter 44, Part 8. Just include the @ in the name. Matching case. Some languages are not case sensitive, such as Pascal. Others, such as C, are case sensitive. You need to tell which type you have with the following commands: :syntax case match, :syntax case ignore. The match argument means that Vim will match the case of syntax elements. Therefore, lowercase int differs from capitalized int and uppercase int. If the ignore argument is used, the following are equivalent: capitalized procedure, uppercase procedure, and lowercase procedure. The :syntax case commands can appear anywhere in a syntax file and affect the syntax definitions that follow. In most cases, you have only one :syntax case command in your syntax file. If you work with an unusual language that contains both case-sensitive and non-case-sensitive elements, however, you can scatter the :syntax case command throughout the file. Chapter 44, Part 2, Keywords. The most basic syntax elements are keywords. To define a keyword, use the following form: :syntax keyword, group keyword, etc. The group is the name of a syntax group. With the highlight command, you can assign colors to a group. The keyword argument is an actual keyword. Here are a few examples: :syntax keyword x-type int long car, :syntax keyword x statement if then else and if. This example uses the group names x-type and x-statement. By convention, each group name is prefixed by the file type for the language being defined. This example defines syntax for the X language, example language without an interesting name. In a syntax file for CSH scripts, the name CSH type would be used. Thus, the prefix is equal to the value of file type. These commands cause the words int, long in car, to be highlighted one way and the words if, then, else, and if to be highlighted another way. Now you need to connect the X group names to standard Vim names. You do this with the following commands: :highlight link X type type, :highlight link X statement statement. This tells Vim to highlight X type like type and X statement like statement. See group-name for the standard names. Unusual keywords. The characters used in a keyword must be in the is keyword option. If you use another character, the word will never match. Vim doesn't give a warning message for this. The X language uses the dash character in keywords. This is how it's done: :set local is keyword plus equals dash, :syntax keyword X statement when dash not. The :set local command is used to change is keyword only for the current buffer. Still, it does change the behavior of commands like W and asterisk. If that is not wanted, don't define a keyword but use a match, explained in the next section. The X language allows for abbreviations. For example, next can be abbreviated to N, NE, or nex. You can define them by using this command: :syntax keyword X statement N ext. This doesn't match next one. Keywords always match whole words only. Chapter 44, Part 3. Matches. Consider defining something a bit more complex. You want to match ordinary identifiers. To do this, you define a match syntax item. This one matches any word consisting of only lowercase letters. :syntax match X identifier / less than /L /plus greater than /. Note: keywords overrule any other syntax item. Thus the keywords if, then, etc. will be keywords as defined with the :syntax keyword commands above, even though they also match the pattern for X identifier. The part at the end is a pattern, like it's used for searching. The // is used to surround the pattern, like how it's done in a :substitute command. You can use any other character like a plus or a quote. Now define a match for a comment. In the X language, it is anything from hash to the end of a line. :syntax match X comment / period asterisk /. Since you can use any search pattern, you can highlight very complex things with a match item. See pattern for help on search patterns. Chapter 44, Part 4. Regions. In the example X language, strings are enclosed in double quotation marks. To highlight strings, you define a region. You need a region start, double quote, and a region end, double quote. The definition is as follows: :syntax region X string start equals / double quote / end equals / double quote /. The start and end directives define the patterns used to find the start and end of the region. But what about strings that look like this? A string with a double quote / double quote in it. This creates a problem. The double quotation marks in the middle of the string will end the region. You need to tell Vim to skip over any escaped double quotes in the string. Do this with the skip keyword. :syntax region X string start equals / double quote / skip equals / double quote / end equals / double quote /. The double / matches a single / since the / is a special character in search patterns. When to use a region instead of a match? The main difference is that a match item is a single pattern which must match as a whole. A region starts as soon as the start pattern matches. Whether the end pattern is found or not doesn't matter. Thus, when the item depends on the end pattern to match, you cannot use a region. Otherwise, regions are often simpler to define. And it is easier to use nested items, as is explained in the next section. Chapter 44, Part 5. Nested items. Take a look at the comment. %getInput to do, skip white space. You want to highlight to do in big yellow letters, even though it is in a comment that is highlighted blue. To let Vim know about this, you define the following syntax groups. :syntax keyword X to do contained. :syntax match x comment /% period asterisk / contains equals x to do. In the first line, the contained argument tells Vim that this keyword can exist only inside another syntax item. The next line has contains equals x to do. This indicates that the x to do syntax element is inside it. The result is that the comment line as a whole is matched with x comment and made blue. The word to do inside it is matched by x to do and highlighted yellow. Highlighting for x to do was set up for this. Recursive nesting. The X language defines code blocks in curly braces, and a code block may contain other code blocks. This can be defined this way: :syntax region x block start equals / open curly brace / end equals / end curly brace / contains equals x block. Suppose you have this text: while I is less than b, open curly brace, if a, open curly brace, b equals c, close curly brace, close curly brace. First, a x block starts at the open curly brace in the first line. In the second line, another open curly brace is found. Since we are inside a x block item and it contains itself, a nested x block item will start here. Thus the b equals c line is inside the second level x block region. Then a closed curly bracket is found in the next line, which matches with the end pattern of the region. This ends the nested x block. Because the closed curly brace is included in the nested region, it is hidden from the first x block region. Then at the last closed curly brace, the first x block region ends. Keeping the end. Consider the following two syntax items: :syntax region x comment start equals %/ end equals $$ contained, :syntax region x pre-proc start equals /# end equal $$ contains equals x comment. You define a comment as anything from % to the end of the line. A preprocessor directive is anything from hash to the end of the line. Because you can have a comment on a preprocessor line, the preprocessor definition includes a contains equals x comment argument. Now look what happens with this text. Hash define x equals y, %comment text int foo equals 1. What you see is that the second line is also highlighted as x preproc. The preprocessor directive should end at the end of the line. That is why you have used end equals $$. So what is going wrong? The problem is the contained comment. The comment starts with hash and ends at the end of the line. After the comment ends, the preprocessor syntax continues. This is after the end of the line has been seen, so the next line is included as well. To avoid this problem and to avoid a contained syntax item eating a needed end of line, use the keep end argument. This takes care of the double end of line matching. :syntax region x comment start equals %/ end equals $$ contained, :syntax region x preproc start equals /# end equals $$ contains equals x comment keep end. Containing many items. You can use the contains argument to specify that everything can be contained. For example, :syntax region x list start equals / open square bracket / end equals / close square bracket / contains equals capital O. All syntax items will be contained in this one. It also contains itself, but not at the same position. That will cause an endless loop. You can specify that some groups are not contained, thus contain all groups but the ones that are listed. :syntax region x list start equals / open square bracket / end equals / close square bracket / contains equal capital all but, x string. With the top item, you can include all items that don't have a contained argument. Contained is used to only include items with a contained argument. See :syn-contains for the details. Chapter 44, Part 6. Following groups. The X language has statements in this form. If condition, then. You want to highlight the three items differently, but condition and then might also appear in other places where they get different highlighting. This is how you can do this. colon syntax match x if next group equals x if condition skip white, colon syntax match x if condition / open parentheses open square bracket caret close parentheses close square bracket asterisk close parentheses / contained next group equals x then skip white, colon syntax match x then / contained. The next group argument specifies which item can come next. This is not required. If none of the items that are specified are found, nothing happens. For example, in this text, if not condition then, the if is matched by x if. Not doesn't match the specified next group x if condition, thus only the if is highlighted. The skip white argument tells Vim that white space, spaces and tabs may appear in between the items. Similar arguments are skip NL, which allows a line break in between the items, and skip empty, which allows empty lines. Notice that skip NL doesn't skip an empty line, something must match after the line break. Chapter 44, Part 7. Other arguments. Match group. When you define a region, the entire region is highlighted according to the group name specified. To highlight the text enclosed in parentheses with the group x inside, for example, use the following command: colon syntax region x inside start equals / open parentheses / and equals / close parentheses /. Suppose that you want to highlight the parentheses differently. You can do this with a lot of convoluted region statements, or you can use the match group argument. This tells Vim to highlight the start and end of a region with a different highlight group, in this case the x parent group. Colon syntax region x inside match group equals x parent start equals / open parentheses / and equals / close parentheses /. The match group argument applies to the start or end match that comes after it. In the previous example, both start and end are highlighted with x parent. To highlight the end with x parent end, do colon syntax region x inside match group equals x parent start equals / open parentheses / match group equals x parent end equals / close parentheses /. The side effect of using match group is that contained items will not match in the start or end of the region. The example for transparent uses this: transparent. In a C language file, you would like to highlight the parentheses text after a while, differently from the parentheses text after a for. In both of these, there can be nested parentheses items, which should be highlighted in the same way. You must make sure the open parentheses highlighting stops at the matching close parentheses. This is one way to do this. Colon syntax region c while match group equals c while start equals / while / s * open parentheses / end equals / close parentheses / contains equals c cond nest. Colon syntax region c for match group equals c4 start equals / for / s * open parentheses / end equals / close parentheses / contains equals c cond nest. Colon syntax region c cond nest start equals / open parentheses / end equals / open parentheses / contained transparent. Now you can give c while and c4 different highlighting. The c cond nest item can appear in either of them, but take over the highlighting of the item it is contained in. The transparent argument causes this. Notice that the match group argument has the same group as the item itself. Why define it then? Well, the side effect of using a match group is that contained items are not found in the match with the start item then. This avoids that the c cond nest group matches the open parentheses just after the while or for. If this would happen, it would span the whole text until the matching close parentheses, and the region would continue after it. Now c cond nest only matches after the match with the start pattern, thus after the first open parentheses. Offsets. Suppose you want to define a region for the text between open parentheses and close parentheses after an if, but you don't want to include the if or the open parentheses and close parentheses. You can do this by specifying offsets for the patterns. Example: colon syntax region x cond start equals / if /s asterisk open parentheses / ms equals e plus 1 and equals / close parentheses / me equals s minus 1. The offset for the start pattern is ms equals e plus 1. MS stands for match start. This defines an offset for the start of the match. Normally the match starts where the pattern matches. E+1 means that the match now starts at the end of the pattern match, and then one character further. The offset for the end pattern is ME equals S-1. ME stands for match end. S-1 means the start of the pattern match and then one character back. The result is that in this text, if open parentheses foo equals bar close parentheses, only the text foo equals bar will be highlighted as xcond. More about offsets here: sin -pattern -offset. One line. The one line argument indicates that the region does not cross a line boundary. For example, syntax region x if then start equals /if end equals /then /one line. This defines a region that starts at if and ends at then. But if there is no then after the if, the region doesn't match. Note: when using one line, the region doesn't start if the end pattern doesn't match in the same line. Without one line, Vim does not check if there is a match for the end pattern. The region starts even when the end pattern doesn't match in the rest of the file. Continuation lines and avoiding them. Things now become a little more complex. Let's define a preprocessor line. This starts with a hash in the first column and continues until the end of the line. A line that ends with / makes the next line a continuation line. The way you handle this is to allow the syntax item to contain a continuation pattern. Syntax region x preproc start equals /caret hash / end equals $$ contains equals x line continue syntax match x line continue $$ contained. In this case, although x preproc normally matches a single line, the group contained in it, namely x line continue, lets it go on for more than one line. For example, it would match both of these lines. Hash define spam, / bacon and spam. In this case, this is what you want. If it is not what you want, you can call for the region to be on a single line by adding exclude NL to the contained pattern. For example, you want to highlight end in x preproc, but only at the end of the line. To avoid the x preproc continue on the next line, like x line continue does, use exclude NL like this. Syntax region x preproc start equals /caret hash / end equals $$ / contains equals x line continue, x preproc end. Syntax match x preproc end exclude NL /end $$ contained. Syntax match x line continue $$ contained. Exclude NL must be placed before the pattern. Since x line continue doesn't have exclude NL, a match with it will extend x preproc to the next line as before. Chapter 44, Part 8, Clusters. One of the things you will notice as you start to write a syntax file is that you wind up generating a lot of syntax groups. Vim enables you to define a collection of syntax groups called a cluster. Suppose you have a language that contains 4 loops, if statements, while loops, and functions. Each of them contains the same syntax elements, numbers and identifiers. You define them like this. Syntax match x4 /caret for period * contains equals x number, x ident. Syntax match x if /caret if period * contains equal x number, x ident. Syntax match x while /caret while period * contains equals x number, x ident. You have to repeat the same contains equals every time. If you want to add another contained item, you have to add it 3 times. Syntax clusters simplify these definitions by enabling you to have one cluster stand for several syntax groups. To define a cluster for the 2 items that the 3 groups contain, use the following command. Syntax cluster x state contains equals x number, x ident. Clusters are used inside other syntax items just like any syntax group. Their names start with @. Thus, you can define the 3 groups like this. Syntax match x4 /caret for period * contains equals @x state. syntax match x if /caret if period asterisk / contains equals at x state, syntax match x while /caret while period asterisk / contains equals at x state. You can add new group names to this cluster with the add argument, syntax cluster x state add equals x string. You can remove syntax groups from this list as well, syntax cluster x state remove equals x number. Chapter 44 Part 9, including another syntax file. The C++ language syntax is a superset of the C language. Because you do not want to write two syntax files, you can have the C++ syntax file read in the one for C by using the following command: runtime bang syntax c.vim. The runtime bang command searches runtime path for all syntax c.vim files. This makes the C parts of the C++ syntax be defined like for C files. If you have replaced the c.vim syntax file or added items with an extra file, these will be loaded as well. After loading the C syntax items, the specific C++ items can be defined. For example, add keywords that are not used in C. Syntax keyword cpp statement new delete this friend using. This works just like in any other syntax file. Now consider the Perl language. A Perl script consists of two distinct parts: a documentation section in pod format and a program written in Perl itself. The pod section starts with equals head and ends with equals cut. You want to define the pod syntax in one file and use it from the Perl syntax file. The syntax include command reads in a syntax file and stores the elements it defined in a syntax cluster. For Perl, these statements are as follows: syntax include add pod, sfile, p, h, pod.vim, syntax region perl pod start equals /caret equals head, /end equals /caret equals cut, / contains equals at pod. When equals head is found in a Perl file, the Perl pod region starts. In this region, the at pod cluster is contained. All the items defined as top-level items in the pod.vim syntax files will match here. When equals cut is found, the region ends and we go back to the items defined in the Perl file. The syntax include command is clever enough to ignore a syntax clear command in the included file, and an argument such as contains equals all will only contain items defined in the included file, not in the file that includes it. The sfile p h part uses the name of the current file, sfile, expands it to a full path p, and then takes the head h. This results in the directory name of the file. This causes the pod.vim file in the same directory to be included. Chapter 44 Part 10, Synchronizing. Compilers have it easy. They start at the beginning of a file and parse it straight through. Vim does not have it so easy. It must start in the middle, where the editing is being done. So how does it tell where it is? The secret is the syntax sync command. This tells Vim how to figure out where it is. For example, the following command tells Vim to scan backward for the beginning or end of a C-style comment and begin syntax coloring from there. Syntax sync C comment. You can tune this processing with some arguments. The min-lines argument tells Vim the minimum number of lines to look backward, and maxLine tells the editor the maximum number of lines to scan. For example, the following command tells Vim to look at least 10 lines before the top of the screen. Syntax sync C comment min-lines equals 10, maxLines equals 500. If it cannot figure out where it is in that space, it starts looking further and further back until it figures out what to do. But it looks no further back than 500 lines. A large maxLine slows down processing. A small one might cause synchronization to fail. To make synchronizing go a bit faster, tell Vim which syntax items can be skipped. Every match and region that only needs to be used when actually displaying text can be given the display argument. By default, the comment to be found will be colored as part of the comment syntax group. If you want to color things another way, you can specify a different syntax group. Syntax sync C comment X alt comment. If your programming language does not have C-style comments in it, you can try another method of synchronization. The simplest way is to tell Vim to space back a number of lines and try to figure out things from there. The following command tells Vim to go back 150 lines and start parsing from there. Syntax sync min lines equals 150. A large min lines value can make Vim slower, especially when scrolling backwards in the file. Finally, you can specify a syntax group to look for by using this command. Syntax sync match sync group name / group here group name pattern. This tells Vim that when it sees pattern, the syntax group named group name begins just after the pattern given. The sync group name is used to give a name to the synchronization specification. For example, the sh scripting language begins an if statement with if and ends it with fi. If open square bracket -- f file.txt close square bracket semicolon then echo file exists fi. To define a group here directive for this syntax, you use the following command. Syntax sync match sh if sync group here sh if / less than if / greater than . The group there argument tells Vim that the pattern ends a group. For example, the end of the if/fi group is as follows. Syntax sync match sh if sync group there none / less than fi / greater than . In this example, the none tells Vim that you are not in any special syntax region. In particular, you are not inside an if block. You also can define matches in regions that are with no group here or group there arguments. These groups are for syntax groups skipped during synchronization. For example, the following skips over anything inside curly braces, even if it would normally match another synchronization method. Syntax sync match x special / open curly brace period * close curly brace /. More about synchronizing in the reference manual, syn-sync. Chapter 44, Part 11, Installing a syntax file. When your new syntax file is ready to be used, drop it in a syntax directory in runtime path. For Unix, that would be .config nvim syntax. The name of the syntax file must be equal to the file type with .vim added. Thus, for the X language, the full path of the file will be .config nvim syntax x.vim. You must also make the file type be recognized. See Chapter 43, Part 2. If your file works well, you might want to make it available to other Vim users. First, read the next section to make sure your file works well for others. Then email it to the Vim maintainer, maintainer@vim.org. Also explain how the file type can be detected. With a bit of luck, your file will be included in the next Vim version. Adding to an existing syntax file. We were assuming you were adding a completely new syntax file. When an existing syntax file works but is missing some items, you can add items in a separate file. That avoids changing the distributed syntax file, which will be lost when installing a new version of Vim. Write syntax commands in your file, possibly using group name from the existing syntax. For example, to add new variable types to the C syntax file, do :syntax keyword ctype off_t uint. Write the file with the same name as the original syntax file, in this case c.vim. Place it in a directory near the end of runtime path. This makes it loaded after the original syntax file. For Unix, this would be .config /nvim /after /syntax /c.vim. Chapter 44, Part 12, Portable Syntax File Layout. Wouldn't it be nice if all Vim users exchange syntax files? To make this possible, the syntax file must follow a few guidelines. Start with a header that explains what the system file is for, who maintains it, and when it was last updated. Don't include too much information about changes history, not many people will read it. Example: Vim syntax file, language C, maintainer Bram Moulinar, bram@vim.org, last change 2001 June 18, remark included by the C++ syntax. Use the same layout as the other syntax files. Using an existing syntax file as an example will save you a lot of time. Choose a good descriptive name for every syntax file. Use lowercase letters and digits. Don't make it too long, it is used in many places. The name of the syntax file name.vim, file type, b:current_syntax, and the start of each syntax group, name time, name statement, name string, etc. Start with a check for b:current_syntax. If it is defined, some other syntax file earlier in runtime path was already loaded. If exists, b:current_syntax, finish and if. Set b:current_syntax to the name of the syntax at the end. Don't forget that included files do this too. You might have to reset b:current_syntax if you include two files. Do not include anything that is a user preference. Don't set tab stop, expand tab, etc. These belong in a file type plugin. Do not include mappings or abbreviations. Only include setting is keyword if it is really necessary for recognizing keywords. To allow users select their own preferred colors, make a different group name for every kind of highlighted item. Then link each of them to one of the standard highlight groups. That will make it work with every color scheme. If you select specific colors, it will look bad with some color schemes. And don't forget that some people use a different background color or have only 8 colors available. For the linking, use high def link so that the user can select different highlighting before your syntax file is loaded. Example, high def link name string, string, high def link name number, number, high def link name command, statement, etc. Add the display argument to the items that are not used when syncing to speed up scrolling backwards, and Ctrl L. Select your language, locale. The messages in Vim can be given in several languages. This chapter explains how to change which one is used. Also, the different ways to work with files in various languages is explained. Chapter 45, Part 1. Language for messages. When you start Vim, it checks the environment to find out what language you are using. Mostly this should work fine, and you get the messages in your language if they are available. To see what the current language is, use this command, :language. If it replies with C, this means the default is being used, which is English. What if you would like your messages in a different language? There are several ways. Which one you should use depends on the capabilities of your system. The first way is to set the environment to the desired language before starting Vim. Example for Unix. Invlang equals d_d.iso_8859-1vim. This only works if the language is available on your system. The advantage is that all the GUI messages and things in libraries will use the right language as well. A disadvantage is that you must do this before starting Vim. If you want to change language while Vim is running, you can use the second method, :language fr_fr_iso_8859-1. This way you can try out several names for your language. You will get an error message when it's not supported on your system. You don't get an error when translated messages are not available. Vim will silently fall back to using English. To find out which languages are supported on your system, find a directory where they are listed. On my system, it is user share locale. On some systems, it's in user lib locale. The manual page for set locale should give you a hint where it is found on your system. Be careful to type the name exactly as it should be. Upper and lowercase matter, and the dash and underscore characters are easily confused. You can also set the language separately for messages, edited text, and the time format. See :language. Do-it-yourself message translation. If translated messages are not available for your language, you could write them yourself. To do this, get the source code for Vim and the GNU getText package. After unpacking the source, instructions can be found in the directory source po readme.txt. It's not too difficult to do the translation. You don't need to be a programmer. You must know both English and the language you are translating to, of course. When you are satisfied with the translation, consider making it available to others. Upload it to github.com/vim/vim, or email it to the Vim maintainer, maintainer@vim.org, or both. Chapter 45, Part 2. Language for menus. The default menus are in English. To be able to use your local language, they must be translated. Normally, this is automatically done for you if the environment is set for your language, just like with messages. You don't need to do anything extra for this, but it only works if translations for the language are available. Suppose you are in Germany with your language set to German, but prefer to use file instead of German word for file, I suppose. You can switch back to using the English menus this way: set language menu equals none. It is also possible to specify a language: set lang menu equals nl_nl.iso_8859-1. Like above, differences between dash and underscore matter. However, upper and lowercase differences are ignored here. The lang menu option must be set before the menus are loaded. Once the menus have been defined, changing lang menu has no direct effect. Therefore, put the command to set lang menu in your vimrc file. If you really want to switch menu languages while running Vim, you can do it this way: $source $vim runtime del menu.vim, set lang menu equals de_de.iso_8859-1, source $vim runtime menu.vim. There is one drawback: all menus that you defined yourself will be gone. You will need to redefine them as well. Do it yourself with menu translation. To see which menu translations are available, look in this directory: $vim runtime lang. The files are called menu_language.vim. If you don't see the language you want to use, you can do your own translations. The simplest way to do this is by copying one of the existing language files and change it. First, find out the name of your language with the :language command. Use this name, but with all letters made lowercase. Then copy the file to your own runtime directory as found early in runtime path. For example, for Unix, you would do :bang cp $vim runtime lang menu_ko_kr.euckr.vim ~config nvim lang menu_nl_be.iso_8859-1.vim. You will find hints for the translation in $vim runtime lang readme.txt. Chapter 45, Part 3. Using another encoding. Vim guesses that the files you are going to edit are encoded for your language. For many European languages, this is Latin 1. Then each byte is one character. That means there are 256 different characters possible. For Asian languages, this is not sufficient. These mostly use a double byte encoding, providing for over 10,000 possible characters. This still isn't enough when a text is to contain several different languages. This is where Unicode comes in. It was designed to include all characters used in commonly used languages. This is the super encoding that replaces all others, but it isn't used that much yet. Fortunately, Vim supports these three kinds of encodings, and with some restrictions, you can use them even when your environment uses another language than the text. Nevertheless, when you only edit files that are in the encoding of your language, the default should work fine and you don't need to do anything. The following is only relevant when you want to edit different languages. Using Unicode in the GUI. The nice thing about Unicode is that other encodings can be converted to it and back without losing information. When you make Vim use Unicode internally, you will be able to edit files in any encoding. Unfortunately, the number of systems supporting Unicode is still limited. Thus, it's unlikely that your language uses it. You need to tell Vim you want to use Unicode and how to handle interfacing with the rest of the system. Let's start with the GUI version of Vim, which is able to display Unicode characters. This should work. :set encoding equals UTF-8, :set GUI font equals -misc -fixed -medium -r -normal -18 -120 -100 -100 -c -90 -ISO 10646-1. The encoding option tells Vim the encoding of the characters that you use. This applies to the text and buffers, files you are editing, registers, Vim script files, etc. You can regard encoding as the setting for the internals of Vim. This example assumes you have this font on your system. The name in the example is for the X window system. This font is in a package that is used to enhance Xterm with Unicode support. For Microsoft Windows, some fonts have a limited number of Unicode characters. Try using the Courier New font. You can use the Edit Select Font menu to select and try out the fonts available. Only fixed width fonts can be used though. Example, set GUI font equals courier_new H12. If it doesn't work, well, try getting a font pack. Now you have told Vim to use Unicode internally and display text with a Unicode font. Using Unicode in a Unicode terminal. There are terminals that support Unicode directly. The standard Xterm that comes with X386 is one of them. Let's use that as an example. First of all, the Xterm must have been compiled with Unicode support. Start the Xterm with the -U8 argument. You might also need to specify a font. Example, Xterm -U8-FN -MISC-fixed -medium -R -normal -18 -120 -100 100 C -90 ISO 10646-1. Now you can run Vim inside this terminal, using Unicode in an ordinary terminal. Suppose you want to work with Unicode files. You don't have a terminal with Unicode support. You can do this with Vim, although characters that are not supported by the terminal will not be displayed. The layout of this text will be preserved. Try editing a file with Unicode characters in it. You will notice that Vim will put a question mark or underscore or some other character in places where a character should be that the terminal can't display. Move the cursor to a question mark and use this command, GA. Vim will display a line with the code of the character. This gives you a hint about what character it is. You can look it up in a Unicode table. You could actually view a file that way if you have lots of time at hand. Note, since encoding is used for all text inside Vim, changing it makes all non-ASCII text invalid. You will notice this when using registers and the shader-file. Example, a remembered search pattern. It's recommended to set encoding in your vimrc file and leave it alone. Chapter 45, Part 4. Editing files with a different encoding. Suppose you have set up Vim to use Unicode and you want to edit a file that is in 16-bit Unicode. Sounds simple, right? Well, Vim actually uses UTF-8 encoding internally. Thus, the 16-bit encoding must be converted since there is a difference between the character set Unicode and the encoding UTF-8 or 16-bit. Vim will try to detect what kind of file you are editing. It uses the encoding names in the File Encodings option. When using Unicode, the default value is UCS-BOM, UTF-8, Latin1. This means that Vim checks the file to see if it's one of these encodings. UCS-BOM file must start with a byte order mark or BOM. This allows detection of 16-bit, 32-bit, and UTF-8 Unicode endings. UTF-8 Unicode. This is rejected when a sequence of bytes is illegal in UTF-8. Latin1. The good old 8-bit encoding always works. When you start editing that 16-bit Unicode file and it has a BOM, Vim will detect this and convert the file to UTF-8 when reading it. The file encoding option, without S at the end, is set to the detected value. In this case, it is UTF-16LE. That means it's Unicode, 16-bit, and little endian. This file format is common on Microsoft Windows, example for registry files. When writing the file, Vim will compare file encoding with encoding. If they are different, the text will be converted. An empty value for file encoding means that no conversion is to be done. Thus, the text is assumed to be encoded with encoding. If the default file encodings value is not good for you, set it to the encodings you want Vim to try. Only when a value is found to be invalid will the next one be used. Putting Latin1 first doesn't work because it is never illegal. An example to fall back to Japanese when the file doesn't have a BOM and isn't UTF-8, do set file encodings equals UCS-BOM, UTF-8, SJIS. See encoding-values for suggested values. Other values may work as well. This depends on the conversion available. Forcing an encoding. If the automatic detection doesn't work, you must tell Vim what encoding the file is. Example, :edit ++enc equals koi8-r russian.txt. The ++enc part specifies the name of the encoding to be used for this file only. Vim will convert the file from the specified encoding, Russian in this example, to encoding. File encoding will also be set to the specified encoding, so that the reverse conversion can be done when writing the file. The same argument can be used when writing the file. This way you can actually use Vim to convert a file. Example: :write ++enc equals utf-8 russian.txt. Note: conversion may result in lost characters. Conversion from an encoding to Unicode and back is mostly free of this problem, unless there are illegal characters. Conversion from Unicode to other encodings often loses information when there was more than one language in the file. Chapter 45, Part 5. Entering language text. Computer keyboards don't have much more than 100 keys. Some languages have thousands of characters. Unicode has over 100,000. So how do you type these characters? First of all, when you don't use too many of these special characters, you can use digraphs. This is already explained in Chapter 24, Part 9. When you use a language that uses many more characters than keys on your keyboard, you will want to use an input method, or IM. This requires learning the translation from typed keys to resulting character. When you need an IM, you probably already have one on your system. It should work with Vim like with other languages. Key maps. For some languages, the character set is different from Latin, but uses a similar number of characters. It's possible to map keys to characters. Vim uses key maps for this. Suppose you want to type Hebrew. You can load the key map like this: :set keymap equals Hebrew. Vim will try to find a keymap file for you. This depends on the value of encoding. If no matching file was found, you will get an error message. Now you can type Hebrew in insert mode. In normal mode, and then typing a : command, Vim automatically switches to English. You can use this command to switch between Hebrew and English. Control-. This only works in insert mode and command line mode. In normal mode, it does something completely different, jumps to alternate file. The usage of the key map is indicated in the mode message, if you have the show mode option set. In the GUI, Vim will indicate the usage of key maps with a different cursor color. You can also change the usage of the key map with the im-insert and im-search options. To see the list of mappings, use this command: :lmap. To find out which key map files are available in the GUI, you can use the Edit Key Map menu. Otherwise, you can use this command: :echo glob path &rtp keymap /*vim. Do-it-yourself key maps. You can create your own key map file. It's not very difficult. Start with a key map file that is similar to the language you want to use. Copy it to the keymap directory in your runtime directory. For example, for Unix, you would use the directory .config nvim keymap. The name of the keymap file must look like this: keymap_name.vim or keymap_name_encoding.vim. Name is the name of the keymap. Choose a name that is obvious, but different from existing keymaps, unless you want to replace an existing keymap file. Name cannot contain an underscore. Optionally, add the encoding used after an underscore. Examples: keymap hebrew.vim, keymap hebrew_utf-8.vim. The contents of the file should be self-explanatory. Look at a few of the keymaps that are distributed with Vim. For the details, see mbyte-keymap. If all other methods fail, you can enter any character with Ctrl-V. So we have 3 columns: encoding, type, and range, and we have 8-bit, Ctrl-V 123, decimal 0-255, 8-bit, Ctrl-V XA1, hexadecimal 00-FF, 16-bit, Ctrl-V U013B, hexadecimal 0000-FFFF, 31-bit, Ctrl-V uppercase U 001303A4, hexadecimal 0000000, 7 FFFFFF. don't type the spaces. See I_control-V_digit for the details. Copyright. See manual-copyright vim:78:TS=8:no_et:FT=help:"no_RL:" Good morning. I assume you've been sleeping throughout this entire thing. I hope you slept well. I hope you had either a bunch of really nice dreams, or maybe you had a lovely dreamless sleep. Who knows? If you're one of the handful of weirdos who've listened to this entire thing, congratulations. You have won the prize of autism. Oh, this was so much work. If you appreciate the work that I've done, make sure to leave a like and subscribe for more mega autistic content. See you in the next one. Bye-bye.